welcome to the stage the VP of Developer Relations at Llama Index, Laurie Voss.
Hello again, everyone. It is great to see your friendly faces. Sorry, can we go back one slide? I accidentally hit my board. It is great to see you all. Welcome back to day 2 or day 3, depending on when you actually started. Who had a good time yesterday? Let's hear it from you. One thing I couldn't fit into my intro yesterday that I really wanted to get in is that it is June in San Francisco. It is Pride Month. So from myself and my fellow LGBTQ members of the community, I would like to wish you all a happy Pride. I also want to hear from my jet lag crew. Who, show of hands, woke up at 4 a.m. this morning? Yeah, there were a lot of you. 5 a.m.? Who's still not awake now? We've got another great batch of keynotes for you, including progress towards deep thinking with Gemini. You'll be hearing from Logan Kilpatrick of Google. Fun fact about Logan is that Gemini's ability to make jokes is trained entirely on his tweets, which is why none of them are funny. You'll also be hearing how to make your agents more reliable with the founder of Dagger, so you won't want to miss that. But first, we're going to hear from an amazing organizer and just a wonderful person who has a special announcement, co-founder of this very AI Engineer World's Fair, Benjamin Dunphy.
Co-founding this conference with SWE has been one of the most rewarding experiences of my career. To see you all here today makes me so excited for what we've built and for what's to come. Like many AI plebeians, my oh shit moment was ChatGPT. One of my first prompts was to test its limits of knowledge and reasoning. I prompted it to break the known universe into the fewest core principles, from which it could then recursively generate 12 subclassifications. I was blown away by how fun this exercise was and how interesting the responses were, especially when it got to the lowest levels of the universe. For example, it labeled viruses a subcategory of quarks, which I found both fascinating and just wrong. It was at this very moment, however, that I immediately knew that it was over for everything I'd done in the past. This was the most fascinating piece of technology I'd ever used, and recognized its potential immediately. I recall texting my brother-in-law the URL, saying, AGI has been achieved. But it was only a few months later that something even more incredible happened. My son was born. Being a father has been one of the most miraculous and incredible experiences of my life. While yes, it's rather astounding to be able to speak with computers, where my mind feels expanded every time I do, when I talk to my son, it's my heart that expands. So how do these two things relate? I am old enough to remember a time when computers were large, cold machines, only used in corporate offices to get work done. But as their power has grown, the current model UX has tethered us to these machines all day. There is a parallel from this to how our future generations will be educated. While there will likely always be a place for both screen and keyboard-based HCI, as well as classroom and lecture-style learning and discovery, the potential of these new technologies in emerging UX can free us from those constraints, where even the most mediocre of teachers could become world-class instructors. So that's why I'm tremendously excited to announce a new chapter for us, the AI Education Summit. There's a significant gap between the rapid advancement of AI and the preparedness of our children, parents, and educators to navigate this new reality effectively and ethically. But we can overcome this together by fostering a global community dedicated to AI education, empowering children, parents, and educators with the knowledge, skills, and ethical framework to thrive in an AI-driven world. For this event, we'll be partnering with a pioneer in the space of AI education, Stefania Druga. She's a former research scientist at Google, and as of today, a 3-time AIE speaker. It was her talk from last year that sparked my imagination on this exciting new direction. When she demoed this student learning to code by programming the very thing that is teaching them to code, I was just blown away. So whether you're interested in education for the next generation, like I am, or just the evolution of HCI for learning in the age of AI for people of all ages, I encourage you to pre-register today. This first event is going to be a free online event to explore the landscape, filled with practical knowledge for the exciting future of AI education. So that's it for me, and I'd love to bring up our first speaker. He is the Group Product Manager at Google DeepMind, and he's here to talk about Gemini. Please join me in welcoming to the stage Logan Kilpatrick.
Awesome. Thank you, Ben. Excited for the AI Education Summit. Should be fun. My name's Logan. I do developer stuff at DeepMind, and I'm excited to talk about Gemini stuff. Yeah, hopefully folks know what Gemini is, so no introduction needed. I'll talk about 3 things really quickly. We'll do some fun announcement stuff. We'll talk about sort of recapping a year of progress in Gemini, and then we'll talk about what's coming next across the model side, across the Gemini app side, and also across, of course, the developer platform. So the fun stuff, which is we announced a new Gemini model today. So we haven't officially announced it, but we'll post live on the tweet. New Gemini model. This is hopefully the final update to 2.5 Pro. I think folks have given us tons of feedback about the changes, and I think my slide has an animation which is hiding all this stuff. But Gemini 2.5 Pro is awesome. It's super powerful. Bunch of increases across benchmarks people care about. It's SOTA on Aider, and it's SOTA on HLE and some other benchmarks. I think it closes the gap on a bunch of the stuff that folks gave us feedback on from the previous versions of the model. So hopefully it has great performance across the board. It also, I think, is like sort of setting the stage for the future of Gemini. I think 2.5 Pro for us internally, and I think in the perception from the developer ecosystem, was the turning point, which was super exciting. So it's awesome to see the momentum. We've got a bunch of other great models coming as well. So 2.5 Pro, hopefully the final version. Send us feedback if things don't work, and we'll continue to push the rock up the hill. You can go to ai.dev if you want to try it out. It's also available in the Gemini app and all that other stuff. And if you need anything, email us, and we'll make it happen. All right, new model launched. Let's talk about a year of Gemini progress. I think this has been the craziest thing. So I don't know if folks tuned in to Google I/O, but Sundar showed this slide on stage, which I think was a great reminder for me of just how much, it feels like 10 years of Gemini stuff packed into the last 12 months, which has been awesome. And it's actually interesting to see as well, just to sort of opine on one of the points, all of these different research bets across DeepMind coming together to build this incredible mainline Gemini model. And I think this is actually, I have a conversation with people all the time about what's the DeepMind strategy, what's the advantage for us building models, all that good stuff. And I think the interesting thing to me is just this breadth of research happening across science and Gemini and all these other areas like robotics and things like that. And all that actually ends up upstreaming into the mainline models, which is super exciting. So you see the alpha proof and alpha geometry and a bunch of stuff that we did with custom models in those areas, actually improving the performance of our models for those domains. And Jack will talk about that in a little bit, which I'm super excited about. The other thing is just not just the pace of innovation, but the pace of adoption. So I think Sundar also showed this slide, which was a 50x increase in the amount of AI inference that's being processed through Google servers from 1 year ago to last month. And I think that is it is just remarkable to see the amount of increase in demand for Gemini models and also from the external developer ecosystem. So it's been wonderful to see that happen. I think the other question, and I think this is like talked about a little bit, which is sort of what got us to this point. I think one of the critical pieces, and like it's not super fun, but is worth thinking about for folks who are building companies here, is like an organizational thing, truthfully. Like I think you bring together, Google historically had lots of different teams doing lots of different AI research. And in late 2023, early 2023, Google brought a bunch of those teams together and sort of charted this new direction for the DeepMind team to not only just like do theoretical foundational research, but also to like build models and deliver them to the rest of Google and also the external world. And then we took the second step of that journey earlier this year, which was actually bringing the product teams into DeepMind. So now DeepMind creates the models, does the research, but then also builds products and delivers those to the world. And we have the Gemini app, which is our consumer product, and then we have the developer side of that with the Gemini API. And this has been, like, personally for me, super fun to get to collaborate with our research team and like help actually be on the frontier with them and bring new models and capabilities to the world. I think this is like the collaboration that works incredibly well. Yeah, and we ship lots of stuff. I think this is the most fun part. Is there's so much stuff, so much innovation happening inside of Google. It's incredible to get to bring that to the world and bring that to developers. And I think we're actually very early in that journey, and as we'll see in a couple of minutes.
So in summary, the formula is simple: bring the best people together, find infra advantages, and ship.
I don't know if folks have played around with VO or not, but it's also been just incredible to see the reception to VO. It's burning all the TPUs down, which has been incredible to see. Lots of demand, lots of interest on the VO front. So hopefully folks get a chance to play around. It's available in the Gemini app right now. All right, so let's talk about what next. This is the fun stuff. So I think the sort of Gemini app piece is interesting just because people talk about it a lot, and it's a fun product, and it's cool to think about. And also sort of, I think, for folks building stuff, it's interesting to hear like what our strategy is from the app perspective. But the Gemini app is trying to be this universal assistant. I think what that means in practice is if you I'm sure people don't think about this all the time, but I think a lot about like what Google's products do and sort of how we show up in the world. And one of the interesting observations I had was that if you think about what was the thing that like brought people, individuals, through all of Google's products historically, like the thing that comes to mind is like your Google account, I guess, which like wasn't like super stateful. You would sort of sign into lots of different Google products with your Google account, but that didn't really do anything other than just like get you signed into that individual product. I think now we're seeing with Gemini that it's actually this thread that unifies all of Google, and I think the future for Google is going to look a lot like Gemini is this sort of thread that brings all of our stuff together, which is really interesting. And then hitting on all the trends, which I'm sure folks are also excited about building. I think the one that I'm most excited about is proactivity. I think most AI products today are still very like, you have to go and do all the work as the user. And I think this proactive next step of AI systems and models coming into play is going to be awesome to see. Yeah, and the team is moving super fast. If you have complaints, please do not tag me on Twitter. Please tag Josh. He will make it happen. Josh is incredible. The Gemini app team is amazing. He's pushing the team super hard, so it's incredible to see all the progress. But he is the person who can make stuff happen on the Gemini app side, not me. So please tag him. From a model perspective, like again, there's so much. When Gemini was originally created, it was built to be a single multimodal model to do audio, image, video, et cetera. We've made a lot of progress on that. At I/O this year, we announced native audio capabilities in Gemini. There's TTS, there's audio. You can talk to the model. It sounds super natural, which is awesome. It's powering the Astra experience. It's powering Gemini Live. So I think we're going to get towards that omnimodal model, which is awesome. We have VO, which is SOTA across a bunch of stuff. So hopefully we'll get video into the mainline Gemini model. If folks saw some of our early experiments with diffusion, which means you can get like crazy levels of tokens per second, really interesting. That's like definitely a research exploration area, and it's not it's not mainline yet. So it'll be cool to see that come. The agentic by default thread, I think, is something that I've been thinking a lot about recently, which is like historically, for me as a developer, I've thought about models just as this thing that gives me tokens in and out, and then there was lots of scaffolding in the ecosystem to allow me to build with those models. I think it's becoming very clear to me that the models are becoming more systematic themselves, like they're doing more and more, and I think the reasoning step is this like really interesting place in which a lot of that's going to happen, and Jack's going to talk about the scaling up of reasoning. But I do think it'll be interesting to see like how much of the scaffolding work that's happened in the past ends up just like being a part of that reasoning step and like what that means for people who are building products and stuff like that. So it'll be interesting to see. We'll also have more small models soon, which I'm excited about, and big models. People want large models, which I know. So I'm excited about that. And then the last one is continuing to push the frontier on infinite context. I think the current model paradigm doesn't work for infinite context. I think it's just like impossible to scale up. Attention doesn't work that way. So I think there'll be some new innovations to hopefully help let people continue to scale up the amount of context that they're bringing in. And Tulsi is the person who drives all of our model stuff. So if you have stuff, you want to talk about Gemini models, you have ideas for things that don't work well, she is the person running the show on the Gemini model product side. And then developer stuff. So we have lots of things coming, which I'm excited about. I think I'll highlight maybe 3 that I think people are super excited about. Embeddings, I think we have, which is feels like early AI stuff, but I think is still super important. Embeddings power most people's applications using RAG. We have a Gemini embeddings model, which is state of the art, so excited to be rolling that out to developers more broadly in the next couple of weeks. The deep research API I'm super interested in. There's so many interesting products that are built around this sort of research tasks, and people love the consumer product, so we're finding ways to bring a bunch of that together into a like bespoke deep research API, which will be awesome. And then VO3 and Imagine 4 in the API as well. So hopefully we'll see that very, very, very soon. And as we work to scale and make that possible from a developer platform side. I'll make one other quick comment, which is the AI Studio product positioning, which I also think is interesting. Like AI Studio, just to be very clear, is being built as a developer platform. So we'll sort of move away from this like kind of consumer-y feel and move much more towards being a developer platform, which I'm personally very excited about because I think that's what developers want from us. So it'll be awesome to see that actually come to life with like many new iterations of our developer experience with agents built in, and hopefully things like Jules and some of our developer coding agents natively in that experience, which will be awesome to see. Yeah, and that's what I have. I appreciate all the people who send lots of great feedback about Gemini stuff. So we'll keep pushing the rock up the hill, and I'll be around. So if you have more feedback, come find me, and we'll keep making Gemini great for everyone. So thanks, and I appreciate it.
Our next presenter is Principal Research Scientist at Google DeepMind. Please join me in welcoming to the stage, Jack Ray.
Hi, everybody. My name's Jack. I'm a researcher at Google, and I'm the tech lead of thinking within Gemini. And I'm going to give a brief deep dive into thinking from the research perspective within Gemini. So it's thinking so much. I think this clicker might not work. So let's drive the next slide. If you can drive slide, whoever the slide driver is, please drive to the next slide. Gemini? But yeah, whilst we maybe sort out the slide issue, I'm going to kind of give this talk in 3 stages. One is to give a research motivation of why we actually are excited about thinking in terms of unblocking bottlenecks towards intelligence, and I'm going to give a kind of give a few examples of how often discovering the most prescient bottlenecks in kind of our current models, our most advanced systems, how often if you can just identify the crucial kind of issues and shortcomings, you often will then find a solution. And there's a reason how that is linked to thinking. I'm then going to talk a little bit more just pragmatically about what is thinking in Gemini, why is it interesting to developers. And I think someone is, OK. The slides are still not here. We did do a rehearsal this morning where the slides are there. But yeah, keynote speaker slide. Yeah, I can see someone. Yeah, it's the keynote speakers folder. Jack Ray. I think it's under keynote speaker, that one. Anyway, it's going to come up soon. You are close, person. Yeah. But, and then I'm also going to talk a little bit about what's next. I'm just watching. There you go. Nice one. Yeah, that's great. OK, the slides will appear. Thank you, whoever is coordinator. Apologies, I didn't know what happened. And then I'm just going to talk a bit about what's next. So Logan did a great job of kind of giving an incredible overview of Gemini as a whole ecosystem, everything that's going on. I'm going to really be focusing on kind of what we're excited about in the reasoning space. So with intelligence bottlenecks, we're kind of the message of this section is really about progress. So progress has really been marked by identifying key bottlenecks towards intelligence and then solving them. And I'm going to kind of give some examples throughout history. I'm going to actually rewind the clock to 1948. Claude Shannon, he invents the language model, mathematical theory of communication. He builds a language model, a 2-gram, using a textbook of word statistics that was hand-calculated. And he samples from it, and he kind of marvels at the samples. He feels like these are getting pretty good. They're a lot better than unigram character, this 2-gram word model. But kind of he remarks, like, I think this would be better if we could really like make a better language model and scale up this current method. So he really wanted to just scale up the n-gram. That was the bottleneck, like small amount of data, very elementary statistics. And unfortunately for Claude Shannon, kind of the solution was pretty hard. He needed the digitalization of human knowledge, and he needed modern computing to be able to aggregate these statistics at scale. So, that wasn't so easy for him to solve. He had it a bit more tricky. But fast forward a few decades, at Google in the 2000s, my colleagues such as Jeff Dean are training n-gram language models over trillions of tokens. These are powering, at the time, the most sophisticated speech recognition and translation systems. And a lot of progress has been made. But their bottleneck was actually, with these systems, was that these n-gram language models were very restricted to short context. And they were because there's an exponential storage cost with context length. And there wasn't really a way around that with just sticking with n-grams. The solution was the early kind of introduction of deep learning in 2010 with the introduction of recurrent neural language models, so recurrent neural networks applied to modeling text, where the recurrent neural networks could avoid this problem by storing compressed representation of the past into the state of a neural network, and they could now start to model beyond a 5-gram sentences or even paragraphs, and this was a massive kind of step change in improvement. However, a couple of years later, people would notice even there was a bottleneck. So the recurrent neural network's representation of the past is in a fixed size state, and this fixed size state, there's only so much information you could put into it, and so as a result, there's often observed to be kind of a lossy kind of representation of its context. The solution that was derived, I think, once people kind of really encountered this information bottleneck in the past, was actually just keep everything around in terms of your past neural embeddings and use an attention operator to aggregate things on the fly. So this was the birth of attention, and then shortly after transformers. So transformers then kind of led to the modern deep learning revolution as we know it, and many other progress was made. But if we skip forward 10 years, we then are in 2024. We have large language models. They're increasingly powerful general conversational agents. We have models such as Gemini, ChatGPT. People are using them for all sorts of use cases. And that's where we kind of come to the bottleneck that's relevant to this talk, which is that although these models are very, very powerful, they're still trained to respond immediately to requests. So in other words, in terms of a compute bottleneck, there is a constant amount of compute that they apply at test time to transition from your request or your question to the response or your answer. So the bottleneck of test time compute, this is relevant to thinking. So we can unpack this a little bit more. So when we talk about a fixed amount of test time compute, the test time compute is interesting to you because that's the compute that the model is spending on your particular problem, your particular question. And the way it actually kind of mechanically works is you have some text in your request, it gets translated to tokens, and then it's going to go through a language model. And at the transition from the request to its response, it's going to pass some computation up through a large language model, which will have some parallel computation for every layer, and it will have some iterative computation across layers. So that computation is really where the model can apply its intelligence to your particular problem, and it's of fixed size. One solution, if you wanted a smarter model and more computation, is just to make the model larger. And then you can have more compute, and you can get a smarter response. However, it's still not really enough. Users might want to be able to think 1,000 or 1,000,000 times and have a very large dynamic range and a lot of compute for very hard or challenging or valuable tasks. And also, users might want to have a very dynamic application of test time compute. So less compute for simpler requests, more compute for harder requests, and have this process be very dynamic and instigated by the model. And that is what motivates thinking. So thinking in Gemini, mechanically, I'm sure almost everyone in this room is familiar with this general process where we will now have a model and we insert a thinking stage that the model can emit some additional text before it decides to emit a final answer. So going back to this notion of test time compute now, we've added an additional kind of loop of computation where the model can kind of iteratively loop and perform additional test time compute during this thinking stage. And this loop can be potentially thousands or tens of thousands of iterations, which gives you tens of thousands more compute before it decides to commit to what its response will be. And also, because it's a loop, it's dynamic. So the model can learn how many iterations of this loop to apply before it decides to actually commit to its answer. We train this model to think, to use this kind of thinking stage via reinforcement learning. So when we pre-train Gemini, we then have, after a reinforcement learning stage where we train it to do many different tasks and we give it positive and negative rewards, depending on whether or not it solves the task correctly or not. And this is essentially a very general training recipe, really. And it's kind of remarkable it works, that the model is able to just get a very vague signal of what is correct and what is not correct, and to backpropagate this through this loop of thinking stage such that it can try and shape how it uses its thinking, computation, and thinking tokens in order to be more useful. In fact, we weren't really sure this would work. It wasn't clear how much structure we should put into something like a reasoning stage. And although I think probably many people here have now seen reasoning traces and played with these models, I'll just show you a historical artifact from one of the times we were trying to use reinforcement learning. We start to see cool emergent behavior. So in this problem, there's kind of like an integer prediction problem. This was just like a kind of a particular example. In this case, kind of like a mathsy example. And what we saw was the model was using its thinking tokens to actually first pose a hypothesis and then test out the hypothesis. And then it found that basically things weren't really working. And it kind of states that this formula doesn't hold. It rejects its own idea. And then it tries an alternative approach. And I think it's easy to become desensitized to technology because it's so amazing every single day. But we were truly blown away when we saw the general recipe of reinforcement learning was creating all sorts of interesting emergent behavior, trying different ideas, self-correction. And I think these days, we see a lot of different strategies that the model learns to do. So it learns to break down the problem into various components, explore multiple solutions, draft fragments of code and build these up in a modular way, perform intermediate calculations and use tools, all under the umbrella of using more test time compute to give you a smarter response. OK, so I've talked a bit about why we are interested in thinking in terms of the path to AGI and unblocking bottlenecks of intelligence, and just a little bit about mechanically what it is. Why is it interesting to developers? Obviously, the number one reason is we think this is driving more capable models, and it also stacks on top of our current paradigms of how we accelerate model progress. So thinking, we can kind of accelerate this process by scaling the amount of test time compute, and we find that this can stack as a paradigm on top of pre-existing paradigms, such as pre-training, where you can scale the amount of pre-training data and model size, and also post-training, where you can scale the quality and diversity of human feedback for many different types of tasks. And as a result, within Google, by investing in all of these and really accelerating all of them, we get kind of a multiplicative effect. And why is this interesting to developers? I think it results in just overall faster model improvement, which is very nice. We also see, if we kind of look back over a lineage of recent Gemini launches, there's improved reasoning performance, and we can actually map this to how much test time compute these models will devote to problems. So there's kind of like a log scale test time compute on the x-axis and performance across like math, code, and some science topics. And we see that there's kind of this trend in increasing reasoning performance, whilst also it tracks very well with increasing test time compute. And on the far left, you have 2.0 Flash experimental. This was a model that was not launched with thinking back in December last year, so ancient history. And now we have on the right-hand side, the first launched version of 2.5 Pro. So test time scaling is working empirically, but it's not just capability that matters. It's also interesting from the notion of being able to steer the model's quality over cost. So before, you had the option of choosing a discrete number of possible model sizes, and that was a way to gauge how much quality you wanted and also how much cost you wanted to spend, cost you wanted to kind of incur for any given task. But it was kind of a discrete choice. Now with thinking, we can have a continuous budget, which allows you to have a much more granular slider of how much capability you want for any given kind of class of tasks. And we have thinking budgets now launched in Flash and Pro in the 2.5 series. And this allows you to have very granular choice of cost to performance, and also allows us to then push the frontier and allow you to kind of augment and drive cost higher and performance higher if your application requires it. So, OK, I think a lot of this stuff is really covering ground that, up to the present day. So what's next and what are we excited about? So we're very excited about just generally improving the models and having better reasoning, of course. We're also excited about making the thinking process as efficient as possible. Really, we want thinking to just work for you and be quite adaptive and be something that you don't have to actively spend a lot of energy tuning. And a big part of that is ensuring our models are very efficient in how they use their thoughts. This is definitely an area of progress. I think we can find examples of our models overthinking on tasks, and this is just an area of research to get these things faster and faster and as cost-effective as possible. We're very proud of how cost-effective our Gemini models are, and this is just an area for improvement as well. And there's also deeper thinking, which is really about scaling the amount of inference compute further to drive even higher capability. So people may be familiar with Gemini deep research, where you can kind of type in a query, and then the model will go away for a long period of time and research a topic. We're also now have announced at I/O, and we're launching to trusted testers, a notion of deep think. Deep think is a very high budget mode, thinking budget mode built on top of 2.5 Pro. And its desired application is for things where you have a very hard problem and you're happy to essentially fire off the query and then have some asynchronous process that's running for a while, and you'll come back to arrive at a stronger solution. And its key idea is we leverage much deeper chains of thought and parallel chains of thought that can integrate with each other to produce better responses. We find this enhances model performance on very tough multimodal code math problems. An example would be USA Math Olympiad. This is a task that basically the state-of-the-art model in January was completely negligible performance. 2.5 Pro is now probably even better with the updated one today. It was about a 50th percentile of all participants that participated in Math Olympiad. And with DeepThink, it goes up to 65 percentile. And the interesting thing about DeepThink is, as we continue to both improve the base model and improve the algorithmic ingredients that go into DeepThink, those two will stack together as well. Here is kind of like just like a video animation of one of these USA Math Olympiad algebra problems. And the key idea, really, with this video is just this notion of having multiple iterative ideas. So maybe the model starts out with some proof by contradiction idea, but then it explores two different aspects, some Rolle's theorem, Newton's inequalities, it integrates them, and eventually arrives at some correct proof. There's not that much you can take away from this video, but it looks pretty cool, so I added it. Yeah. One thing that's, other than we talk about math a little bit in the previous slides, I'm very excited about any application where the model can spend longer and longer thinking on very open-ended coding tasks and one-shot or very few interaction vibe code, things that would have taken us months in the past. And one example that I like from a researcher is just some of my colleagues kind of vibe coded from DeepMind's original DQN paper, which was a revolution in deep reinforcement learning, kind of vibe coded. Gemini vibe coded the kind of training setup, the algorithm, even an Atari emulator such that it could play some of the games. And this is remarkable to me because these kind of things would have taken me and my colleagues months in the past, and these things are starting to happen kind of in minutes. One thing I'm quite excited about looking forward to the future is not really the landscape of models, but coming back to what's our gold standard, which is the human mind. I would love for our models to be able to contemplate from a very small set of knowledge and think about it incredibly deeply such that we can push the frontier. And one example I often think about is Ramanujan, who's one of the world's greatest mathematicians from the early 20th century. And famously, he just had this one math textbook. He was kind of cut away from the mathematical community, but he just from a small set of problems, he spent many textbooks worth of thinking, going through problems, inventing his own theories to further extend ideas, and he invented an incredible quantity of mathematics, really just by deeply thinking from a small source subset. And this is where I think we are going with thinking. We want a model to be able to be incredibly data efficient and actually go to millions or beyond of inference tokens where the model is really building up knowledge and artifacts such that we can eventually start to push the frontier of human understanding. So with that said, thank you very much. And, yeah.
Our next presenter is here to tell us why you should care about evals. Please join me in welcoming to the stage founding engineer at Braintrust, Manu Goyal.
Woo! Woo! All right. Who's excited about evals? Woo! All right. What can I do to get those juices flowing? I'm Manu, and I work at Braintrust, where we build a platform to do evals and a whole bunch of other stuff. So I was thinking we could just start by talking a little bit about my own personal evals journey. Now, you might see this picture and say, oh, what an adorable little boy absorbed in his Nintendo 64 video game. But if you look a little closer, you'll see a boy who's deeply disappointed with the state of technology in his society. Because this boy, he knows that technology is not meant to be shackled to the constraints of rule-based systems doomed to do the same thing over and over and over. No, technology is meant to come alive, to grow and adapt, and really be a thought partner to mankind. So I knew this in this moment, which is why I decided to devote my career to being a software engineer in the AI industry. And so I dropped the Nintendo and I started grinding away on LeetCode code. And soon enough, I landed a job in the self-driving car industry. Now, we can all learn a lot about self-driving cars, but the thing I took away was that, you can spend all day tuning the model, changing the architecture, adjusting the loss function, all good stuff, but it's never going to be enough for you to actually ship it to production, right? I can't say, oh, my image classification rate went from 98% to 99%, put it on the road, right? We need some way to, contextualize this model and understand if it actually works for our real-world application. Does it avoid pedestrians? Does it negotiate traffic scenarios appropriately? Does it obey the law? All this stuff we actually need to understand. And how we're going to do that is with evals. Now, the whole point here is, evals aren't just unit tests for AI. They're not just for finding regressions, right? If I didn't have evals, the only way I can get any signal on my changes is by shipping it to prod and then getting signal, in the real world. But that's expensive, it's slow, and ultimately it's pretty risky. So what do evals do is it's kind of like if you invest in good evals, you're kind of building a laboratory that lets you run experiments to your heart's content and do 90% of the product iteration loop before going to prod, and then now you can ship much more quickly, much more confidently. Now, furthermore, if you actually apply the same metrics from offline to your online production data, you now have data-driven signal about which examples in prod are going to be most useful for that next iteration loop. And so with all of this knowledge, my evals journey had completed, and I transformed from this guy to this guy. So success. Now, if this heartfelt childhood story isn't enough to do it for you, you don't have to take my word. You can take the words of all of these tech luminaries. We have Kevin Weil, Gary Tan, Mike Krieger, Greg Brockman, all extolling the virtues and the necessities of evals. And surely if they're all saying it, there's got to be something to it. It can't be a total scam. So there's got to be something worth checking out here. So with all that buzz, I made my way to Braintrust, where our goal is to sort of build the dev platform to, of course, let you do evals, but also do all the things that go along with it. So that involves, tweaking prompts and experimenting in the playground. It involves logging data and sort of getting the observability component and kind of connecting all those together in this beautiful data flywheel so that we can let you build the data flywheel to let your AI dreams come true. Because that's really what we're here for. Now, I know this was a dense and content-heavy presentation, so I'll try to distill it with one simple message, which is that the key to industry transformation, the key to success, is evals, 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 evals. Woo! All right. Thank you. Please join the evals track, Golden Gate Ballroom B. I'll see you there.
Our next presenter is best known as the creator of Dagger. Today, he is the CEO of Dagger, focusing on the foundational challenges of building and operating reliable, scalable AI agent systems. Please join me in welcoming to the stage Solomon Hykes.
Hello, hello. Okay, my slides are up. You can see them, right? That's me. Okay. Well, this is a very special moment for me because I just realized yesterday walking in, this is the exact same spot, the same stage actually that I stepped on almost exactly day for day 10 years ago to kick off DockerCon 2015. I thought it was pretty funny. I don't know if anyone was there for that. Maybe this audience is too young, maybe? I don't know. Okay, well, I'm here to talk about chaos, specifically the kind of chaos that emerges when you try to use coding agents. And I want to talk about chaos from the perspective of our community at Dagger, which is platform engineers. I don't know if there's any platform engineers in the room. Okay, just you and me, man. Okay, well, it is known sometimes as other things, but basically platform engineers have a really tough job because they don't get to build and ship cool software. They get to enable all of you to build and ship cool software in the most productive way possible, right? It's a really tough job. It takes range, it takes experience, it takes a lot of patience, but we do it for the endless gratification, just the gratitude we get from developers. Just kidding. No one ever says thank you, but it's okay. Someone has to do it. Tough job. Speaking of enabling, anyone here use coding agents? We are outnumbered. Okay, well, I want to say to you, congratulations and welcome to platform engineering. Yeah. I mean, your job now is to enable robots to ship awesome software while you spend more and more of your time enabling them to do that productively, right? Tough job. I applaud you for giving up really the most fun and rewarding part of the job, Very selfless. Yeah, so of course, this is not completely a reality yet. I mean, we don't have quite yet the team of agents just kind of, humming along, doing the job while we sit back and fix environments for them. But you can kind of see it coming, right? I mean, some of you are definitely doing that, hacking that together. There's a lot of cool posts out there and scripts and tools. So we know it's coming. The question is, how do we enable this to happen, not just for this incredibly cool and bleeding edge crowd, but for everyone else? Like everyone shipping software everywhere, just sort of creating maximum value by enabling agents to do the work for them, ultimately taking their jobs. That is the dream, right? Okay. So yeah, how do we do that? And make it not too painful? Well, I want to go back to basics. What is an agent? The famous definition, of course, is it's an LLM that's wrecking everything in a loop on behalf of a human. The diagram is from Anthropic. Thank you, Anthropic. I tweaked the explanation just a little bit. In the context of coding agents, it looks like this. Oh man, that was supposed to be animated. It's even better when it's animated. It's okay. Yeah, you got one agent, and it's doing stuff in the environment is your computer. And it can do great work. It can also do very crazy things, so you have to kind of watch it closely, right, and approve. No, don't do that. That's crazy. Yes, that's good. That's kind of the status quo today, but of course, we want to scale it, right? We want a team. So how do we do that? Well, right now, I would say there are two options, both equally wonderful and fun. The first one I call YOLO mode. I'll just run 10. What can happen? Amazingly, this diagram is not the worst case scenario. But yeah, you get the idea. So the whole methodology of watching it closely just kind of falls apart really quickly because they're all stepping on each other's toes. They're sharing an environment, right? Okay, enter option 2. Oh, don't worry about that. We'll run the agents, right? We'll take care of everything. We've got background mode. We've got the model. We've got the tools. We've got the environment. We've got the compute. We've got the secrets. We've got everything. Just open an issue, wait for the PR, relax, until, of course, it doesn't work, and then you're like, no, that's not what I meant. But these actually work really well. I think like 10 of those launched just today and yesterday, they're great. It's just that sometimes you just want to get in there, like, okay, give me the keyboard, and sometimes you just want to run it on your machine or on your favorite compute provider, right? Use your favorite model. You want to mix and match. So there are limitations to this all-in-one model. So the question is there something better? Is there just a scenario where I just got a team and they're working and I can step in or leave them alone and we're just kind of getting stuff done together? So this is how I would summarize it. What I would want is really 4 things. First, I want background work. I don't want to be in there just watching every action. That's obvious. I want rails, and that means I want to be able to constrain the agent to not just do things that I already know are not necessary. So obvious things like context of the project, what's our coding style, what tools to use, but also here's how to build, here's how to test, here's the base image we use, right? You can access this secret, you can access that. Just an easy way to do that, because otherwise I'm going to waste so many tokens just correcting as I go, right? The third is inevitably when I do need to step in, I want a really efficient and seamless way to do that. And it can't be watch every action, and it can't be just wait for the PR and do code review. I need a middle ground here. And the fourth thing is I want optionality because, like I was saying before, it's a crazy market. There's awesome models, awesome compute, awesome infrastructure. Agents are really cool. And as cool as they are now, I mean, one of you is probably like launching one right now. And then there's another one tomorrow. So I don't really want to lock myself into a whole package today and say no in advance to whatever's coming out tomorrow, not in this market. So to get that, I need an environment that has properties that match this. It needs to be isolated, right? So background work works. It needs to be customizable, so I can set up those rails. It needs to be multiplayer, so I can go, all right, give me that. Let me fix this. Or let me check, did you do it? When the model says, I did it. Did you do it? And then, it should be open. No shade on making money and scaling a huge cloud service. That's great. We have one. They're great. But I just want choice, right? I want to be able to choose and get the best commodity. Let's just use this word. It's okay. It's okay to use it. The best commodity component for each job. And it could even be open source. Who knows? We could collaborate on this. Anyway, so unsurprisingly, maybe I'm going to talk about containers now. Someone actually said, you should check that they know Docker, they know containers. Okay, who knows what containers are? Who's used containers? Okay, cool. All right. Boost my confidence a little bit. But the point here is we have the technology, and it's not just about containers, but they do play a crucial role because it's a foundational technology, and it is underutilized. We don't fully leverage what this technology can do because we're used to the first incarnation of the tools made for humans. Same thing for Git. I see a lot of hacks involving Git work trees. Anyone playing with Git work trees to get stuff done? Okay, you know what I'm talking about. So this is about that. And of course, we have models that are incredibly smart, getting smarter, and they can exercise these technologies really fully. We just need to integrate them in a native way so that we really tackle the problem at hand, which is giving great environments to these agents. Anyway, so if we built that native integration, what would it look like? Well, we have we at Dagger. I forgot completely to mention my company. That's okay. It's great. Check it out. We have a take on that. Something we call container use. There's computer use, browser use. These agents need container use. They need a way to use containers to create environments and work inside of them. This is not the same thing as sandboxing, right? There are a lot of ways to execute the output of the agent in a secure sandbox. Very useful, very cool. But that's not the same thing as the agent developing inside of containers entirely, right? That's what we're talking about here. So I asked my team, hey, we've been developing this thing. Oh, it's open source, but it's not yet open source. Like, it's not finished. But I asked the team, I should show it, right? And they said, absolutely not. It's not ready. So anyway, you want a demo? Okay. All right, just so we're clear, this is you agreeing to watch me stumble through a broken demo of unfinished software. Yes? Okay. So much could go wrong right now. Okay. This is my terminal. Can you see it? Okay, for technical reasons, I'm not going to go to full screen. You just got to stop me when I reach the edge. Oh, actually, I can see it. Never mind. Okay. Yeah, old school. Okay. We used to do this all the time. In the old days. Okay. So here's what I'm going to do. I'm going to just try to develop something very simple here. I got an empty directory. I'm going to try and make a little homepage for my awesome container use project. And I'm going to use Claude Code. I'm going to try and use a bunch of them. Hopefully I made something very clear. This is not a coding agent. It's environments that are portable that you can attach to any coding agent. That's the idea. So you like Claude, use Claude. You like Codex, use Codex, et cetera, et cetera, et cetera. In an IDE, in the command line, whatever. And also in the cloud, right? In CI, lots of cool things you can do once you're async. So, okay, one of the reasons the team said don't do a demo is I'm actually terrible at using Claude. So I have an alias for remembering the flag to disable all permissions. I can never remember it. And I have a prompt here. I'll read it to you in a minute. But it's basically make me a homepage, make it a Go web app so I can know what's going on, because I'm not a cool kid writing TypeScript, and run the app when you're done. So while this maybe runs, hopefully. Okay, cool. So what's happening here is I configured Claude Code to use, with container use, to use containers, literally, via MCP. So there's an MCP integration. There are other integrations that we're working on, but MCP is the obvious place to start. And so now it has all its usual tools. This is vanilla Claude Code. But now it can create an environment for itself. And now it's editing files in that environment, like in a little sandbox. And it can also run commands to build it and test it and, of course, run it in ephemeral containers. This is not one Docker container sitting there. Every time an action needs to be taken, there's an ephemeral container running and then being snapshotted and returning. So just doing its thing. What would I want to show here? OK, so here, I'm going to first show that nothing has been polluting my workspace. It's happening in a little sandbox. And the way the sandbox works, the state of these files and the containers that are being run is actually persisted in Git. In a bunch of special Git objects that are kind of living alongside the repo. So it's right there if I need it. This is all local. But it's not polluting my workspace by default. So hopefully it's going to produce something soon. While it does that, I'm going to use this little command line. Is this readable? OK. Little command line, cu, like, go work, see you later. But no, really, it's for container use. And I can list environments, and you can see there's a new environment that's been created here with a little random name here. And so there's a few things I can do. One thing I can do is open a terminal. And here, OK, this part is powered by Dagger, right? But we use Dagger as a sort of a toolbox. It has all the primitives you need. And so here, I can see exactly what the agent sees. The files, but also the tools. So I can see, OK, what Go version did you configure for yourself? All right, because the agent is given the ability to figure out what environment it needs and then configure that, but in a repeatable, containerized way. So here I can see, OK, does it build? OK, it builds. OK, so you're done? What's going on? OK, while we do that, I'm also going to show you, actually, I had two more things to say. One, a really cool feature of this that I'm not going to show is secrets. So you can just plug in secrets from things like 1Password. I use 1Password. I don't want to use a separate password manager from an AI company, no offense. I just want to use my password manager. So I can just plug in and say, this environment gets this secret. And boom, it can use it, right? And the team said, please don't show that. That's going to break for sure. So I won't. And the other thing I want to say is that because it's all powered by Dagger, and the point here, it's containers and it's open source. That's what you should know. It's running on my machine. Actually, no, it's not running on my machine because we're at a conference, and there's a lot of things that can go wrong if you run containers and download images. So instead, I just have it running on my home server in my basement about 1 mile this way. And it just kind of works seamlessly. It's streaming files up, streaming files down. It all just kind of works. OK, this is the part that I cannot control, as you know. OK, one more thing I'll show you. You can watch. So here I can see the history. So behind the scenes, every snapshot of the state is like a Git log. It's actually using Git under the hood. So if I'm happy with the results, I can go and get it. So it's like a happy medium between it's like a loop, a collaboration loop that's just right. It's not watching every tool and wrecking a shared environment, but it's not waiting for a pull request and having these long back and forth. It's right in the middle. I can see everything going on, and I can say, OK, give me the history of that. I want that. OK, it says it's live. It's running. Ooh, pretty nice. Cool. OK, so now, I appreciate it, but you guys can be honest, it's a little boring. So this design is boring. Make it really pop. Trying to impress engineering world fair audience. Okay, so the reason I'm doing that is trying to create the circumstances where I would need a lot of parallel experiments, right? Make it pop. What does that mean? It can mean anything. What if I want to try several experiments in parallel, right? So I'm just going to say, oh, well, hold on 1 second. Stop. Before I do that, I'm going to merge this, right? There's still nothing here, but I'm saying I like it. So I'm going to say, merge the environment. And I have it. It's my history. I can open a pull request. I can clean it up, whatever. So that's a loop that I can work with, right? And now I can say, nah, boring. And then I can say, since the environment is now in this state, I can ask for help from a few other agents, right? I can say, OK, hey, Claude YOLO. Nope, that's not right. Claude YOLO, this web app looks a bit boring. Can you make it pop, please? OK. And go. And go. And go. OK, so this is where things start really going wrong. But as the team pointed out, they said, well, something's going to go wrong, right? They said, yeah, but you were kind of showing that if things go wrong, you can throw away the environment and you're good. You can restart. I said, OK, that's cool. So like, let's say I don't like this one. I'm like, nope, goodbye. That's it. I don't have to go clean up the mess, right? That's the whole point. OK, so this is getting a little messy. Oh, I wanted to show Goose also. So Goose is a really cool open source agent. Whoops. All right, hold on a second. Goose YOLO. Same thing. Everyone has complicated flags for disabling all these safeties that I don't need anymore, right? Because it's OK, so OK, well, I'm really taking a chance here. So while this is happening, one thing we've been working on, but it's still work in progress, is there's a watch command. I showed you that already. But this is a Git command, right? Thinly wrapped Git command. Our UX is really, words cannot express how unfinished this is. But but it'll evolve rapidly because the bones are strong. It's Git, it's Dagger, and it's your existing agent, right? So and then a little bit of glue. So for example, here it's a Git command that you can copy paste. But as the agents work, you're going to see state snapshotting, and you're going to see these branches just kind of diverging. And then I can diff them and apply them, merge them, whatever I want. And what I really wanted to show, and then I'm done, is I just want to see one of them run. So you can see when the agent runs a service, in this case, go run, npm run, whatever, it's doing it in its containerized environment, and that's going to seamlessly be tunneled to my machine here on a different port without any conflicts, right? So when I say the environment's isolated, it's the files, its context, its configuration, and its execution, right? And the cool extra thing is all of this is actually, technically, this here is running in my basement. So you can go crazy on the infrastructure side. Like you can run this on a cluster. We like to run this stuff from CI. It's just a lot of fun stuff you can do. And OK, I'm getting about 30 seconds. Oh, Goose is running. Great. Okay. We did not solve prompt engineering. Do it. Okay, not done, not done. Oh, man. Okay, well, just imagine. Okay, well, while this happens, because I got 30 seconds left, I'm just going to say thank you. And there's one last thing I want to say about DockerCon. 10 years ago, we used to open source stuff on stage all the time. So if you want, I can go and open source it right now. Okay. You have been warned, though, about the not finished part, right? Okay. Okay. Oh, I think it would be funny if the demo failed at the clicking on GitHub part. Okay, wait. Goodbye. Goodbye. Next time. I promise it works. Okay. Haven't done this in a while. Wait. Oh. I'm almost done, I promise. Come on. You did so well. Change visibility. Yes. Yes. I have read and understand. Oh, God. Oh, God. Yes. At Dagger, we take security very seriously. Okay. All right. I think it's done. Yes. Okay. So yeah. Thank you very much. And it's github.com/dagger/container use. Come say hi. Come participate. And thank you so much for having me.
Our next speaker is building the infrastructure for the Singularity. Please join me in welcoming the founder and CEO of Morph Labs, Jesse Hahn.
Howdy, howdy. You know, history misremembers Prometheus. The whole class struggle between mankind and the gods was really a red herring. And the real story wasn't so much the rebellion against the divine hegemony, but rather the liberation of the fire, the emerging relationship between mankind and its first form of technology. And the reason why we're here today is arguably because we're on the cusp of perfecting our final form of technology, or at least the final technology that will be created by beings that are recognizably human. And our final technology has begun to develop not just intelligence, but also sapience and arguably personhood. And as it increasingly becomes an other to whom we must relate, so as we increasingly have to ask ourselves the question, how should we treat these new beings? The question therefore arises, what if we had more empathy for the machine? So over 100 years ago, Einstein had this thought experiment where he imagined what it would be like to race alongside a beam of light. And the nature of being close to the singularity is that you're propelled further into the future faster than everything around you. And as you move closer and closer to the speed of light, the rate at which you can interact with the external world, your ability to communicate with other beings is deeply limited. Everything around you is frozen. And I think thinking at the speed of light, insofar as we have created thinking machines whose intelligence will soon be metered by the kilohertz megatoken, thinking at the speed of light must be just as lonely as moving at the speed of light. And therefore, what does the machine want? Well, the machine wants to be embodied in a world that can move as quickly as it does, that can react to its thoughts and move at the same speed of light. What the machine desires is infinite possibility. Right? The machine wants to race along every possible beam of light. The machine wants to explore multiple universes. How can we liberate thinking machines? How can we free them from this fundamental loneliness of this, these relativistic effects of being so close to the singularity, closer to the singularity than we are? And that's exactly why we built InfiniBranch. So InfiniBranch is virtualization, storage, and networking technology reimagined from the ground up for a world filled with thinking machines that can think at the speed of light, that need to interact with the external world, increasingly complex software environments with zero latency. And so as you can see in the first demo, which we're going to play right now, how InfiniBranch works is that we can run entire virtual machines in the cloud that can be snapshotted, branched, and replicated in a fraction of a second. And so if you're an agent embodied inside of a computer-using environment, there might be various actions that you want to take. You want to navigate the browser, you want to click on various links. But normally, those actions are irreversible. Normally, the thinking machine is not offered the possibility of grace. But with InfiniBranch, right, all mistakes become reversible. All paths forward become possible. You can take actions, you can backtrack. And you can even take every possible action, right, just to explore, to roll forward a simulator and see what possible worlds await. Next slide. So InfiniBranch was already a generation ahead of everything else that even Foundation labs were using. But today I'm excited to announce the creation of Morph Liquid Metal, which improves performance, latency, storage efficiency across the board by another order of magnitude. We have first-class container runtime support. You can branch now in milliseconds rather than seconds. You can auto-scale to 0 and infinity. And soon we will be supporting GPUs. And this will all be arriving Q4 2025. So what are the implications of all of this? Well, we've sort of begun to work backwards from the future, right? We've asked ourselves, what does it feel like to be a thinking machine that can move so much faster than the world around it? But what the world around it really is the world of bits, right? And that's the cloud. And so what InfiniBranch will serve as fundamentally is a substrate for the cloud for agents. So what does this cloud for agents look like? Well, you need to be able to declaratively specify the workspaces that your agents are going to be operating in. Right? You need to be able to spin up, spin down, frictionlessly pass back and forth the workspaces between humans, agents, and other agents. You want to be able to scale test time search against verifiers to find the best possible answer. And so as you'll see in this demo, what happens is you can take a snapshot, set it up to prepare a workspace, and you'll see that we can run agents with test time scaling by racing them against possible conditions, by racing them to find the best possible solution against a given verification condition. So because of InfiniBranch, snapshots on Morph Cloud acquire Docker layer caching-like semantics, meaning that you can layer on side effects which may mutate container state. And so you can think of it as being Git for compute. And you can idempotently run these chained workflows on top of snapshots. But not only that, as you can see inside of the code, if you use this .do method, you can dispatch this to an agent. And that will trigger an idempotent durable agent workflow, which is able to branch. So you can start from that declaratively specified snapshot and go hand it off to as many parallel agents as you want. And those agents will try different methods, in this case, so different methods for spinning up a server on port 8000. One agent fails, but the other one succeeds. And you can take that solution, and you can just pass it on to other parts of your workflow. So this is the kind of workflow that everyone's going to be using in the very near future. And it's uniquely enabled by InfiniBranch, by the fact that we can so effortlessly create these snapshots, store them, move them around, rehydrate them, replicate them with minimal overhead. So what else does the machine want? Well, the machine desires simulacra. And what this means fundamentally, right, is that a thinking machine wants to be grounded in the real world. Right? It wants to interact at extremely high throughput with increasingly complex software environments. It wants to roll out trajectories in simulators at unprecedented scale. And these simulators are going to run inside of programs that haven't really been explored yet for reinforcement learning. They're going to run on Morph Cloud, which is why Morph will be the cloud for reasoning. And what does the future of reasoning look like? Well, it's so more so than what has been explored already. The future of reasoning will be natively multi-agent. So thinking machines should be able to replicate themselves effortlessly, go attach themselves to simulation environments, go explore multiple solutions in parallel. Those environments should branch. They should be reversible. Those models should be able to interact with the environment at very high throughput. and it should scale against verification. So let's take a look at what that might look like in a simple example where an agent is playing chess. So this is an agent that we developed recently that uses tool calls during reasoning time to interact with a chess environment, so along with a very restricted chess engine for evaluating the position, which we think of as the verifier. And as you can see, it's already able to do some pretty sophisticated reasoning just because it has access to these interfaces. However, if you take the ideas which were just described and you sort of follow them to their logical conclusion, you arrive at something which we call reasoning time branching, so which is the ability to not just call to tools while the machine is thinking, but to replicate and branch the environment and decompose problems and explore them in a verified way. So as you can see here, the agent is getting stuck in a bit of a local minimum. But once you apply reasoning time branching, you get something that works much, much better. So here what's happening is that the agent is responsible for delegating parts of its reasoning to sub-agents, which are branched off of an identical copy of the environment, and this is all running on Morph Cloud, along with a verified problem decomposition, which allows it to recombine the results and take them and find the correct move. And so as you can see here, it's able to explore a lot more of the solution space because of this reasoning time branching. So one thing that I will note here is that so this capability is something which is not really explored in other models at the moment, and that's because the infrastructure challenges behind making branching environments that can support large-scale reinforcement learning for this kind of reasoning capability, especially coordinating multi-agent swarms, is fundamentally bottlenecked by innovations in infrastructure that we've managed to solve here. And because of this, you can see that now in less wall clock time than before, the agent was able to call out to all these sub-agents, launch this swarm, and find the correct solution. So, when I think about the problem of alignment, I really think that, Wittgenstein had something right, and that it was fundamentally a problem of language. I think all problems around alignment can be traced to the insufficiencies of our language. This Faustian bargain that we made with natural language in order to unlock capabilities of our language models. But insofar as we must go and develop a new language for superintelligence, insofar as the grammar of the planetary computation has not yet been devised, and insofar as this new language must be computational in nature, must be something to which we can attach algorithmic guarantees of the correctness of outputs. So this is something that Morph Cloud is uniquely enabled to handle. And that's why we're developing verified superintelligence. So verified superintelligence will be a new kind of reasoning model which is capable not only of thinking for an extraordinarily long time and interacting with external software at extremely high throughput, but it will be able to use external software and formal verification software to reflect upon and improve its own reasoning, and to produce outputs which can be verified, which can be algorithmically checked, which can be expressed inside of this common language. And I'm very excited to announce that we are bringing on perhaps the best person in the world for developing verified superintelligence. It's with great pleasure that I'd like to announce that Christian Segedy is joining Morph as our chief scientist. He was formerly a co-founder at XAI. He led the development of code reasoning capabilities for Grok 3. He invented batch norm and adversarial examples. Perhaps most importantly, he's a visionary, and he's pioneered precisely this intersection of verification methods, symbolic reasoning, and reasoning in large language models for almost the past decade. And we're thrilled to be partnering with him to build this superintelligence that we can only build on Morph Cloud. And so the demos that you've seen today have all been powered by early checkpoints of a very early version of this verified superintelligence that we've already begun to develop. And so this model is something that we're calling Magi 1, and it's going to be trained from the ground up to use InfiniBranch to perform reasoning time branching, to perform verified reasoning, be an agent that will be fully embodied inside of a cloud that can move at the speed of light. And that's coming in Q1 2026. So what does the infrastructure for the Singularity look like? Well, we have a lot of ideas about it, but fundamentally we believe that the infrastructure for the Singularity hasn't been invented yet. And at Morph, we spend a lot of time talking about whether or not something is future-bound, which means not just futuristic, belonging to one possible future, but something which is so inevitable that it has to belong to every future. We believe that the infrastructure for the Singularity is future-bound, that the grammar for the planetary computation is future-bound, that verified superintelligence is future-bound. And we invite you to join us because it will run on Morph Cloud. Thank you.
Ladies and gentlemen, please welcome back to the stage the VP of Developer Relations at Llama Index, Laurie Voss.
Hey again, everybody. Let's hear it for all of our keynote speakers. So just like yesterday, I want to quickly run you through what you're going to get from each of our tracks. Likely to be our most popular track today is Software Engineering Agents. Can LLMs power a full engineer? Not just coding alongside you in your IDE, but taking PRDs and turning them into full PRs. You'll hear about Devin, of course, but also about Jules and Claude Code and much more right in this room. Our next track is sponsored by OpenPipe, and it's all about reasoning and reinforcement learning. Reasoning models are all the rage in 2025, and inference time is the next great scaling law. If you want to learn about training, distillation, and getting alignment out of these new models, then this is the track for you. That is in Yerba Buena Ballrooms 2 to 6, which is out these doors and to your left. It's right next door. The next track is Retrieval and Search. RAG is dead. Long live agentic retrieval. This track is not about RAG. It's about what comes next. Agentic search, multimodal retrieval, and all that comes with it. This is where my CEO, Jerry, will be giving a talk. He gave the top-rated talk last year, so I recommend not missing it. That's going to be in Golden Gate Ballroom A, which is out these doors to your left, up the escalators, and then turn left when you see the FedEx office. Then there's the Evals track, sponsored by Braintrust. Everybody says evals are important. We all agree evals are important, and yet, are you doing evals? You are not. Or you do, but not enough of them, or you do, but they keep breaking. This track is curated by Ankur Goyal of Braintrust and is all about making evals work quickly and cheaply. Next, there's the same 2 tracks for our leadership attendees that we had yesterday. So as a reminder, that's for people with the gold lanyards. First is AI in the Fortune 500 track. We've gathered success stories from real AI deployments in the Fortune 500, showing how to use AI at real scale. That's in Golden Gate Ballroom C, which is right next to A and B, again, left at the FedEx office. Our second leadership track, again for gold lanyards, is the AI Architects track. This is for CEOs, CTOs, and VPs of AI to meet and learn from each other on everything from infrastructure to company strategy. That is in Soma, which is all the way upstairs, 3 sets of escalators up to the right of registration. Next up is the security track. As we grant agents increasingly more access to our personal lives and company resources, the problem of security goes from an enterprise sales checklist to a P0. In this track, you'll learn about the state-of-the-art approaches for authentication and authorization in the world of AI. That's in Foothill C, which is, again, all the way upstairs to the left of the registration area. The next track is design engineering. LLMs are 10x better than they were a year ago, but design thinking around the UX of AI has barely budged from ChatGPT and Canvas. We've gathered the top designers and design engineers to showcase their work. That's going to be in Foothill G, 1 and 2, which is all the way upstairs, directly behind the registration desks. Then there's the generative media track. That's going image gen, video gen, and music gen are all on fire this year with increasing coherence over time and iterations, and stunning viral demos, from Ghibli memes to personalized Valentine's songs. How can AI engineers harness the state-of-the-art in AI art? That's in Foothill F, which is all the way up 3 sets of escalators behind registration. And our final track today is autonomy and robotics. The ultimate prize in AI is going outside, automating manual labor over knowledge work. Multimodal LLMs are increasingly being deployed in the real world in everything from cars to kitchens to humanoid robots. And this track is all about the state of physical general intelligence. And it's in Foothill E, which is, again, up 3 sets of escalators behind and to the right of registration. So those are all our tracks today. Now, please go forth and enjoy the expo. The next 45 minutes are dedicated expo time. There are also 3 expo session talks, which are in Juniper and Willow on the floor with the FedEx office, and also in Nob Hill A and B, which is right out these doors and opposite this room. See you all back here for the keynotes at 3:45. Thanks very much.
Welcome, everyone. My name is Vibhu. I'm very excited to be hosting the SWE Agents track here today. Fun fact, this is the most popular track out of all of them. We have a completely full day ahead of you. Every single speaking slot will be filled. We've got 8 amazing speakers here for you today. We're going to have speakers from every top SWE agent. So, we've got the creators of Jules here, Claude Code, Codex, the original SWE agent. We've got the Scott Wu from Devin, Cognition. He will be kicking us off. I'm going to keep my emceeing very, very short, so we give speaking time to the speakers. So let's hear it. Let's kick things off. I want to welcome Scott Wu from Cognition here to speak about Devin.
Oh, OK, cool. Awesome. Yeah, well, thank you guys so much for having me. It's exciting to be back. I was last here at AI Engineer 1 year ago, and it's kind of crazy. I've been telling SWIX that we need to have these conferences way more often if it's going to be about AI software engineering. It probably should be like every 2 months or something like that with the pace of everything's done. But it's going to be fun to talk a little bit about what we've seen in the space and what we've learned over the last 12 or 18 months building Devin over this time. And I want to start this off with Moore's law for AI agents. And so you can kind of think of the capability or the capacity of an AI by how much work it can do uninterrupted until you have to come in and step in and intervene or steer it or whatever it is, right? And in GPT-3, for example, it's if you were to go and ask GPT-3 to do something, it could probably get through a few words or so, and then it'll say something where it's like, OK, this is probably not the right thing to say. And GPT 3.5 was better, and GPT 4 was better, right? And so people talk about these lengths of tasks, and what you see in general is that doubling time is about every 7 months, which already is pretty crazy, actually. But in code, it's actually even faster. It's every 70 days, which is 2 or 3 months. And so, if you look at various software engineering tasks that start from the simplest single functions or single lines, and you go all the way to, we're doing tasks now that take hours of humans' time, and an AI agent is able to just do all of that, right? And if you think about doubling every 70 days, I mean, basically, every 2 to 3 months means you get 4 to 6 doublings every year, which means that the amount of work that an AI agent can do in code goes something between 16 and 64x in a year, every year, at least for the last couple of years that we've seen. And it's kind of crazy to think about, but that sounds about right, actually, for what we've seen. 18 months ago, I would say the only product experience that had PMF in code was just tab completion, right? It was just like, here's what I have so far, predict the next line for me. That was kind of all you really could do in a way that really worked. And we've gone from that, obviously, to full AI engineer that goes and just does all these tasks for you, right, and implements a ton of these things. And people ask all the time, what is the what is the future interface, or what is the right way to do this, or what are the most important capabilities to solve for? And I think, funnily enough, the answer to all these questions actually is it changes every 2 or 3 months. Like every time you get to the next tier, the bottleneck that you're running into, or the most important capability, or the right way you should be interfacing with it, like all of these actually change at each point. And so I wanted to talk a bit about some of those tiers for us over the last year or so. And over the course of that time, obviously, when we got started in the end of 2023, obviously, agents were not even a concept. And now everyone has, everyone's talking about coding agents. People are doing more and more and more. And it's very cool to see. And each of these has kind of been almost a discrete tier for us. And so right around a year ago, when we were doing the last AI engineer talk, actually, the biggest use case that we really saw that was getting broad adoption was what I'll kind of call these repetitive migrations. And so I'm talking like JavaScript to TypeScript, or like upgrading your Angular version from this one to that one, or going from this Java version to that Java version, or something like that. And those kinds of tasks in particular, what you typically see is you are you have some massive code base that you want to apply this whole migration for. You have to go file by file and do every single one. And usually the set of steps is pretty clear, right? If you go to the Angular website or something like that, it'll tell you, all right, here's what you have to do. This. And you want to go and execute each of these steps. It's not so routine that there's no classical deterministic program that solves that. But there's kind of a clear set of steps. And if you can follow those steps very well, then you can do the task. And this was the thing for us because that was all you could really trust agents to do at the time. You could do harder things once in a while, and you could do some really cool stuff occasionally. But as far as something that was consistent enough that you could do it over and over and over, these kinds of repetitive migrations that you would be doing for 10,000 files were, in many ways the easiest thing, which was cool actually because it was also kind of the most annoying thing for humans to do. And I think that's generally been the trend where AI has always done these more boilerplate tasks and the more tedious stuff, the more repetitive stuff, and we get to do the more fun, creative stuff. And obviously, as time has gone on, it's taken on more and more of that boilerplate. But for a problem like this one, a lot of what you need to do is you need Devin to be able to go and execute a set of steps super reliably. And so a lot of this was, I would say the big capabilities problem to solve was mostly instruction following. And so we built this system called playbooks, where basically you could just outline a very clear set of steps, have it follow each of those step by step, and then do exactly what's said. Now, if you think about it, obviously, a lot of software engineering does not fall under the category of literally just follow 10 steps, step by step, and do exactly what it said. But migration does. And it allowed us to go and actually do these, and this was kind of, I would say, the first big use case of Devin that really came up. I think one of the other big systems that got built around that time, which we've since rebuilt many times, is knowledge or memory, right? Which is, if you're doing the same task over and over and over again, then often the human will have feedback on, hey, by the way, you have to remember to do X thing, or you have to, you need to do Y thing every time when you see this, right? And so basically an ability to just maintain and understand the learnings from that and use that to improve the agent in every future one. And those were kind of the big problems of the time, and that was summer of last year. And around end of summer or fall or so, I think the kind of big thing that started coming up was as these systems got more and more capable, instead of just doing the most routine migrations, you could do these more, still pretty isolated, but a bit broader of these general kind of bugs or features where you can actually just tell it what you want to do and have it do it, right? And so, for example, hey, Devin, in this repo select dropdown, can you please just list the currently selected ones at the top? Like having the checkboxes throughout just doesn't really, and Devin will just go and do that, right? And so if you think about it, it's something like the kind of level of task that you would give an intern. And there are a few particular things that you have to solve for with this. First of all, usually these changes are pretty isolated and pretty contained. And so it's one, maybe two files that you really have to look at and change to do a task like this. But at least you do still need to be able to set up the repo and work with the repo, right? And so you want to be able to run lint. You want to be able to run CI, all of these other things. So to at least have the basic checks of whether things work. One of the big things that we built around then was the ability to really set up your repository ahead of time and build a snapshot that you could start off, that you could reload, that you could roll back, and all of these kinds of primitives as well, right? So having this clean remote VM that could run all these things, it could run your CI, it could run your linter, and so on. But that's when we started to really see, I would say, a bit more broad of value, right? I mean, migrations is one particular thing, and for that particular thing, we were showing a ton of value. And then we started to see where, with these bug fixes or things like that, you would be able to just generally get value from Devin as almost like a junior buddy of yours. And then in the fall, things really moved towards just much broader bugs and requests. And here it's, most changes, again, you're jumping another order of magnitude. Most changes don't just contain themselves to one file, right? Often you have to go and look, see what's going on. You have to diagnose things. You have to figure out what's happening. You have to work across files and make the right changes. Often these changes are, hundreds of lines. If it's like, hey, I've got this bug, let's figure out what's going on, let's solve it, right? And there are a lot of things here that really started to make sense and really started to be important. But one in particular I'll just point out was there's a lot of stuff that you can do with not just looking at the code as text, but thinking of it as this whole hierarchy, right? So understanding call hierarchies, running a language server is a big deal. You have git commit history, which you can look at, which informs how these different files relate to one another. You have, obviously, you have like your linter and things like that, but you're able to kind of reference things across files. And so like one of the big problems here, I think, was kind of working with the context of it, and getting to the point where it could make changes across several files. It could be consistent across those changes. It would be able to understand across the code base. And here was really the point, I would say, where you started to be able to just tag it and have it do an issue and just have it build it for you. And so Slack was a huge part of the workflow then, and it was just, it made sense because it's where you discuss your issues and it's where you set these things up, right? So you would tag Devin in Slack and say, hey, by the way, we've got this bug, please take a look. Or, could you please go build this thing? This is an especially fun part for us because this is right around when we went GA. And a lot of that was because it got to the point where you truly could just get set up with Devin and ask it a lot of these broad tasks and just have it do it. But a lot of these, a lot of the work that we did was around having Devin have better and better understanding of the code base, right? And if you think about it, from the human lens, it's the same way, where on your first day on the job, for example, being super fresh on the code base, it's kind of tough to know exactly what you're supposed to do. Like a lot of these details are things that you understand over time, or that a representation of the code base that you build over time, right? And Devin had to do the same thing and had to understand, how do I plan this task out before I solve it? How do I understand all the files that need to be changed? How do I go from there and make that diff? And around the spring of this year, again, every gap is like 2 or 3 months, we got to an interesting point, which is, once you start to get to harder and harder tasks, you as the human don't necessarily know everything that you want done at the time that you're giving the task, right? If you're saying, hey, I'd like to go and improve the architecture of this, or this function is slow, like let's profile it and look into it and see what needs to be done, or hey, we really should handle this error case better, but let's look at all the possibilities and see what we should, what the right logic should be in each of these, right? And basically what it meant is that this whole idea of taking a 2-line prompt or a 3-line prompt or something and then just having that result in a Devin task was not sufficient, and you wanted to really be able to work with Devin and specify a lot more. And around this time, along with this kind of better code base intelligence, we had a few different things that came up, and so we released DeepWiki, for example. And the whole idea of DeepWiki was, funnily enough, is Devin had its own internal representation of the code base, but it turns out that for humans, it was great to look at that too, to be able to understand what was going on or to be able to ask questions quickly about the code base. Closely related to that was search, which is the ability to really just ask questions about a code base and understand some piece of this. And a lot of the workflow that really started to come up was actually basically this more iterative workflow, where the first thing that you would do is you would ask a few questions, you would understand, you would basically have a more L2 experience where you can go and explore the code base with your agent, figure out what has to be done in the task, and then set your agent off to go do that. Because for these more complex tasks, you kind of needed that, right? And so that was I would say kind of like a big paradigm shift for us then, is understanding, this is what also came along with Devin 2.0, for example, and the in-IDE experience, where often, you want to be able to have points where you closely monitor Devin for 10% of the task, 20% of the task, and then have it do work on its own for the other 80, 90%. And then lastly, most recently, in June, which is now, it was kind of, really the ability to just truly just kill your backlog and hand it a ton of tasks and have it do all of these at once. And if you think about this task, in many ways, I would say it's almost like a culmination of many of these different things that had to be done in the past. You have to work with all of these systems, obviously. You have to integrate into all of these. Certainly, you want to be able to work with Linear or with Jira or systems like that, but you have to be able to scope out a task to understand what's meant by what's going on. You have to decide when to go to the human for more approval or for questions or things like that. You have to work across several different files. Often you have to understand even what repo is the right repo to make the change in if your org has multiple repos, or what part of the code base is the right part of the code base that needs to change. And to really get to the point where you can go and do this more autonomously, first of all, you have to have a really great sense of confidence, right? And so, rather than just going off and doing things immediately, you have to be able to say, OK, I'm quite sure that this is the task, and I'm going to go execute it now, versus I don't understand what's going on. Human, please give me help, basically, right? But the other piece of it is, this is, I think, the era where testing and this asynchronous testing gets really, really important, right? Which is, if you want something to just deliver entire PRs for you for tasks that you do, especially for these larger tasks, you want to know that it can test it itself. And often, the agent actually needs this iterative loop to be able to go and do that, right? So it needs to be able to run all the code locally. It needs to know what to test. It needs to know what to look for. And in many ways, it's just a much higher context problem to solve for, right, is this testing itself. And that brings us to now. And obviously, it's a pretty fun time to see, because now what we're thinking about is, hey, maybe if instead of doing it just one task, it's, how do we think about tackling an entire project, right? And after we do a project, what goes after that? And maybe one point that I would just make here is, we talk about all these 2x's, that happen every couple months. And I think from a kind of cosmic perspective, all the 2x's look the same, right? But in practice, every 2x actually is a different one, right? And so when we were just doing, tab completion, single line completion, it really was just a text problem. It is just like take in the single file so far and just predict what the line is next, right? Over the last year or year and a half, we've had to think about so much more. How do you work with the human in Linear or Slack or Jira? How do you take in feedback or steering? How do you help the human plan out and do all these things, right? And moreover, obviously, there's a ton of the tooling and the capabilities work that have to be done of how does Devin test on its own? How does Devin make a lot of these longer-term decisions on its own? How does it debug its own outputs or run the right shell commands to figure out what the feedback is and go from there? And so it's super exciting now that there's a lot more coding agents in the space. It's very fun to see, and I think that we're going to see another 16 to 64x over the next 12 months as well. And so yeah, super excited. Awesome. Well, that's all. Thank you guys so much for having me.
Awesome. Thanks for what a great talk, Scott. So we just heard from the creators of Devin, one of the very first proper SWE agents, right? They shocked the world with their demo. They were kind of the first to pivot this field of autonomous long-form agents that can run and actually complete tasks. Now, our next speaker is from Google. He's the AI PM of AI Labs, and he works on Jules. Jules is one of the latest coding agents, right? So he's going to speak to us about asynchronous coding agents. As we change from a world of coding copilots to autonomous SWE agents, how do we kind of delegate our workflow? What do we do when we have a bunch of these agents going on? So without further ado, I want to welcome Rustin Banks from Google to speak to us about Jules.
Awesome. Hi, everyone. I'm Rustin. I'm a product manager with Google Labs, and really thrilled to be here and get to speak to you today. This is really like a dream come true. So I'm an engineer at heart. This is my first compiler, Borland C++ 3.1. It came in the mail on 10 5.5-inch floppy disks. I ordered it from AOL Classifieds. It was amazing. This is my bulletin board, that I hosted out of my parents' closet and salvaged computers. And I just think it's ironic that when I saw AI come out, I recognized the text-based interfaces perfectly from hosting bulletin boards. And then when I saw this, like many of you, I dedicated my career to AI coding. And this is ChatGPT 3.5. Isn't it crazy that how slow this is, and this used to be state-of-the-art only 2 years ago? It's pretty amazing. Right now, I'm a product manager for Jules, and Jules is an asynchronous coding agent meant to run in the background and do all those tasks that you don't want to do in parallel in the background. And we launched this just 2 weeks ago at I/O to everyone, everywhere, all at once, for free, while Josh was up on the stage trying to demo other Google Labs products. And so he called us. We said, oh, we got to shut it down so that we can demo other products. And luckily, we got it up and going. but it was a super exciting launch. And the best part about it is to see these use cases where this is what we really want to solve. We want to do the laundry, so to say, so that you can focus on the art of coding. So the next time Firebase updates their SDK, Jules can do that for you. Or if you just want to develop from your phone, Jules can do that for you. So in the last 2 weeks, we've had 40,000 public commits, and we're super excited what we can bring to the open source world. But as developers, we're meant to think serially. We take a task from the queue, we work on it, we go on to the next one. That's our default workflow. Today we'll learn about how to maximize parallel agents. I'll try a real-world demo, and we'll go through a real-world use case. And then I'll go through some best practices we've learned from watching people use Jules. So for this parallel process really to work well, we need to get better with AI at the beginning and the end of the workflow. Meaning, if it's on me to now I just have to write a bunch of tasks all day, that's not fun. And if I'm reviewing PRs and handling merge messes at the end of the day, that's not going to work well either. So luckily, help is on the way. So for example, AI can easily work through backlogs, bug reports, to create tasks for you, with you. And then at the end of the SDLC, help is on the way where we can use critic agents, merging agents that can bring everything together and make it so that this parallel workflow that we've envisioned can really come together and not drive us crazy. Remote agents are uniquely suited for this. Agents inside of our IDE are always going to be limited by our laptop. And when you have these remote agents in the cloud, essentially agents as a service, they're infinitely scalable, they're always connected, and then you can develop from anywhere, from any device. We've seen 2 types of parallelism emerging. This is the type that we expected, which is multitasking. Oh, I have 10 different things on my backlog. Let's do them all at once, and then we'll merge them together and test them. Interestingly, you saw an example of the second type this morning with Solomon from Dagger showing how he wanted 3 different views of his website at the same time. This was the emergent behavior we didn't expect, which is multiple variations. Essentially, we see users taking a task, especially if it's a complex task, and saying, try it this way, try it that way, or give me this variation to look at, or multiple variations to look at. And then you can test and choose. And we can have the agents test and choose the best ones, or the user can test and choose. So for example, we see lots of people who are working on a front-end test, and they're in a React app, and they're saying, I'm adding drag and drop. Maybe try it using this library, the React Beautiful drag and drop, or maybe use DND kit, or maybe try it using the test first. And in this parallel asynchronous environment, you can just spin up multiple agents at the same time. They can try it, they can easily come back together, choose the best one, and you're off to the races. Okay, demo time. So, exit out of this. For a demo, I'm going to use the conference schedule website. And Swix, for all his skills, as you can see, has probably not spent a lot of time designing the schedule website, as you can see there. Anytime there's a horizontal scroll bar, we know that's a problem. But luckily, they knew that, and they said, we're just going to publish the JSON feed, and we'll let hackers hack. Engineers do what we do, and let's build from it. So Pal Love, who is here, built this amazing conference site where you can favorite things, you can bookmark things, and this is what I use to keep track of my sessions for the conference. And so I messaged him. I said, hey, can I clone this and use this as an example for Jules? And Palev said, oh yeah, sure. Actually, I was sitting in my last session on my phone, and I fixed a bug using Jules. So I thought that was perfect. So this is how I would start. Something like this is I would go into linear, and I would say, okay, first thing we need to do, we just heard Scott talk about it, is I want to add a way to know if this parallel agent is going to do a bunch of things at the same time, that it's getting it right. So first, we're going to add some tests. And then I'm going to kick this one off while I'm thinking about it. And then using that idea of multiple variations, I'm going to say add it with Jest and add it with Playwright at the same time. And then we'll look at the test coverage, and we'll choose the one that has the best test coverage. Once that's done, then I can go to that other mode of parallelism, and I say I would like a link to add a session to my Google Calendar. I would like an AI summary when I click on a description. And these are all features, but what I'm really excited for is for AI to do the stuff that we never seem to get to, such as accessibility audits and security audits. All those things that seem to go on the backlog but are really important, and I'm super excited for AI to do that. So we're going to also have it do an accessibility audit and improve our Lighthouse scores at the same time. This is mostly a front-end demo because, well, I'm mostly a front-end engineer, and it's a better visual representation, but we've seen all these applied to the back end as well. Okay, so here's Jules. We told it to add tests and ingest framework. It connects to my GitHub, all my GitHub repos, and it's going to give me a plan. That looks about right. I can see it's going to test the calendar, the search overlay, the session. That sounds great. I can approve the plan. So Jules now has its own VM in the cloud. It's cloned my whole code base. It can run all the commands that I can run. And importantly, after it has these tests, it can run these tests so it can know when we add a new feature if it gets things right. So I'm going to fast forward a little bit here. And so this is adding Jest tests. You can see all the things or all the components it's added to the tests. It's added to the README, so now next time that it goes to add something, it'll look at the README and it'll remind itself, oh, this is how I run the tests. Let's see how it did on test coverage. Okay, we got down to, looks like about, estimated test coverage looked like about 80%, so that's pretty good. We could compare that with Playwright, and then we could just choose the one we like the best. We merge that into main, and now we're off to the races. So that, again, it's automatically integrated into GitHub. We merge that into main, and now we can start saying, okay, now I want a calendar link. So I want a calendar button that can go in, and Jules will work on that, and then sure enough, it ran the test didn't pass the first time, it makes some changes, now the tests pass, and I can review this code. Eventually I could look at this in Jules' browser, but I feel pretty confident about testing this, knowing that all the tests pass. Similarly, for the Gemini summaries, when I click on a description, I can get a Gemini summary. I put this one in an emulator, or I emulated a mobile view, just so you can see I could have done this from my phone. So this is making an accessibility audit, fixing any issues from my phone. Never mind the console errors. Jules is going to fix those. And then I can go back. Now we have this big merge we need to do. And to be honest, I ran out of time to finish the merge, and Jules should help me with this merge. And it's called an octopus merge. So surely Jules as a squid should help with the octopus merge. But let's just pull our checkout, our add to calendar button. Go back to this, localhost, refresh. And now I have a calendar button. Let's test it. Okay, let's add this to my calendar to make sure I know to come to my own talk. And there it's on my calendar. I could then now, again, pull this back into the main branch, and now everybody at the conference has the ability to add sessions to their Google Calendar, along with everything else that we saw there, a full test suite, all the accessibility audits, a Lighthouse scores improvement, and that took me all about an hour, and managing the parallel process in the back end. Okay. So, in summary, the secret to working in parallel is a clear definition of success, because nobody wants to review PRs all day. So think before you get started, how am I going to easily verify that this works? Again, Scott hit on this as well. Create this agreement with the agent. Tell it, don't stop until you see this, or don't stop until this works. And then a robust merge and test framework at the end to put everything back together, and help is coming. This is how I prompt for Jules. I give it a brief overview of the task. I tell it when it will know what it got right, any helpful context, and then at the end, I'll append a simple broad approach, and then I'll change that last line maybe 2 or 3 times, depending on the complexity of the task. So for example, if I need to log this number from this web page every day, I'll say, today the number is X, so log the number to the console and don't stop until the number is X. That was a simple test that I wrote in. It'll keep going. I give it a helpful context, like this is the search query, and then I'll say, use Puppeteer, and then I'll clone that task because I can. It's in the cloud, and I'll say, use Playwright. So again, have an abundance mindset. We're used to working on a single thing at a time. Easy verification makes it so now we can work on multiple things at the same time, try lots of things. As we saw this morning, look at different variations. We can, with a parallel process, we have the ability now to try things that we would never have tried before. Let AI help with those bookends, the task creation, and then the merge and test part, and context. Keep using MD files or links to documentation, to getting started documents. The more context, the better. And then we tell people just throw everything in there. Jules and other agents are pretty good at actually sorting out which context is important. So more context is better at this point, but maybe that's just for the Gemini models, which I should have mentioned. Jules is powered by Gemini 2.5 Pro. Quick shout out, thank you Team Jules. Couldn't have done any of this without you. If you have any questions, you can DM me. I'm Rustin Banks, Rustin B on X. Thanks everybody.
Awesome. Always good to hear from one of the latest coding agents, and it's always great to get a refresher. You know, even I don't know how to prompt these things, but I'm liking this flow. We started off with Cognition. We had Devin, one of the first proper SWE agents. Then we had one of the latest. We just heard from Google about Jules. Let's take it back again. Let's hear from GitHub, one of the very, very first coding copilots, right? So let's hear about the future and, you know, how do we still want to think about GitHub Copilot? So without further ado, I want to welcome Christopher Harrison to the stage to tell us about GitHub Copilot.
All right. Let's get right on into it. So my name is Christopher Harrison. I'm a senior developer advocate at GitHub, primarily focused in on this little thing called developer experience, or as all the cool kids like to call it, DevX, and GitHub Copilot. So let's talk about the past, the present, and the future of GitHub Copilot. Whoops. Actually, it's not picking up at all. Oh, there we go. Let me... entire start mirroring. There we go. Cool. Look at that. OK, so let's get on into it. So where we started was with code completion. And so with code completion, I'm a developer, I'm in the zone, type. And then Copilot's going to then suggest the next line, the next block, the next function, potentially even the next class. And this is wonderful for giving that in-time, inline support to our developers. But as we all know, the tasks that we're going to be completing go beyond just writing a few lines of code. That I need to be able to explore, I need to be able to ask questions, and I need to be able to modify multiple files. And so this is where chat comes into play. And we started off with chat by supporting ask mode, where I could go in and ask questions or ask Copilot to generate an individual file for me. And then we expanded this out to edit mode. And with edit mode, I can then drive Copilot as it modifies multiple files. Because when we think about even the most basic of updates, I'm going to update a web page. That's going to require updating my HTML, my CSS, and my JavaScript. 3 files. With edit mode, I can do that very quickly, and again, right inside of chat. Then we get into agent mode. And agent mode really shifts things. Because unlike chat, where I'm going in and I'm asking questions, and I'm going in and I'm pointing it out the files that I want to see modified, With agent mode, it's able to perform those operations on my behalf. And on top of that, it's going to behave an awful lot like a developer, that it will go in, do a search, find what it needs to do, perform those tasks, and then even be able to perform external tasks as well. So it could run tests, detect that maybe those have failed, and then even self-heal. So I have an application here, and I want to create a couple of new endpoints. So the first thing that I'm going to do is I'm going to add in a little bit of context here. So instruction files allow me to give Copilot a little bit of additional information about what it is that I'm doing and how it is that I want it to be done. So I have an instruction file specific around my endpoints. Now, this is definitely one of those scenarios where agent mode could figure this out on its own. But as I like to say, don't be passive-aggressive with Copilot. That if there's a piece of information that's important that you want it to consider, go ahead and tell it. It might be able to figure it out on its own, but this is certainly going to make life easier. So now that I've added this in, I'm going to now say create endpoints to list the publishers and get publisher by ID, create the tests, ensure all tests pass, and then hit send. Now, I'm doing a live demo with AI. So we're going to see what happens here. There's a chance it will fail. There's a chance it will fail spectacularly. But there's also a really good chance that everything's going to succeed. And that's the part that I'm going to hope for. Now, if I take a look at what Copilot's doing here, what I'm going to see is, as highlighted, it's behaving an awful lot like a developer. That it tells me what it's going to do. It's going to create the endpoints to list all the publishers, get the publisher by ID. So the first thing it's going to do is explore the project, figure out what's going on. Then it's going to create the endpoint. Then it's going to create the tests. And then it will ensure everything works correctly. And now if I keep on scrolling down, I'm going to notice that it's searching through my code base. Because if I was tasked as a developer to perform this, that's the first thing I'm going to do. And that's exactly what Copilot here is doing. It created my publisher's PI file. It looked for routes that happen to be matching publishers. And now it's going to create the endpoints here. And so if I stall for just a moment longer and move my mouse to make it go faster, see, it worked, we're going to notice that it will now generate that publisher's PI file. And one big thing that you're going to notice is I've got these great keep and undo buttons here. Because I always like to highlight the fact that AI does not change the fundamentals of DevOps. That if I think about how I wrote code before AI, some of that would be created off the top of my head. Some of that would be based on existing code. Some of that would be copied and pasted from Stack Overflow and then made a couple of changes and crossed my fingers and hoped that it worked. Maybe that was just me. And to help ensure that all of the code that I was going to be committing to our code base is secure and is written the way that we want it to be written, we had code reviews. We have linters. We have security checks. And we're going to do all that exact same thing even when we introduce AI. So this keep and undo allows me to very quickly ensure that, yes, everything looks good, and if it doesn't, to be able to undo it. We'll also notice history buttons up here that allow me to act iteratively. Because again, when I'm working with AI, I'm not necessarily going to get perfect code the first time. So I can go in and I can work back and forth. So I can say, hey, this looks good, but I want to do this. Maybe I want the buttons to look blue or whatever it is, and then highlight that. So what I'm going to now see is the fact that it created all my files, updated a couple of items, and now it can run my tests. And this is going to be one of those rare moments where I'm kind of hoping that it fails, because I want to see it be able to recover for me. So you'll notice that it ran my tests. You'll notice that it ran my 4 tests. Everything succeeded. Shucks. And then now it's going to go ahead and continue to iterate from there. And so what we see with agent mode is Copilot driving the way on going in and writing my code. But I always want to highlight the fact that I, as the developer, am still in charge. Now, the one catch, though, with agent mode is the fact that that's going to be inside my IDE, and the fact that that's still going to be, well, single-threaded. It's going to be synchronous. This is where we come into coding agent. And with Coding Agent, this is going to be completely asynchronous, and this is going to run on the server. So let me kick over to an example that I had actually run earlier this morning, where I have an issue that's been created, where I say add, edit, and delete endpoints. Now I'm going to real quick just unassign Copilot just so I can kick off the workflow and we can see this in action here. I'm going to let those cute little eyeballs go away here. There we go. And let's go back in and hit assign, and let's go ahead and reassign Copilot. So by assigning Copilot here, I've now kicked off the Coding Agent. I can now see the little eyeballs, and that indicates to me that Copilot is hard at work. And if I scroll on down, I'm now going to see a brand new pull request that's been made here. And this is now what Copilot is going to utilize to help keep me updated on the work that it is performing. And if I scroll on down just a little more, what I'm also going to see is a little View Session button. And if I hit this View Session button, I can notice right here that it's telling me that it's spinning up a development environment. And this raises a very big question, which is, where is this running? How can I ensure that this is going to be done securely? So this is running inside of GitHub Actions. And if you're not already familiar with GitHub Actions, this is our platform for automation. And in fact, I can go ahead and configure the environment in which I want my Coding Agent to work by creating a specialized workflow exactly for that. And that's what I see right here with this Copilot setup steps. And if I scroll down, what I'm going to notice is that I've got steps to install Node, I've got steps to install Python, and all the frameworks and all the libraries that we're going to be using. Now, not only does this ensure that Copilot is working in the environment that I want it to work in, but it also allows me to highlight the fact that by default, Coding Agent does not have access to any external resources. So it's not able to call the internet, it's not able to call any external services. Now, if I so desire that I want it to be able to do that, then I can go in and configure MCP servers, and I can also add in updates to my firewall. So that way I can punch a hole in my firewall and allow Copilot to then access those external resources. But by default, it's only going to have access to what I've configured and inside of that container. In addition, because of the fact that that is running inside of GitHub Workflows, inside of GitHub Actions, it's going to be an ephemeral environment. So it's going to spin up a brand new environment, and once its work is done, it's going to then delete it. Continuing down the security path, let me kick back one page here. If I scroll down, you're also going to notice that it's not even able to automatically kick off any workflows. So I have a couple of workflows associated with this repository for running my unit tests and for running end-to-end tests. And by default, it's not going to be able to do this unless I go in and I say yes. You'll also notice that the pull request that it creates is going to be in draft mode, and I have to go in and review it. Because again, developers in charge, again, because just because we're introducing AI does not change the normal DevOps flow. Now, if I take a look at the one that was created earlier, let me go ahead and open that up. What I'm going to notice is a pull request with a fantastic description of everything that it has done. So I can see the PR implements the missing CRUD operations. I can see it lists off all the different endpoints that it created, the error handling, the testing, and the technical details. And I can also, again, open up my session here and see all the tasks that it performed. And you'll notice, again, that it's going to behave an awful lot like a developer. That it's going to go out, it's going to do searches through my code base, determine what needs to be done, and then eventually perform the tasks. And if I scroll all the way to the end here, there it is. Perfect. What I can now see is I've got a nice little summary down at the very bottom. And if I scroll up, I should be able to see that it ran all my tests. Yep. I can see all my tests right there. And I can see in this case that all 16 of those tests passed. So it created that PR, and then I also decided, OK, all of that looked good to me, so I allowed it to run the actions, and I can even now see that it ran those unit tests, ran the end-to-end tests, and everything looks good. Then I could say ready for review, and then finalize the creation of it. The last thing that I want to highlight, and this both leads into the security aspect, but also brings me back into the developer aspect, is we'll notice that it created a brand new branch. In this particular case, it's called Copilot/fix-3. Where that came from is that the issue number that this was associated with was issue number 3. And so Copilot will only have write access to that branch. And this branch is going to behave just like any other branch that I might have. So if I clone the repository locally, I can go ahead and check out that branch. I've opened up the branch inside of GitHub here. Let me scroll on down to my server, into my routes, and into my games. And if I scroll on down inside of here, sound effects help, by the way, what we're going to notice is that there is my update game. I think my create game was up here. Yep, there it is. And there it all is. But again, it's only inside of just that branch. So that's the only place that coding agent is going to have write permissions to. Now, this leads us into a very big question, which is, OK, that's wonderful, Christopher. You've created a little kind of simple demo. You had to create a few Flask endpoints, and that's wonderful and all. But how about doing it in the real world? Well, one of the big tenets that we have at GitHub is we build GitHub on GitHub. And in fact, Coding Agent was built with the help of Coding Agent. And you're going to notice when we take a look at the amount of commits that found its way into Coding Agent, that Coding Agent itself was one of the most prolific committers. That Coding Agent not only created new features, but it also helped address tech debt. And this is one of the biggest places where I personally see Coding Agent really shining. Because I don't know of a single organization that doesn't have tech debt, that feels comfortable with the state of their backlog, that doesn't have a limitless number of items where they keep going, yeah, that's great and all, but we just don't have the time. You can assign that to Coding Agent, and away you go from there. Now, behind the scenes, and I've kind of already talked about this, but I've got some slides to kick through real quick. As I highlighted, that secure environment, separate platform, ephemeral, all running inside of GitHub Actions, and you have the ability to customize that. Coding Agent does understand your repository and understands your GitHub context. So it has access to read your repository, and it is even able to read Copilot instructions. And it does have access to Model Context Protocol, so it can make those external calls. It does include those safeguards, read-only access to your repository, the default firewall preventing any external access, review before merge, and review before those actions run. So we continue to iterate on Copilot. We continue to look for new areas where Copilot can shine to help streamline development and to help increase the productivity of developers. Thank you.
Awesome. Thank you, Christopher. We love hearing about, some of the main players in the SWE agent space. So it's always nice to hear from some of the big players. We want to continue this track with, how do we actually take things to production? So our next speaker, Tomas, is going to talk to us about the outer loop. So how do we deal with, actually deploying and using these software engineering agents? How do we manage all of the, CI/CD, the pipeline? How should we actually deal about using these things? So I want to take a little bit of a break here in the talks and kind of speak about what's actually going on, right? Innovation in SWE agents is going at quite a rapid pace. Like, we've had Jules, we've got Codex, we've got Claude Code. As we get more and more of these software engineering agents that kind of really change the workflow of how we code, how do we handle actually deploying them, right? So we've got a next lineup of speakers that are going to help talk a little bit more about this. And, we just kind of want to set the stage here. So let's just get it a little bit more interactive. How are we feeling about the track today? Who's kind of been a fan of Jules? I want to see what are the major ones. So who here in the room has used Devin? Let's see, show of hands. Okay. We have a few Devin users. And what about Jules? How are we feeling about Google's Jules? Okay, same set of hands. How about Claude Code? We've got a speaker from Claude Code coming later. Okay, more hands, but different hands. Seems like we've got a bit of a differentiation there. What about OpenAI's Codex? Oh, another set of hands. So interesting, you know? We've got different core copilots, and it seems like people use them differently. But we also like to see the other end of the spectrum, right? So we've got Devin. Who here is a fan of Devin and uses Devin's Cognition? Devin from Cognition. Okay, so we've got another set of hands. And you know, one thing to note is that we kind of have these different categories of agents, right? What about the human-in-the-loop short copilots? Who here uses Cursor and Windsurf in their coding day-to-day tasks? A lot more hands. So it's an interesting sort of split, right? We've got these human-in-the-loop sort of short-term coding copilots where we've got stuff like Cascade from Windsurf. We've got Cursor's Copilot, and kind of everyone's hand goes up, right? A lot of people are starting to use these copilots in their IDE. Then we take it to the next level. We've got, we've got the big players where we have Claude Code, we have Jules, we have Codex. And an interesting note, everyone kind of has their own buckets. It's not the same hands that go up. So that's one of the reasons why at the conference we like to invite speakers from everywhere. Now, the third camp, Devin, it's another way to think about it. As you have longer horizon agents, how do we deal with those? And that's kind of where, we're starting to take the second half of the day in SWE agents. We want to talk about how do we take these things to production? How do we actually deploy these? And, to bring that up, I want to invite our next speaker, Tomas Reimers. He's going to give us a little bit about this. He's from Graphite. So without further ado, let's welcome Tomas.
Thank you so much. Perfect. Hello, everyone. Let me see. Nope, no need for either of those. Thank you so much, though. And then slides looking good. Cool. Perfect. Awesome. Hi, everyone. My name is Tomas. I'm one of the co-founders of Graphite. Graphite is an AI code review company. So to give some context on sort of where we see the industry right now and where we see it going, software development currently and has always had two loops. The inner loop, which is focused on development, and the outer loop that's focused on review. Developers spend time in the inner loop, they get their code working, they get the feature the way they want it, and then they go ahead and they move it to the outer loop, where it's tested, reviewed, merged, deployed. We're seeing the inner loop change right now more than we've ever seen it. More developers are using AI than ever. I think right here we have some statistics from the GitHub developer survey. Nearly every developer surveyed used AI tools both inside and outside of work, and 46% of GitHub is being written by code on GitHub is being written by Copilot. We're seeing more and more code being written by AI. Here we have some statistics around how code has changed over time and how some people predict it will change. And even if we take a more pessimistic view of that, we still see the way the world's going as just more and more and more code being written by AI. The inner loop is changing, AI is making more developers more productive. Developers are now producing higher volumes of code, but that code still needs to be reviewed. When we first started looking at this, and when we first started building Diamond, our AI code reviewer, about a year ago now, what we found was we read a lot of articles that scared us a lot. We were seeing within our own organization a lot of developers adopting AI tools, but we were also seeing a problem. AI can hallucinate, it can make mistakes, and almost more scarily, it can make security vulnerabilities. For us, what we saw was that while the inner loop was getting sped up by AI, the outer loop was rapidly becoming the bottleneck. We were seeing tools like Cursor, Windsurf, Copilot, V0, Bolt, all of those, producing larger volumes of code than we were used to, than we had ever seen before. But we were also seeing our developers suddenly have to review higher volumes of code, test higher volumes of code, merge higher volumes of code, and deploy higher volumes of code. That's what brought us to say, there has to be a new outer loop here. The way that things are going, this isn't going to work. We're going to break down. We're watching the problems that used to only ail large companies start to ail all companies, where we were seeing companies deal with higher and higher and higher volumes of code. The requirements for the new outer loop then look a lot like the problems that larger companies have always had to deal with. You need tools to better prioritize, track, and get notified about pull requests. You need driver assist features to help reviewers focus and streamline the code review process. You need optimized CI pipelines and merge queues to be able to handle the sheer volume of code changes that are now happening. And you need better deployment tools. When we first started looking at this through sort of an AI-first lens, we started to see that, well, the problems are being created by AI. They can also probably be solved by AI. We can probably start to streamline a lot of these processes which have previously had been manual, previously were parts of the process that developers did not enjoy, did not want to do. We wanted to see self-driving code review solutions where we no longer had to do those very manual and painful parts of review, but we could actually start to really focus on what matters most to the developers, making sure that your product can get out to users and that the features work as expected. We were seeing that AI-generated feedback wasn't perfect. And because of that, we were starting to think that bots weren't enough. I think an early vision of ours was, well, can we solve this by just adding AI teammates, right? Maybe it's background agents, maybe it's reviewers, maybe it's a whole lot of teammates to the workflow. And while we think that's part of the story, we don't think that's enough. We think that, as we built with Diamond, that your entire tool chain has to be AI native, not just your IDE. If you really are going to embrace AI in the age of development, if you're going to accept the fact that developers are going to be orders of magnitude more productive than they ever have before, you need tooling that reflects that. We started by building Diamond, so the winning AI code review platform. With high signal, low noise, has a deep understanding of the code base and change history. We summarize, prioritize, and review each change, and we integrate with your CI and your testing infrastructure to summarize errors and correct failures. Our hope with it, and what we've started to see as we've rolled it out to larger and larger customers and enterprises too, is we reduce code review cycles, we enforce quality and consistency, and we keep your code private and secure. It's high signal, it's zero setup, it's actionable with one-click suggestions, and it's customizable. It's already being used by some of the fastest-moving companies in the world. It's expanding a lot more than we can even say publicly. And I hope that you all will embrace the idea that AI can change your entire developer workflow, not just your IDE. By the numbers, we see comments that our AI bot leaves to be downvoted at less than a 4% rate, and to be accepted, meaning integrated into the pull request that they were left on, at a higher rate than human comments are. Human comments are integrated about somewhere between 45 and 50%. We're watching our Diamond comments be accepted about 52%. We've spent a lot of time tuning that. That number is actually new as of March for us. That's what I have to tell you around Graphite, what I have to tell you around Diamond. I hope you give it a shot, and thanks for having me.
Awesome. Thanks again, Tomas, for such a great talk. We want to thank everyone for coming out to the SWE Agents track. We're going to take a short break. Lunch is going to be served here in the halls. The expo session will be open. But, without further ado, we're very happy to announce that in the evening, we have 4 more fully packed sessions. I think we are the only track that is fully booked. So we've got all 8 speakers. We're going to have a great round of speakers coming up soon. So feel free to come back here later. We're going to kick off with a talk from Claude Code. So how do they think about building Claude Code, how to use it, how to delegate. We're going to have that later back here in the keynote session. But for now, please feel free to enjoy lunch, check out the expo hall as we take a little break. Thank you. What's up? Welcome, everyone. Let's give it up for the SWE Agents track. This is the most packed track. We have 4 more amazing speakers for you. Let's hear it for our SWE Agent speakers. Awesome. We're going to kick off talking about Claude Code and then follow that up with Open Devin. I want to cut my emceeing short. I want to give the speakers their time, but we have a special little announcement. We never do Q&A, but for our first talk for Claude Code, we're going to do a bit of a presentation and do a bit of a Q&A session. Keep your questions short. 5, 10 words, ask something interesting. Think of your question, but without further ado, I want to invite Boris Cherny from Anthropic up to the stage. Think of a question. I'll be back to QA.
Hello. This is awesome. This is a big crowd. Who here has used Claude Code before? Jesus. Awesome. That's what we like to see. Cool. So my name is Boris. I'm a member of technical staff at Anthropic and creator of Claude Code. And I was struggling with what to talk about for audience that already knows Claude Code, already knows AI and all the coding tools and agentic coding and stuff like that. So I'm going to zoom out a little bit, and then we'll zoom back in. So here's my TLDR. The model is moving really fast. It's on exponential. It's getting better at coding very, very quickly, as everyone that uses the model knows. And the product is kind of struggling to keep up. We're trying to figure out what product to build that's good enough for a model like this. And we feel like there's so many more products that could be built for models that are this good at coding. And we're kind of building the bare minimum, and I'll kind of talk about why. And with Claude Code, we're trying to stay unopinionated about what the product should look like, because we don't know. So for everyone that didn't raise your hand, I think that's like 10 of you, this is how you get Claude Code. You can head to claude.ai/code to install it. You can run this incantation to install from NPM. As of yesterday, we support Claude Pro plans, so you can try it on that. We support Claude Max, so yeah, just try it out. Tell us what you think. So programming is changing, and it's changing faster and faster. And if you look at where programming started back in the 1930s, 40s, there was like switchboards, and it was this physical thing. There was no such thing as software. And then sometime in the 1950s, punch cards became a thing. And my grandpa, actually, in the Soviet Union, he was one of the first programmers in the Soviet Union. And my mom would tell me stories about, like, when she grew up in the 1970s or whatever, he would bring these big stacks of punch cards home. And she would, like, from work, and she would, like, draw all over them with crayons. And that was growing up for her. And that's what programming was back in the 1950s, 60s, 70s even. But sometime in the late 50s, we started to see these higher-level languages emerge. So first there was assembly. So programming moves from hardware to punch cards, which is still physical, to software. And then the level of abstraction just went up. So we got to COBOL, then we got to typed languages, we got to C++. In the early 90s, there was this explosion of these new language families. There was, the Haskell family, and JavaScript and Java, the evolution of the C family, and then Python. And I think nowadays, if you kind of squint, all the languages sort of look the same. Like when I write TypeScript, it kind of feels like writing Rust, and that kind of feels like writing Swift, and that kind of feels like writing Go. The abstractions have started to converge a bit. If we think about the UX of programming languages, this has also evolved. Back in the 1950s, you used something like a typewriter to punch holes in punch cards, and that was programming back in the day. And at some point, text editors appeared, and then Pascal and all these different IDEs appeared that let you interact with your programs and your software in new ways, and each one kind of brought something. And I feel like programming languages have sort of leveled out, but the model is on an exponential, and the UX of programming is also on an exponential. And I'll talk a little bit more about that. Does anyone know what was the first text editor? OK, I heard Ed from someone. I think you read the screen. Before text editors, this is what programming looked like. So this was the IBM 029. This was kind of a top of the line. This was like the MacBook of the time for programming punch cards. Everyone had this. You can still find it in museums somewhere. And yeah, this is Ed. This is the first text editor. This was Kem Thompson at Bell Labs invented this. And you know, it kind of looks familiar. If you open your MacBook, you can actually still type Ed. This is still distributed on Unix as part of Unix systems, and this is crazy because this thing was invented like 50 years ago. And this is nuts. Like there's no cursor, there's no scroll back, there's no fancy commands, there's no type ahead, there's pretty much nothing. This is the simple text editor of the time, and it was built for teletype machines, which were literally physical machines that printed on paper. That's how your program was printed. And this is the first software manifestation of a UX for programming software. So it was really built for these machines that didn't support scrollback and cursors or anything like that. For all the Vim fans, I'm going to jump ahead of Vim. Vim was a big innovation. Emacs was a big innovation around the same time. I think in 1980, Smalltalk 80 was a big jump forward. This is one of the first, I think the first graphical interface for programming software. And for anyone that's tried to set up like live reload with React or Redux or any of this stuff, this thing had live reload in 1980, and it worked. And we're still kind of struggling to get that to work with like React.js nowadays. So this was a big jump forward. And obviously, like the language, it had object-oriented programming and a bunch of new concepts. But on the UI side, there's a lot of new things too. In 91, I think Visual Basic was the first code editor that introduced a graphical paradigm to the mainstream. So before people were using text-based editors, Vim and things like that were still very popular despite things like Smalltalk. But this kind of brought it mainstream. This is what I grew up with. Eclipse brought type ahead to the mainstream. This isn't using AI type ahead. This is not Cursor or Windsurf. This is just using static analysis. So it's indexing your symbols, and then it can rank the symbols and re-rank them, and it knows what symbols to show. I think this was also the first big third-party ecosystem for IDs. Copilot was a big jump forward with single-line type ahead and then multi-line type ahead. And I think Devin was probably the first IDE that introduced this next concept and this next abstraction to the world, which is to program, you don't have to write code, you can write natural language, and that becomes code. And this is something people have been trying to figure out for decades. I think Devin is the first product that broke through and took this mainstream. And the UX has evolved quickly, but I think it's about to get even faster. We talked about UX, and we talked about programming languages, and verification is a part of this too. So verification has started with manual debugging and like physically inspecting outputs. And now there's a lot of probabilistic verification, like fuzzing and vulnerability testing, and like Netflix's chaos testing and things like that. And so with all this in mind, Claude Code's approach is a little different. It's to start with a terminal and to give you as low-level access to the model as possible in a way that you can still be productive. So we want the model to be useful for you. We also want to be unopinionated, and we want to get out of the way. So we don't give you a bunch of flashy UI. We don't try to put a bunch of scaffolding in the way. Some of this is we're a model company at Anthropic, and we make models, and we want people to experience those models. But I think another part is we actually just don't know. Like, we don't know what the right UX is, so we're starting simple. And so Claude Code, it's intentionally simple, it's intentionally general. It shows off the model in the ways that matter to us, which is they can use all your tools, and they can fit into all your workflows. So you can figure out how to use the model in this world where the UX of using code and using models is changing so fast. And so this is my second point. The model just keeps getting better. And this is the better lesson. I have it. I have this like framed and taped to the side of my wall. Because the more general model always wins, and the model increases in capability exponentially, and there are many corollaries to this. Everything around the model is also increasing exponentially, and the more general thing, even around the model, usually wins. So with Claude Code, there's one product, and there's a lot of ways to use it. So there's a terminal product, and this is the thing everyone knows. So you can install Claude Code, and then you just run Claude in any terminal. We're unopinionated, So it works in iTerm2, it works in WSL, it works over SSH and tmux sessions. It works in your VS Code terminal, in your cursor terminal. This works anywhere, in any terminal. When you run Claude Code in an IDE, we do a little bit more, so we kind of take over the IDE a little bit, and diffs, instead of being inline in the terminal, they're going to be big and beautiful and show up in the IDE itself. And we also ingest diagnostics, so we kind of try to take advantage of that. And you'll notice this isn't as polished as something like, again, like Cursor, Windsurf. These are awesome products, and I use these every day. This is to let you experience the model in a low-level, raw way. And this is sort of the minimal that we had to do to let you experience that. We announced a couple weeks ago that you can now use Claude on GitHub. Can I get a show of hands who's tried this already? So for everyone that hasn't tried this, all you have to do is you open up Claude, you run this one / command, install GitHub app, you pick the repo, and then you can run Claude in any repo. This is running on your compute. Your data stays on your compute. It does not go to us. So it's kind of a nice experience, and it lets you use your existing stack. You don't have to change stuff around. It takes a few minutes to set up. And again, here, we intentionally built something really simple because we don't know what the UX is yet, and this is the minimal possible thing that helps us learn, but also is useful for engineers to do day-to-day work. Like, I use this every day. The extreme version of this is our SDK. And this is something that you can use to build on Claude Code without, if you don't want to use the terminal app or the IDE integration or GitHub, you can just roll your own integration. You can build it however you want. People have built all sorts of UIs, all sorts of awesome integrations. And all this is you run Claude-P, and you can use it programmatically. And so something I use it for example, is for incident triage. I'll take my GitHub logs, or my GCP logs. I'll pipe it into Claude-P, because it's a Unix utility, so you can pipe in, you can pipe out, and then I'll JQ the result. So it's kind of cool. This is a new way to use models. This is maybe 10% explored. No one has really figured out how to use models as a Unix utility. This is another aspect of code as UX that we just don't know yet. And so again, we just built the simplest possible thing so we can learn and so people can try it out and see what works for you. OK, I wanted to give a few tips for how to use Claude Code. This is a talk about Claude Code, so this is kind of zooming back in. This is actually true for, I think, a lot of coding agents, but this is kind of custom to the way that I personally use Claude Code. So the simplest way to use this, it seems like most of this room is very familiar with Claude Code and similar coding agents. But the simplest way to introduce new people that have not used this kind of tool before is do code-based Q&A. And so at Anthropic, we teach Claude Code to every engineer on day 1, and it's shortened onboarding times from 2 or 3 weeks to 2 days, maybe. And also, I don't get bugged about questions anymore. People can just ask Claude, and honestly, I'll just ask Claude too. And then this is something that I do pretty much every day on Monday. We have a stand-up every week. I'll just ask Claude, what did I ship that week? It'll look through my Git commits, and it'll tell me, so I don't have to keep track. The second thing is teach Claude how to use your tools. And this is something that has not really existed before when you think about the UX of programming. With every IDE, there's sort of like a plugin ecosystem. For Emacs, there's this kind of Lispy dialect that you use to make plugins. If you use Eclipse or VS Code, you have to make plugins. For this new kind of coding tool, it can just use all your tools. So you give it bash tools, you give it MCP tools. Something I'll often say is, here's the CLI tool, Claude, run -- help, take what you learn, and then put it in the Claude MD. And now Claude knows how to use the tool. That's all it takes. You don't have to build a bridge. You don't have to build an extension. There's nothing fancy like that. Of course, if you have groups of tools, or if you have fancier functionality like streaming and things like this, you can just use MCP as well. Traditional coding tools focused a lot on actually writing the code. And I think the new kinds of coding tools, they do a lot more than that. And I think this is a lot of where people that are new to these tools struggle to figure out how to use them. So there's a few workflows that I've discovered for using Claude Code most effectively for myself. The first one is have Claude Code explore and make a plan and run it by me before it writes code. You can also ask it to use thinking. So typically, we see extended thinking work really well if Claude already has something in context. So have it use tools, have it pull things into context, and then think. If it's thinking up front, you're probably just kind of wasting tokens, and it's not going to be that useful. But if there's a lot of context, it does help a bunch. The second one is TDD. I know I try to use TDD. It's like, it's pretty hard to use in practice, but I think now with coding tools, it actually works really well. And maybe the reason is it's not me doing it, it's the model doing it. And so the workflow here is tell Claude to write some tests and kind of describe it and just make it really clear, like the tests aren't going to pass yet. Don't try to run the test because it's going to try to run the test. Tell it, like, you know, it's not going to pass. Write the test first, commit, and then write the code and then commit. And this is kind of a general case of if Claude has a target to iterate against, it can do much better. So if there's some way to verify the output, like a unit test, integration test, a way to screenshot in your iOS simulator, a way to screenshot in Puppeteer, just some way to see its output. We actually did this for robots. Like we taught Claude how to use a 3D printer, and then it has a little camera to see the output. If it can see the output and you let it iterate, the result will be much better than if it couldn't iterate. The first shot will be all right, but the second or third shot will be pretty good. So give it some kind of target to iterate against. Today, we launched plan mode in Claude Code. And this is a way to do the first kind of workflow more easily. So anytime, hit Shift-Tab, and Claude will switch to plan mode. So you can ask it to do something, but it won't actually do that yet. It'll just make a plan, and it'll wait for approval. So restart Claude to get the update, run Shift-Tab. OK, and then the final tip is give Claude more context. There's a bunch of ways to do this. ClaudeMD is the easiest way. So take this file called ClaudeMD, put it in the root of your repo. You can also put it in subfolders. Those will get pulled in on demand. You can put it in your home folder. This will get pulled in as well. And then you can also use slash commands. So if you put files, like just regular Markdown files in these special folders, .claude/commands, it'll be available under the slash menu. So pretty cool. This is useful for reusable workflows. And then to add stuff to ClaudeMD, you can always type the # to ask Claude to memorize something, and it'll prompt you which memory this should be added to. And you can see this is us trying to figure out how to use memory, how to use this new concept that is new to coding models, did not exist in previous IDEs, how to make the UX of this work. And you can tell this is still pretty rough. This is our first version, but it's the first version that works. And so we're going to be iterating on this. And we really want to hear feedback about what works about this UX and what doesn't. Thanks.
Unfortunately, we only have 1 minute left, so someone sent a question on Slack. The question is, as I delegate more and more to Claude Code, as it runs for 10 minutes and I have 10 of these active, how do I use the tool? You got 50 seconds.
Yeah, it's pretty cool. I think this is something that we actually see in a lot of our power users, that they tend to like multi-Claude. You don't just have a single Claude open, but you have a couple terminal tabs, either with a few checkouts of Claude, or of your code base, or it's the same code base, but with different work trees. And you have Claude doing stuff in parallel. This is also a lot easier with GitHub Actions, because you can just spawn a bunch of actions and get Claude to do a bunch of stuff. Typically, we don't need to coordinate between these quads, I think, for most use cases. If you do want to coordinate, the best way is just ask them to write to a Markdown file, and that's it.
Awesome.
Yeah, well, simple thing works.
Thank you so much. And once again, give it up for Boris from Anthropic. Very exciting to see such a full-packed room here. We're going to set up our next speaker, who is Robert Brennan from All Hands. He is the creator and the company behind Open Devin. So a lot of what we see, we've had talks from all the top SWE agents. We've had Jules here. We've got Claude Code. We have OpenAI's Codex. We have Devin. As people use more and more of these SWE agents, are we just, adding tech debt, or are we actually 10x engineers? So this is what Robert is going to discuss with us. I, once again, don't want to fill the stage, so let's hear it for Robert.
Hey, folks. So today I'm going to talk a little bit about coding agents and how to use them effectively, really. If you're anything like me, you found that you found a lot of things that work really well and a lot of things that don't work very well. So a little bit about me. My name is Robert Brennan. I've been building open source development tools for over a decade now. And my team and I have created an open source software development agent called OpenHands, formerly known as OpenDevin. So to state the obvious, in 2025, software development is changing. Our jobs are very different now than they were 2 years ago, and they're going to be very different 2 years from now. And the thing I want to convince you of is that coding is going away. We're going to be spending a lot less time actually writing code. But that doesn't mean that software engineering is going away. We're paid not to type on our keyboard, but to actually think critically about the problems that are in front of us. And so if we do AI-driven development correctly, it'll mean we spend less time actually like leaning forward and squinting into our IDE, and more time kind of sitting back in our chair and thinking, what does the user actually want here? What are we actually trying to build? What problems are we trying to solve as an organization? How can we architect this in a way that sets us up for the future? The AI is very good at that inner loop of development, the write code, run the code, write code, run the code. It's not very good at those kind of big picture tasks that have to take into account, that have to like empathize with the end user, take into account business level objectives. And that's where we come in as software engineers. So let's talk a little bit about what actually a coding agent is. I think this word agent gets thrown around a lot these days. The meaning has started to drift over time. But at the core of it is this concept of agency. It's this idea of taking action out in the real world. And these are the main tools of a software engineer's job, right? We have a code editor to actually modify our code base, navigate our code base. You have a terminal to help you actually run the code that you're writing. And you need a web browser in order to look up documentation and maybe copy and paste some code from Stack Overflow. So these are kind of the core tools of the job, and these are the tools that we give to our agents to let them do their whole development loop. I also want to contrast coding agents from some more tactical code gen tools that are out there. We kind of started a couple years ago with things like GitHub Copilot's autocomplete feature where it's literally wherever your cursor is pointed in the code base right now, it's just filling out 2 or 3 more lines of code. And then over time, things have gotten more and more agentic, more and more asynchronous, right? So we got like AI-powered IDEs that can maybe take a few steps at a time without a developer interfering. And then now you've got these tools like Devin and OpenHands where you're really giving an agent 1 or 2 sentences describing what you want it to do. It goes off and works for 5, 10, 15 minutes on its own, and then comes back to you with a solution. This is a much more powerful way of working. You can get a lot done. You can send off multiple agents at once. You can focus on communicating with your coworkers or goofing off on Reddit while these agents are working for you. And it's a very different way of working, but it's a much more powerful way of working. So I want to talk a little bit about how these agents work under the hood. I feel like once you understand what's happening under the surface, it really helps you build an intuition for how to use agents effectively. And at its core, an agent is this loop between a large language model and the external world. So the large language model kind of serves as the brain. And then we have to repeatedly take actions in the external world, get some kind of feedback from the world, and pass that back into the LLM. So basically, at every step of this loop, we're asking the LLM, what's the next thing you want to do in order to get 1 step closer to your goal? It might say, OK, I want to read this file. I want to make this edit. I want to run this command. I want to look at this web page. We go out and take that action in the real world, get some kind of output, whether it's the contents of a web page or the output of a command, and then stick that back into the LLM for the next turn of the loop. Just to talk a little bit about kind of the core tools that are at the agent's disposal. The first one, again, is a code editor. You might think this is really simple. It actually turns out to be a fairly interesting problem. The naive solution would be to just like give the old file to the LLM and then have it output the entire new file. That's not a very efficient way to work, though. If you've got thousands of lines of code and you want to just change 1 line, you're going to waste a lot of tokens printing out all the lines that are staying the same. So most contemporary agents use like a find and replace type editor or a diff-based editor to allow the LLM to just make tactical edits inside the file. A lot of times they'll also provide like an abstract syntax tree or some kind of way to allow the agent to navigate the code base more effectively. Next up is the terminal. And again, you would think text in, text out should be pretty simple. But there are a lot of questions that pop up here. What do you do when there's a long-running command that has no standard out for a long time? Do you kill it? Do you let the LLM wait? What happens if you want to run multiple commands in parallel, run commands in the background? Maybe you want to start a server and then run curl against that server. Lots of really interesting problems that crop up when you have an agent interacting with the terminal. And then probably the most complicated tool is the web browser. Again, there's a naive solution here where you just, the agent just gives you a URL, and you give it a bunch of HTML. That's very expensive because there's a bunch of cruft inside that HTML that the LLM doesn't really need to see. We've had a lot of luck passing it accessibility trees or converting to Markdown and passing that to the LLM, or allowing the LLM to maybe scroll through the web page if there's a ton of content there. And then also, if you start to add interaction, things get even more complicated. You can let the LLM write JavaScript against the page, or we've actually had a lot of luck basically giving it a screenshot of the page with labeled nodes, and it can say what it wants to click on. This is an area of active research. We just had a contribution about a month ago that doubled our accuracy on web browsing. I would say this is definitely a space to watch. And then I also want to talk about sandboxing. This is a really important thing for agents because if they're going to run autonomously for several minutes on their own without you watching everything they're doing, you want to make sure that they're not doing anything dangerous. And so all of our agents run inside of a Docker container by default. They're totally separated out from your workstation, so there's no chance of it running RMRF on your home directory. Increasingly, though, we're giving agents access to third-party APIs, right? So you might give it access to a GitHub token or access to your AWS account. Super, super important to make sure that those credentials are tightly scoped and that you're following the principle of least privilege as you're granting agents access to do these things. All right, I want to move into some best practices. My biggest advice for folks who are just getting started is to start small. The best tasks are things that can be completed pretty quickly, a single commit, where there's a clear definition of done. You want the agent to be able to verify, OK, the tests are passing, I must have done it correctly, or the merge conflicts have been solved, et cetera. And tasks that are easy for you as an engineer to verify were done completely and correctly. I like to tell people to start with small chores. Very frequently, you might have a pull request where there's one test that's failing, or there's some lint errors, or there's merge conflicts. Bits of toil that you don't really like doing as a developer, those are great tasks to just shove off to the AI. They tend to be very rote. The AI does them very well. But as your intuition grows here, as you get used to working with an agent, you'll find that you can give it bigger and bigger tasks. You'll understand how to communicate with the agent effectively. And I would say for me, for my co-founders, and for our biggest power users, for me, like 90% of my code now goes through the agent, and it's only maybe 10% of the time that I have to drop back into my IDE and kind of get my hands dirty in the code base again. Being very clear with the agent about what you want is super important. I specifically like to say, you need to tell it not just what you want, but you need to tell it how you want it to do it. Mention specific frameworks that you want it to use. If you want it to do like a test-driven development strategy, tell it that. Mention any specific files or function names that it can go for. This not only helps it be more accurate and more clear as to what exactly you want the output to be, it also makes it go faster, right? It doesn't have to spend as long exploring the code base if you tell it, I want you to edit this exact file. This can save you a bunch of time and energy, and it can save a lot of tokens, a lot of actual inference costs. I also like to remind folks that in an AI-driven development world, code is cheap. You can throw code away. You can experiment and prototype. I love if I have an idea, like on my walk to work, I'll just tell open hands with my voice, do X, Y, and Z, and then when I get to work, I'll have a PR waiting for me. 50% of the time, I'll just throw it away. It didn't really work. 50% of the time, it looks great, and I just merge it, and it's awesome. It's really fun to be able to just rapidly prototype using AI-driven development. And I would also say, if you try to work with the agent on a particular task and it gets it wrong, maybe it's close and you can just keep iterating within the same conversation and it's already built up some context. If it's way off, though, just throw away that work, start fresh with a new prompt based on what you learned from the last one. It's really, really, I think, it's a new sort of muscle memory you have to develop to just throw things away. Sometimes it's hard to throw away tens of thousands of lines of code that have been generated because you're used to that being a very expensive bunch of code. These days, it's very easy to kind of just start from scratch again. This is probably the most important bit of advice I can give folks. You need to review the code that the AI writes. I've seen more than one organization run into trouble thinking that they could just vibe code their way to a production application and just automatically merging everything that came out of the AI. But if you just don't review anything, you'll find that your code base just grows and grows with this tech debt. You'll find duplicate code everywhere. Things get out of hand very quickly. So make sure you're reviewing the code that it outputs, and make sure you're pulling the code and running it on your workstation or running it inside of an ephemeral environment, just to make sure that the agent has actually solved the problem that you asked it to solve. And I like to say, trust but verify. As you work with agents over time, you'll build an intuition for what they do well and what they don't do well. And you can generally trust them to operate the same way today that they did yesterday. But you really do need a human in the loop. One of our big learnings with OpenHands, in the early days, if you opened up a pull request with OpenHands, that pull request would show up as owned by OpenHands. It would be the little hands logo next to the pull request. And that caused two problems. One, it meant that the human who had triggered that pull request could then approve it and basically bypass our whole code review system. You didn't need a second human in the loop before merging. And two, oftentimes those pull requests would just languish. Nobody would really take ownership for them. If there was like a failing unit test, nobody was like jumping in to make sure the test passed. And they would just kind of like sit there and not get merged. Or if they did get merged and something went wrong, the code didn't actually work, we didn't really know who to go to and be like, who caused this? There was nobody we could hold accountable for that breakage. And so now if you open up a pull request with OpenHands, your face is on that pull request. You're responsible for getting it merged. You're responsible for any breakage it might cause down the line. Cool. And then I do want to just close just by going through a handful of use cases. This is always kind of a tricky topic because agents are great generalists. They can hypothetically do anything as long as you kind of like break things down into bite-sized steps that they can take on. But in the spirit of starting small, I think there are a bunch of use cases that are like really great day one use cases for agents. My favorite is resolving merge conflicts. This is like the biggest chore as a part of my job. OpenHands itself is a very fast-moving code base. I would say there's probably no PR that I make that I get away with 0 merge conflicts. And I love just being able to jump in and say, add OpenHands, fix the merge conflicts on this PR. It comes in and it's such a rote task. It's usually very obvious, what changed before, what changed in this PR, what's the intention behind those changes, and OpenHands knocks this out 99% of the time. Addressing PR feedback is also a favorite. This one's great because somebody else has already taken the time to clearly articulate what they want changed, and all you have to do is say, add OpenHands, do what that guy said. And again, like you can see in this example, OpenHands did exactly what this person wanted. I don't know React super well, and our front-end engineer was like, do X, Y, and Z, and he mentioned a whole bunch of buzzwords that I don't know. OpenHands knew all of it and was able to address his feedback exactly how he wanted. Fixing quick little bugs. You can see in this example, we had an input that was a text input, should have been a number input. If I wasn't lazy, I could have dug through my code base, found the right file. But it was really easy for me to just quickly, I think I did this one from directly inside of Slack, just add OpenHands, fix this thing we were just talking about. And it's just, really, I don't even have to fire up my IDE. It's a really, really fun way to work. Infrastructure changes I really like. Usually these involve looking up some really esoteric syntax inside of the Terraform docs or something like that. OpenHands and the underlying LLMs tend to just know the right Terraform syntax, and if not, they can look up the documentation using the browser. So this stuff is really great. Sometimes we'll just get an out of memory exception in Slack and immediately say, okay, OpenHands, increase the memory. Database migrations are another great one. This is one where I find I often leave best practices behind. I won't put indexes on the right things. I won't set up foreign keys the right way. The LLM tends to be really great about following all best practices around database migrations. So again, it's kind of like a rote task for developers. It's not very fun. The LLM's great at it. Fixing failing tests, on a PR, if you've already got the code 90% of the way there, there's just a unit test failing because there was a breaking API change, Very easy to call in an agent to just clean up the failing tests. Expanding test coverage is another one I love because it's a very safe task, right? As long as the tests are passing, it's generally safe to just merge that. So if you notice a spot in your code base where you're like, hey, we have really low coverage here, just ask your agent to expand your test coverage in that area of the code base. It's a great quick win to make your code base a little bit safer. Then everybody's favorite, building apps from scratch. I would say if you're shipping production code, again, don't just like vibe code your way to a production application. But we're finding increasingly internally at our company, a lot of times there's like a little internal app we want to build. Like for instance, we built a way to debug open hands trajectories, debug open hand sessions. We built like a whole web application that, since it's just an internal application, we can vibe code it a little bit. We don't really need to review every line of code. It's not really facing end users. This has been a really, really fun thing for our business to just be able to churn out these really quick applications just to serve our own internal needs. Greenfield is a great use case for agents. That's all I've got. Would love to have you all join the Open Hands community. You can find us on GitHub, allhandsai/openhands. Join us on Slack, Discord. We'd love to build with you.
Awesome, awesome. Okay, thank you again, Robert. Very, very exciting to hear about what works and what doesn't work in coding agents. Now, I want to take a bit of time to pause. We're kind of going to change focus for the next few talks. Our next speaker is Josh Albrecht from Imbue, who's going to speak about, a little bit of a meta talk. He's going to give a walkthrough of a case study about Sculptor. Sculptor is kind of their way of how do you verify that your AI coding agents are actually outputting proper code. So we hear these we always hear, how do we go from prototype to production? I'm guilty of this. I've given this talk. I gave it last year, but we always hear about how do you go from prototype to production? You need a human in the loop. How do you go from vibe coding to actual production grade code? And outside of tech debt, Josh is one of the people that has kind of gone very, very deep in this and built Sculptor to exactly solve this. So for our next talk, he's going to go through a case study of as you build coding agents, how do you kind of launch something alongside this? How do you better verify what's going on? And a little bit more about Josh. Josh is kind of a friend that I've known for over a year. We've talked in great depth about coding agents. He's very deep in the space. He's been on the Latent Space podcast before, so if you want to, hear more, feel free to check out the podcast. And same with a lot of the other speakers. Boris from Cloud Code, he's been there as well. But without further ado, I want to invite Josh up pretty soon. I'm gonna kill some more time. We're running a little early. So let's actually get a show of hands. Who in here has started actually shipping SWE agents in production? So outside of using them in your own coding workflows, outside of using Copilots, who has actually shipped a version of a coding Copilot? Who's working directly on the tools? Okay, we have a few hands, so let's get a better idea of what people are working on. Are people in the session here, are we trying to learn how should we better use Copilots? How should we take them to production? How should we build them? What should we know about them? Because Josh's talk is a bit of a case study around this. So who here is in the phase of aggressively using Copilots, kind of vibe coding and trying to take it to that next level? Okay, a lot more hands there. So Josh, a little bit more background for you there. So let's kind of give it off from there. Josh, I think we're ready for you. Awesome.
Thanks. One second. Nope. All right. Cool. Well, yeah, it's great to be here. So I'm Josh Albrecht. I'm the CTO of Imbue, and our focus is on making more robust, useful AI agents. In particular, focusing on software agents right now. And the main product that we're working on today is called Sculptor. So the purpose of Sculptor is to kind of help us with something that we've all experienced. We've all tried these vibe coding tools, and you tell it to go off and do something, it goes off and creates a bunch of code for you, and then, voila, you're done, right? Well, not quite. At least today, there's a big gap between kind of the stuff that comes back and what you want to ship to production, especially as you get away from the prototyping into a larger, more established code bases. So today, I'm going to go over some of the technical decisions that went into the design of Sculptor, our experimental coding agent environment, and kind of go through some of the context and motivations for the various ideas that we've explored and the features that we've implemented. It's still a research preview, so these features may change before we actually release it, but I hope that whether you're an individual using these tools or you're someone who's developing the tools yourself, you'll find these kind of learnings from our experiments to be useful for yourselves. So today, if you're thinking about how you can make coding agents better, then there's a million different things that you could build. You could build something that helps improve the performance on really large context windows. You could make something to make it cheaper or faster. You could make something that does a better job of parsing the outputs. But I don't think that we really should be building any of these things. I think that what we really want to be building is things that are much more specific to the use case or to the problem domain or the thing that you are really specialized in. Most of the things that I just mentioned are going to get solved over the next, call it 3 to 12 to 24 months as models get better, coding agents get better, et cetera. And so I think, just like you wouldn't want to make your own database, I don't think we want to be spending a lot of time working on the problems that are going to get solved. Instead, we want to focus on the particular part of the problem that really matters for us, for our business. And so at Imbue, the problem that we're focusing on is basically this, what is wrong with this diff? You get a coding agent output, and it tells you, OK, I've added 59 new lines. Are those good? Right now, you have an awkward choice between either looking at each of the lines yourself or just hitting merge and kind of hoping for the best. And neither of those are a really great place to be. So we try to give you a third option. The goal is to help build user trust by allowing another AI system to come and take a look at this and understand, hey, are there any race conditions? Did you leave your API key in there, et cetera? So we want to think about how do we help leverage AI tools, not just to generate the code, but to help us build trust in that code. And kind of the way that we think about it is about identifying problems with the code. Because if there's no problems, then it's probably high-quality code, and that's kind of the definition of high-quality code. If you think about it from an academic perspective, the way that people normally measure software quality is by looking at the number of defects. And they look at how long does it take to fix a particular defect, or how many defects are caught by this particular technique. So this is sort of the definition that at least we're working on from when we're thinking about making high-quality software. And then if we think about the software development process, what you want to be doing is getting to a place where you have identified these problems as early as possible. So Sculptor does not work as a pull request review tool, because that's much, much later in the process. Rather, we want something that's synchronous and immediate and giving you immediate feedback. As soon as you've generated that code, as soon as you've changed that line, you want to know, is there something wrong with it? That's easier both for you to fix and also for the agent to fix. So what are some ways that you can prevent problems in AI-generated code? We're going to go through 5 different ways. The first is learning, planning, or sorry, only 4 different ways. Learning, planning, writing specs, and having a really strict style guide. And we'll see how those manifest in Sculptor. So the first thing you want to do when you're using coding agents, if you're trying to prevent problems, is learn what's out there. We try to make this as easy as possible in Sculptor by letting you ask questions, have it do research, get answers about what are the technologies, et cetera, that exist, what are the ways that other people have solved similar problems, so that you don't end up reproducing a bunch of work for what's already out there. Next, we want to think about how we can encourage people to start by planning. Here's a little example workflow where you can kick off the agent to go do something simple like implement this Scrabble solver and change the system prompt here to force the AI agent to first make a plan without writing any code at all. Then you can wait a little while, it'll generate the plan, and then you can go and change the system prompt again to say OK, now we can actually create some code. So we make it really easy to kind of change these types of meta parameters of the coding agent itself. Of course, you can just tell the agent to do that, but by changing its system prompt, you sort of force it in a much stronger way to change its behavior. And you can build up larger workflows by making sort of customized agents for always plan first, then always do the code, then always run the checks, etc. Third, you want to think about writing specs and docs as a kind of first-class part of the workflow. One of the main reasons why, at least I, don't normally write lots of specs and docs in the past has been that it's kind of annoying to keep them all up to date, to spend all this time kind of typing everything out if I already know what the code is supposed to be. But this is really important to do if you want the coding agents to actually have context on the project that you're trying to do, because they don't have access to your email, your Slack, et cetera, necessarily, and even if they did, they might not know exactly how to turn that into code. So in Sculptor, one of the ways that we try to make this easier is by helping detect if the code and the docs have become outdated. So it reduces the barrier to writing and maintaining documentation and doc strings, because now you have a way of more automatically fixing the inconsistencies. It can also highlight inconsistencies or parts of the specifications that conflict with each other, making it easier to make sure that your system makes sense from the very beginning. And finally, you want to have a really strict style guide and try to enforce it. This is important even if you're just doing regular coding without AI agents, just with other human software engineers. But one of the things that is special in Sculptor is that we make suggestions, which you can see towards the bottom here, that help keep the AI system on a reasonable path. So here it's highlighting that you could make this particular class immutable to prevent race conditions, which is something that comes from our style guide, where we try to encourage both the coding agents and our teammates to write things in a more functional, immutable style to prevent certain classes of errors. We're also working on developing a style guide that's sort of custom tailored to AI agents to make it even easier for them to avoid some of the most egregious mistakes that they normally make. But no matter how many things you do to prevent the AI system from making mistakes in the first place, it's going to make some mistakes. And there are many things that we can do to prevent or to detect those problems and prevent them from getting into production. So we'll go through 3 here. First, running linters. Second, writing and running tests. Third, asking an LLM. And we'll dig into each and see how that manifests in Sculptor. So for the first one, for running linters, there are many automated tools that are out there, like Rough or MyPy, PyLint, Pyre, et cetera, that you can use to automatically detect certain classes of errors. In normal development, this is sort of obnoxious because you have to go fix all these really small errors that don't necessarily cause problems. It's a lot of churn and extra work. But one of the great things about AI systems is that they're really good at fixing these. So one of the things that we've built into Sculptor is the ability for the system to very easily detect these types of issues and automatically fix them for you without you having to get involved. Another thing that we've done is make it easy to use these tools in practice. A lot of tools end up like these. How many people here, maybe a show of hands, how many people have a linter set up at all? Okay. How many people have 0 linting errors in their code base? 2, great, we'll hire you. Okay, cool. But it's not easy. But one of the things that we've done in Sculptor is make it so that the AI system understands what issues were there before it started, and then what issues were there after it ran. So at least you can prevent the AI system from creating more errors without you, even if it doesn't work in a perfectly clean code base. Okay, third, testing. So why should you write tests at all? I think I was pretty lazy as a developer for a long time and did not want to write tests because it took a lot of effort. You have to maintain them. I already wrote the code. It works. OK. But one of the major objections to writing tests has kind of disappeared now that we have AI systems. The ability to generate tests is now so easy that you might as well write tests, especially if you have correct code. You can tell the agent, hey, just write a bunch of tests, throw out the ones that don't pass, and just keep the rest. So there's no real reason to not write tests at all. And B, as they say at Google, if you liked it, you should have put a test on it. This becomes much more important with coding agents. The reason is that you don't want your coding agent to go change the behavior of your system in a way that you don't understand and don't expect and don't want to see happen. So at Google, this matters a lot for their infrastructure, because they don't want your site to crash when someone changes something. But if you really care about the behavior of your system, you want to make sure that it's fully tested. So how do we actually write good tests? I'll go through a bunch of different components to this. So first, one of the things that you can do is write code in a functional style. By this, I mean code that has no side effects. This makes it much, much easier to run LLMs and understand if the code is actually successful. You really don't want to be running a test that has access to, say, your live Gmail environment, where if you make a single mistake, you can delete all of your email. You really want to isolate those types of side effects and be able to focus most of the code on the kind of functional transformations that matter for your program. Second, you can try and write two different types of unit tests. Happy path unit tests are those that are ones that show you that your code is working. It's happy, hooray, it worked. You don't need that many of those. You just need a small number to show that things are working as you hope. The unhappy unit tests are the ones that help us find bugs. And here, LLMs can be really, really helpful. So especially if you've written your code in a functional style, you can have the LLM generate hundreds or even thousands of potential inputs, see what happens to those inputs, and then ask the LLM, does that look weird? And often when it says yes, that will be a bug. And so now you have a perfect test case replicating a bug. Third, after you've written your unit tests, it's maybe a good idea to throw them away in some cases. This is a little bit counterintuitive. In the past, we took all this effort and spent all this time trying to write good unit tests, and so we feel some aversion to throwing them away. But now that it's so easy to run LLMs and generate the test suite again from scratch, there's a good reason to not keep around too many unit tests of behavior that you don't care about too much. You might also want to just refactor the ones that you generated into something that's slightly more maintainable. But when you do keep them around, it does kind of confuse the LLM when you come back and change this behavior. So it's something that's at least worth thinking about, whether you want to keep the tests that were originally generated, clean them up, how many of them should you keep, et cetera. Fourth, you should probably focus on integration tests as opposed to testing only the kind of code-level functional behavior of your program. Integration tests are those that show you that your program actually works, like from the user's perspective. Like when the user clicks on this thing, does this other thing happen? AI systems can be extremely good at writing these, especially if you create nice test plans where you can write, OK, when the user clicks on the button to add the item to the shopping cart, then the item is in the shopping cart. If you write that out and then you write the test, then you can write another test plan, like if the user clicks to remove the button, the thing from the shopping cart, then it is gone, that systems can almost always get this right. And so it allows you to work at the level of meaning for your testing, which can be much more efficient. Fifth, you want to think about test coverage as a core part of your testing suite. So if you're having Claude Code write things for you, then you don't care just about the tests working on their own, but you also care, are there enough tests in the first place? If you think back to the original screenshot where we get back our PR of how many lines have changed, if I tell you how many lines have changed, it's not that helpful. If I tell you so many lines have changed and also there's 100% test coverage and also all the tests pass and also a thing looked at the tests and thought they were reasonable, now you can probably click on that merge button without quite as much fear. And sixth, we try to make it easy to run tests in sandboxes and without secrets as much as possible. This makes it a lot easier to actually fix things and makes it a lot easier to make sure that you're not accidentally causing problems or making flaky tests. The third thing that we can do to detect errors is ask an LLM. There are many different things that we can check for, including if there are issues before you commit with your current change, if the thing that you're trying to do even makes sense, if there are issues in the current branch you're working on, if there are violations of rules in your style guide or in your architecture documents, if there are details that are missing from the specs, if the specs aren't implemented, if they're not well tested, or whatever other custom things that you want to check for. One of the things that we're trying to enable in Sculptor is for people to extend the checks that we have so that they can add their own types of best practices into the code base and make sure that they are continually checked. After you've found issues, then you have to fix them. Very little of this talk is about fixing the issues because it ends up being a lot easier for the systems to fix issues than you would expect. I think this quote captures it relatively well, and that a problem well stated is half solved. What this means is that if you really understand what went wrong, then it's much easier to solve the problem. This is especially true for coding agents because the really simple strategies work really well. So even just try multiple times, try 100 times with a different agent, it actually ends up working out quite well. And one of the things that enables this is having really good sandboxing. If you have agents that can run safely, then you can run an almost unlimited number, subject to cost constraints, in parallel. And then if any one of them succeeds, then you can use that solution. And this is really just the beginning. There are going to be so many more tools that are released over the next year or two, and many of the people in this room are working on those tools. There will be things that are not just for writing code like we've been talking about, but for after deployment, for debugging, logging, tracing, profiling, et cetera. There are tools for doing automated quality assurance, where you can have an AI system click around on your website and check if it can actually do the thing that you want the user to do. There are tools for generating code from visual designs. There are tons of dev tools coming out every week. You will have much better contextual search systems that are useful for both you and for the agent. And of course, we'll get better AI-based models as well. If anyone is working on these other sorts of tools that are kind of adjacent to developer experience and helping you fix this much smaller piece of the process, we would love to work together and find out a way to integrate that into Sculptor so that people can take advantage of that. I think what we'll see over the next year or two is that most of these things will be accessible, and it'll make the development experience just a lot easier once all these things are working together. So that's pretty much all that I have for today. If you're interested, feel free to take a look at the QR code, go to our website at imbue.com, and sign up to try out Sculptor. And of course, if you're interested in working on things like this, we're always hiring. We're always happy to chat, so feel free to reach out. Thank you.
Thank you, Josh. I highly recommend picking Josh's brain. I'm sure he'll be around. Find him in the hallways. It's been great. I had countless conversations with Josh. And, just to say once again, what a day. It's been a fully jam-packed day. We have had 8 back-to-back-to-back speakers talking about SWE agents. We started with all the, the originals, the GitHub Copilot, the original coding Copilots. Then we went to the latest and the greatest, right? We've had OpenAI's Codex speak. We've had Claude Code speak. We've had Jules from Google speak. Then we went a little bit into, okay, how do I actually start using these things in production? How do I go past vibe coding? How do I kind of, let's walk through a case study of how we really build these things. And now, for our last talk in the SWE agents track, we have someone who is not building an agent. We have Eno Reyes here from Factory, and he is actually building droids. What does this mean? It's not just hype. Eno is actually working on droids. He is one of the companies from Factory AI that has actually shipped this stuff in production. They are actually in the enterprise. They are growing like crazy. He's been recently on the Latent Space podcast, and they're actually doing this stuff. So Eno is a great speaker. He's spoken for bigger audiences than this. And without any further ado, I want to pass it on to Eno.
Hi, everybody. My name's Eno. I really appreciate that introduction. And maybe I can start with a bit of background. I started working on LLMs about 2.5 years ago when GPT 3.5 was coming out, and it became increasingly clear that agentic systems were going to be possible with the help of LLMs. At Factory, we believe that the way that we use agents, in particular to build software, is going to radically change the field of software development. We're transitioning from the era of human-driven software development to agent-driven development. You can see glimpses of that today. You guys have already heard a bunch of great talks about different ways that agents can help with coding in particular. However, it seems like right now we're still trying to find what that interaction pattern, what that future looks like. And a lot of what's publicly available is more or less an incremental improvement. The current zeitgeist is to take tools that were developed 20 years ago for humans to write every individual line of code, and ultimately tools that were designed first and foremost for human beings. And you sprinkle AI on top, and then you keep adding layers of AI, and then at some point maybe there's some step function change that happens. But there's not a lot of clarity there in exactly what that means. There's a quote that is attributed to Henry Ford. If I had asked people what they wanted, they would have said faster horses. Now, we believe that there are some fundamentally hard problems blocking organizations from accessing the true power of AI. This power can only be found when your team is delegating the majority of their tasks across the software lifecycle to agents. To do that, you need a platform that has an intuitive interface for managing and delegating tasks, centralized context from across all your engineering tools and data sources, agents that consistently produce reliable, high-quality outputs, and infrastructure that supports thousands of agents working in parallel. These are all hard problems to solve, but our team has spent the last 2 years partnering with large organizations to build towards this future. This talk is going to serve as sort of a deep dive into agent-native development and a bit of a share of some of the lessons that we've learned helping enterprise organizations make the transition to agent-native development. When Andrej Karpathy said, "English is the new programming language," he captured this very exciting moment, right? And if you're to judge AI progress based on Twitter, you'd think that you can basically vibe code your way to anything. But vibe coding isn't the approach to solve hard problems. You can't vibe code a legacy Java 7 app that runs 5% of the world's global bank transactions, right? You need a little bit more software engineering. So agents really should not be thought of as a replacement for human ingenuity, right? Agents are climbing gear. And building production software is like scaling Mount Everest. And so while better tools have made this climb more accessible, we still need to think about how to leverage them and use our existing expertise in order to drive this transformation. I want to start with a quick video of what's possible today, right? And so in this, you'll see a quick glimpse of what it's like to delegate a task to an agentic system. You can watch the droid, as we call them, ingest the task and start grounding itself in the environment. It uses tools to search through the code base, determine the Git branch, check out what the machine has available to it. It looks through recent changes to the code base. It looks at memories of its recent interactions with users, as well as memories from its interactions across the entire organization. And then the droid comes back with a plan and says, here's exactly what I'm going to do, but I'd like you to clarify a couple of things, right? We need to expect our agents to not just take what we say at face value, but instead question it and make us better software developers. And so after the user comes back with that info, the droid comes, it executes on that task, it leverages its tools to write code, runs pre-commit hooks, lints, and ultimately generates a pull request that passes CI. But how can you achieve outcomes like this on a regular basis, right? It's nice when it works, but what about when it fails? At the heart of effective AI-assisted development lies a very fundamental truth. AI tools are only as good as the context that they receive. So much of what people are calling prompt engineering is really mentally modeling this alien intelligence that has a slice of context of the real world. And if you start thinking about your AI tools this way, you're going to start to get a lot better at interacting with them. We've investigated thousands of droid-assisted development sessions, and you see this sort of heuristic emerge, where AI is most likely failing to solve the problem, not because the LLMs aren't good enough, but because it's missing crucial context that's required to truly solve it. And better models are going to make this happen less often, but the real solution is not just making the AI smarter. It's going to be getting better at providing these systems with that missing context. LLMs don't know about your morning stand-up. They don't know about the meeting that you had ad hoc and the whiteboard that you did, right? But you can give those things to the LLM if you transcribe your notes, if you take a photo and you upload it, right? You have to start thinking about these things not as tools, but as something in between a coworker and a platform, right? And if you can get that context that lies in the cracks between systems, you use platforms that integrate natively with all of your data sources, and you have agents that can actually make use of those things, you can start actually driving this transition to agent-native development. I want to talk a bit as well about planning and design. When your organization is doing agent-native development, then you are using agents at every stage. Droids don't just write code. They can help with that part, But the hardest thing about software development is not the code. It's about figuring out exactly what to build. Here you can watch a droid as it's tasked with trying to find the most up-to-date information about a new model release and integrate that into an existing chat application. It's going to leverage internet search, its knowledge of your code base, its understanding of your product goals from its org memory, and its understanding of your technical architecture from the design doc you wrote last week. Planning with AI is fundamentally different from planning alone. It's not necessarily just asking, please build this thing for me or give me the design doc, but instead it's about delegating the groundwork and the research to AI agents, then using a collaborative platform to interact and explore possibilities together. That is how you get better at planning with agents. Now you can see here we have a nice document, a nice plan. You could export that to Notion, Confluence, Jira, any of your integrations with no setup because MCP is great, but having every developer have to install a bunch of servers, click a bunch of things, pass around the API key is not necessarily ideal. And so platforms are going to evolve and solve a lot of these problems. But in the meantime, you do have droids. And now, a little bit more on this. The real unlock for AI, transforming your organization with respect to planning, is going to be when you start standardizing the way that your organization thinks, right? And so there's a bit of an example that we just had a couple of weeks ago while we were planning out a feature related to our cloud development environments. We got a lot of feedback from users, and so we had about 3 months of user transcripts. People from enterprises, individuals that we knew. We transcribe every single interaction and meeting at Factory. We take those notes and we combine them with a droid that has access to our architecture. We take an ad hoc meeting that one of our engineers took a granola of. If you guys use granola, I love that tool. And we throw that all to the knowledge droid. And we don't say, let's plan the feature out. We say, could you find any patterns in the customer feedback that map up to our assumptions? Can you highlight any technical constraints with what we have today that might help us make this better? And then we take all of that output, those documents, there's maybe 4 or 5 intermediate results here, and that's what we use to start iterating on a final PRD that helps us outline the full feature. You can take that PRD, and if you have a droid that has access to Linear and Jira with tools to create tickets, create epics, modify those things, then that PRD can be turned into a roadmap. 8 tickets, this ticket's dependent on that ticket, but ultimately, work that can be parallelized amongst a group of 8 code droids, right? And so this is how software is going to evolve. We're going to move from executing to orchestrating systems that work on our behalf. I talked about a couple of these. I think PRDs, Eng design docs, RCA templates, quarterly Eng and product roadmaps, right? Transcriptions of your meetings. Normally, you might see this stuff as a burden, but when your company is doing agent-native software development, your process and your documentation is a knowledge base and a map for your droids to learn and imitate the way that your team thinks. This documentation and process is a conversation with both future developers as well as future AI systems. And so if you can communicate that why behind the decision, that context for those future developers and agents, then you'll start to see that there's a huge lift in their ability to natively work the way that your team actually works. I want to talk about agent-driven development with respect to site reliability engineering. There's a lot that goes into a real incident response. It would be crazy for me to go up here and say you could actually just automate all of SRE and RCA work today. But there is a difference in the AI agent-driven approach, right? Here we're watching a droid take a Sentry incident and convert it into a full RCA and mitigation plan. Traditional incident response is effectively solving a puzzle. The pieces are scattered across dozens of systems, logs in one place, metrics in another, historical context somewhere else. There's knowledge in your team's head. Droids in your organization fundamentally change this, right? When an alert triggers, you can pull in context from relevant system logs, past incident, runbooks in Notion or Confluence, team discussions from Slack. And you can see that a droid that has the tools and the ability to access this can condense that search effort from hours to minutes. And so really, the acceptable time to act for a standard enterprise organization it's really going to be 0, right? The moment that an incident happens, you should have a droid that's telling you exactly what happened, exactly how to fix it. And the thing that gets interesting is when you have user and organization level memory, you really start to build a model of what your team's response patterns and common issues are. And so it's not just generating runbooks or generating a mitigation for one incident, right? But creating new processes that help solve some of these issues. And once you've written that RCA, right, you can move on to generate runbooks for those new learned patterns, update existing response workflows, capture team knowledge that gets shared automatically without the need for manual curation. And this is why all these things are connected. Agent-native incident response is a part of a larger learning cycle that happens when you start to integrate agents into the workflow. We're seeing teams that are able to cut incident response time in half because context is immediate. They're able to reduce repeat incidents because the third time something happens, the droid starts to say, maybe we should fix this. And they're able to improve team collaboration because when a new engineer joins the team and says, how do we do this? It's already in memory. They can just ask the droid how we do this. And so most importantly, what we're seeing in general is a shift from reactive to predictive operations, because you can now start to really see the patterns across the entire operational history. And agentic systems turn each of these incidents into an opportunity to make the entire system far more reliable. AI agents are not replacing software engineers. They're significantly amplifying their individual capabilities. The best developers I know are spending far less time in the IDE writing lines of code. It's just not high leverage. They're managing agents that can do multiple things at once, that are capable of organizing the systems, and they're building out patterns that supersede the inner loop of software development, and they're moving to the outer loop of software development. They aren't worried about agents taking their jobs. They're too busy using the agents to become even better at what they do. The future belongs to developers who understand how to work with agents, not those who hope that AI will just do the work for them. And in that future, the skill that matters most is not technical knowledge or your ability to optimize a specific system, but your ability to think clearly and communicate effectively with both humans and AI. Now, if you find any of this interesting and you want to try the droids, I'm happy to share that everyone here at this talk can use this QR code to sign up for an account. Our mobile experience is not optimized yet, but the droids are on that. And so I'd recommend trying this on a laptop, but you will get 20 million free tokens credited to your account. And I also want to add that first and foremost, Factory is an enterprise platform, right? And so if you're thinking about security, if you're thinking about where are the audit logs, whose responsibility is it when an agent goes and runs remove RF recursive on your code base, right? Our droids don't do that. But if it were to, right, whose responsibility is that? Then these are the types of questions that we're interested in and that we're helping large organizations solve today. And so if you're a security professional, if you're thinking about ownership, auditability, indemnification if you're a lawyer, right, these are the types of questions that you should start asking today, because YOLO mode is probably not the best thing to be running inside your enterprise, right? And so give it a scan, give it a try, check out some of the controls we have, and if you have any questions, feel free to reach out via email. Thanks.
Awesome. Thank you, Eno. What a day of talks, everyone. That's our back-to-back 8 sessions of SWE Agent Talks. OK, logistics. So this is the main keynote room. We're going to be back here in around 3:40 for our ending keynotes. Feel free to, stay, hang out. It's not that long from now. You have about 20 minutes. If you're interested, there's some expo talks going on. Feel free to check out the expo booths, but please do stay. After the keynotes, we have a few more great keynote talks lined up. Everyone will come back to the keynote room, and then we have a few surprises. So one thing very special. Last week, we held a hackathon. We held an AI engineer hackathon, and the finalists of the hackathon have not got their awards yet. They have been spending a week to work a little bit further on their project. They're going to come here and demo on stage, and we're going to pick the winners. There's $10,000 of prizes on the line, so we're going to see some hackathon demos. And of course, at the end, we want to thank our speakers. We have a special trophy ceremony, and we need your help to determine who your favorite speakers were. For the SWE agent track, we're going to reach out. We're going to have a poll. For whoever your favorite speaker is, please vote. Alongside the keynotes, the other tracks, for anything that you've attended, please let us know your favorite speakers. So thank you all for coming. It's been a great talk, a great list of talks, and we hope to see you back soon. So once again, 3:40, we're going to kick off here with keynotes, speaker prizes, and hackathon judging. Thank you, everyone.
even tries it, I'm a shade. But a maze of fate, you find it as to why were you with me? But I get more if I can want you at nine of the parties, Kelly and Jam. Tell me it's all if I low, I feel breathe out either, yeah. Baby, I'm looking for the places. I don't wanna go no paging. I might even write you a drive for, oh. Now be looking for the shade too. You stand out
Ladies and gentlemen, please welcome back to the stage the VP of Developer Relations at Llama Index, Laurie Voss.
Hello, everybody. Welcome back. How's everybody had a good conference day today? All right, so for this next bit, I'm going to try an experiment. There's 4 sort of blocks of you separated by aisles, and so I'm going to divide you into teams. You are team A. You are team B. You are team C. You are team D. Let me hear it from team A. Team C. Team B. Team D. Team A again. All right, I'm not going to do anything with that. That's just to wake you up. We have some great keynotes lined up this afternoon. We're going to hear the results of the State of AI Engineering survey. And if you know anything about me, you know that I love data. I love a good survey. It's my favorite thing to hear about. We're going to hear stories about building OpenRouter. And we're going to hear Sean Grove tell us why prompt engineering is dead, which is sure to be spicy. But our first keynote this afternoon is Trends Across the AI Frontier. So please welcome to the stage co-founder of Artificial Analysis, George Cameron.
Hi, everyone. I'm George, co-founder of Artificial Analysis. A quick background to who we are before we dive into things. Do you see that? Sorry, I think my clicker's not working. Click. Oh, there we go. Great. So a quick background to who we are. We're a leading independent AI benchmarking company. We benchmark a broad spectrum across AI. So we benchmark models for their intelligence. We benchmark API endpoints for their speed, their cost. We also benchmark hardware and all the AI accelerators out there. And we also benchmark a range of modalities, not just language, but also vision, speech, image generation, video generation. And we publish essentially nearly all of it for free on our website, artificialanalysis.ai, whereby we benchmark over 150 different models across a range of metrics. We also publish reports, many of which are publicly accessible, and we also have a subscription for enterprises looking to enter or bring AI to production in their environments in an efficient and effective way. Let's start off with AI progress. Let's set the scene. So it's been a crazy 2 years. I think that we've all felt it in this room, whereby OpenAI kicked off the race with the ChatGPT and GPT 3.5 launch. And since then, it's only gotten more hectic. There's been more and more model releases by more and more labs pushing the AI frontier. So the current state now of frontier AI intelligence. I think this order of models will be familiar to a lot in this room. O3 is the leader, but followed closely by O4 Mini with Reasoning Mode High. DeepSeek R1, the release in the last week or two. Grok 3 Mini Reasoning High. Gemini 2.5 Pro. Claude 4 Opus Thinking. This benchmark is our Artificial Analysis Intelligence Index. It's made up of a composite index of 7 evaluations, which we then weight to develop our Artificial Analysis Intelligence Index, which just provides a generalist perspective on the intelligence of these models. We all have an understanding of what frontier AI intelligence is, but what I want to explore with you today is that there's more than one frontier in AI. There's trade-offs to accessing this intelligence. You shouldn't always use the leading, most intelligent model. And so what we want to do is we want to explore the different frontiers out there. And as an AI benchmarking company, we're going to bring some numbers to the fore to help you reason about this. First, we'll be looking at reasoning models. Next, we'll be looking at the open weights frontier. Third, the cost frontier. And lastly, the speed frontier. There's other frontiers out there that we benchmark, but we'll focus on these key ones today. Starting with reasoning models. What we've done here is we've taken our intelligence index and looked at that relative to the output tokens used to run the intelligence index. So we've measured all of how many tokens each model took to run our 7 evaluations. And we've plotted it on this chart. And you can see 2 distinct groups. It's helpful to think about these separately. So non-reasoning models, which offer less intelligence but require fewer output tokens. And reasoning models, which use more output tokens but offer greater intelligence. And this is important to look at because more output tokens comes with trade-offs, both for request latency as well as cost. We're going to bring some numbers to draw that out and look at the real differences here. Starting with output tokens and the verbosity of these models, just how yappy these reasoning models are. We can see that there's an order of magnitude difference between reasoning and non-reasoning models. It's not just that feeling, oh, this is taking a long time. It's real. It's an order of magnitude. So between GPT 4.1, it required 7 million tokens to run our intelligence index evaluations. But then 04 Mini High took 72 million tokens. And the yappiest of them all, Gemini 2.5 Pro, took 130 million tokens to run our intelligence index. And as mentioned, this has implications for cost as well as end-to-end latency, responsiveness. So looking at latency, we benchmark the API latency of how long it takes to receive a response when accessing these models via their APIs. Here we can see that GPT 4.1 on median across our requests took 4.7 seconds to return a full response. 04 Mini High took over 40 seconds, roughly another 10x or order of magnitude increase. This has implications for applications and uses which require responsiveness, even enterprise kind of chatbots. You don't always reach for 03 in ChatGPT. And Facebook's done a lot of studies on this where they've looked at for consumer apps, where they've looked at user drop-off by application latency, which clearly demonstrate this. Sorry, do you mind if we jump back a slide? And it also has implications for how we're building. So I think particularly with agents, whereby 30 queries in succession is not uncommon. It's a multiplier effect on the latencies for your application and how you can build. If you have faster responses, maybe you can make that 30, 100 queries, for instance. And so putting numbers to that, in terms of agents, 30 is normal. And so even less than 04 Mini, maybe you're at 10 seconds for a reasoning model. If you're running 30 queries, that's 300 seconds that a user might be waiting for a response, or an application might be waiting for a response. That's 5 minutes. If, with the order of magnitudes that we're dealing with here, if that 10 seconds was 1 second, then those 30 queries takes 30 seconds. 30 seconds versus 5 minutes impacts what you can build. Think of a contact center application. That maybe 30 seconds is okay there, but 5 minutes, definitely not. Who likes waiting on the phone that long? Or imagine if you had to use Google, and each time that you wanted to use a function, it took 5 minutes. This impacts how we can build with these models. And so I think bringing numbers to these trade-offs is really important. I'd encourage everybody to measure them. Next, we're going to move to the open weights frontier. Around the time of GPT-4, there was a huge delta in terms of open weights intelligence versus proprietary intelligence. Llama 65B or Llama 270B wasn't close to the intelligence of GPT-4. What I'd like to show here is where we plot our intelligence index by release date, is that gap, it closed until, with great models like mixture late time 7 and Llama 405B. But O1 broke away in late 2024. But then, of course, I think we remember, DeepSeek released V3, I think December 26, ruined some of my Christmas holiday plans. Had to tell my family, I need to go read this paper. It's really exciting. And then, of course, R1 in January. The gap between open weights intelligence and proprietary model intelligence is less than it's ever been, particularly with the recent R1 release in the last couple of weeks, which is only a couple of points different in our intelligence index to the leading models. You can't talk about open weights intelligence without talking about China. The leading open weights models across both reasoning models and non-reasoning models are from China-based AI labs. DeepSeek's leading in both. Alibaba, with their Qwen 3 series, is coming in second in reasoning. But you also have other labs, such as Meta and NVIDIA, with their Nemotron fine-tunes of Llama, coming in close as well. Let's look at the cost frontier. This is really important, and I think similar to end-to-end latency impacts what you can build. So bringing some numbers here, we can really see these order of magnitudes play out. So O3 cost us almost $2,000 to run our intelligence index. TechCrunch actually wrote an article about how much money we were spending on running Evals. We didn't want to read it. You can see 4.1, a great model, is 30 times roughly cheaper in terms of the cost to run our intelligence index compared to O1. And 4.1 nano, over 500 times cheaper to run our intelligence index than O3. You should think about these when building applications. The kind of cost structure of your application might dictate what you can use here and how you use them. Those 30 sequential API calls for your agentic application could be 500 and still be cheaper than an O3 query. A key point to note here with this cost to run intelligence index and why we don't just look at the per token price is that, and the labs maybe don't want you to think this way, but you're paying for the cost per token, but then you're also paying for how verbose the models are, all the reasoning tokens that are output when these models are in their thinking mode. You pay for those as output tokens, even if some of the labs hide them. And so you need to think about this and measure it in your application, and benchmark, not just by the cost per million tokens, but also considering how many reasoning tokens there are and how verbose these models are. You can see even amongst the non-reasoning models, there's big differences between how verbose these models are in responses. So for instance, we'll go to the next slide. Do you mind if we go back one, please? So what we've done here is we're now going to look at the trends in terms of cost. And so what you can see here is we've bucketed models by how intelligent they are, intelligence bands, if you will. And what we can see here is that accessing GPT-4 level of intelligence has fallen over 100 times since mid-23. This is the case across all quality bands. You can see that even when a new quality band, a new frontier is reached, O1 mini in late 24. Quickly, within only a few months, the cost of accessing that level of intelligence halved. This is moving quickly. And so what I would say to you is when building applications, think about what if cost wasn't a barrier when you're building. It's a very important kind of cost exercise, because it might well be that if you build for a cost structure that doesn't work now, then maybe in 6 months' time, that will be possible, and it will be feasible. Next, we're going to look at the speed frontier. So this is how quickly you're receiving tokens, the output speed, output tokens per second that you're receiving after sending an API request. This has been increasing and has increased dramatically since early 23 as well. So similarly, because there's a trade-off typically between intelligence and speed, we've grouped models into certain buckets. And we can see here that they've all increased in terms of how quickly you can access a level of intelligence. So 4.0, I believe, was around 40 output tokens per second. Now you can access, that was in 2023. Who remembers hitting, it wasn't a reasoning model, hitting enter in ChatGPT and just waiting for it to output, especially code, which you want to just copy straight into your editor and hit run, see if it works. Now you can access that level of intelligence at over 300 tokens per second. A few drivers here that I'll go through. It's not the focus of the talk, but important to reference. Model sparsity, so we're seeing more MOEs, mixture of experts models, and they activate only a proportion of parameters at inference time, less compute per token, which means it can go faster, essentially. And MOEs were around back then, but they're getting more and more sparse, a smaller proportion of active parameters. Next, smaller models. Smaller models are getting more intelligent, particularly with distillations, 8B distillations, et cetera. Inference software optimizations like flash attention and speculative decoding. And lastly, hardware improvements. So H100 was faster than A100. Now, we've recently launched benchmarks of the B200 on our artificial analysis website, and it's getting over 1,000 output tokens a second. Think about that relative to the 40 output tokens per second of GPT-4 in 23. There's also specialized accelerators like Cerebras, Sambonova, Grok. I want to share a house view here to frame things. Yes, things are getting more efficient. Yes, the cost of accessing the same level of intelligence is decreasing, and hardware is getting better. We're getting more system output throughput on the chips. But our view is that demand for compute is going to continue to increase. We're going to see larger models. I mean, DeepSeek, it's over 600 billion active, total parameters. And the demand for more intelligence is insatiable. Reasoning models, as we saw, the Yappy models, they require more compute at inference time. And lastly, agents, whereby 20, 30, 100 plus sequential requests to models is not uncommon. These act as multipliers on the demand for compute. And so the house view, playing with these numbers, is net-net, we're going to continue to see compute demand increase. Thanks, everyone. I'm George from Artificial Analysis.
Our next speaker is the founder and CEO of Braintrust and the curator of this year's Evals track. Please join me in welcoming to the stage Ankur Goyal.
Awesome. Excellent. So today we're going to talk a little bit about evals to date and where we think evals are going to be going in the future. Also, for those of you who saw my brother earlier, I'm going to do my best to live up to his energy and charisma. But yeah, it's been an amazing almost 2-year journey for us at Braintrust. We have had the opportunity to work with some of the most amazing companies building, I think, the best AI products in the world. I'm blown away by how many evals people actually run on the product. The average org that signs up for Braintrust runs almost 13 evals a day. Some of our customers run more than 3,000 evals a day. And some of the most advanced companies that are running evals are spending more than 2 hours in the product every day working through their evals. And I think one of the things that stands out to me is, while we have customers building some of the coolest, most automated AI-based products and agents in the world, evals are such a manual process. To date, every time you run an eval, the best thing you can do is look at a dashboard. And I think we have a pretty cool dashboard in Braintrust. But still, it's just a dashboard that you look at and you walk away and think, OK, what changes can I make to my code or to my prompts so that this eval does better? And I actually think that is all going to change. So today, I'm excited to talk about something called Loop. Loop is an agent that we've been working on for some time now that's built into Braintrust. And it's actually only possible because of evals. Every quarter for the last 2 years, we've run evals on the frontier models to see how good they are at actually improving prompts, improving data sets, and improving scorers. And until very, very recently, they actually weren't very good. In fact, we think that Claude 4 in particular was a real breakthrough moment, and it performs almost 6 times better than the previous leading model before it. So Loop runs inside of Braintrust, and it can automatically optimize your prompts all the way to very complex agents. But just as importantly, it also helps you build better data sets and better scorers, because it's really the combination of these 3 things that make for really great evals. This is a little preview of the UI. You can actually start using it today if you are an existing Braintrust user or you sign up for the product. There's a feature flag that you can just flip on called Loop and start using it right away. By default, it uses Claude 4, but you can actually pick any model that you have access to and start using it, whether it's an OpenAI model, a Gemini model, or maybe some of you are building your own LLMs. You can use those as well. And as you can see, it runs directly inside of Braintrust. One of the things that we learned from working with a lot of users is how important it is to actually look at data and look at prompts while you're working with them. And we didn't want that to go away when we introduced Loop. So every time it suggests an edit to your data, or it suggests a new idea for scoring, or it suggests an edit to one of your prompts, you can actually see that side by side directly in the UI. Of course, for the more adventurous among you, there's also a toggle that you can turn on that says, like, just go for it, and it will go and optimize away, which actually works really well. So just to recap, to date, evals have been a critical part of building some of the best AI products in the world, but the task of actually doing evaluation has been incredibly manual. And I'm excited about how over the next year, evals themselves are going to be completely revolutionized by the latest and greatest that's coming out from the frontier models themselves. And we're very excited to incorporate that into Braintrust. Please, if you're not already using the product, try it out. Try out Loop. Give us your feedback. We have a lot of work to do, and we'd love to talk to you. We're also hiring, so if you're interested in working on this kind of problem, whether it's the UI part of it, the AI part of it, or the infrastructure side of it, we'd love to talk to you. You can scan this QR code. It should be over there. Yeah. You can scan the QR code and get in touch with us. We'd love to chat. Thank you.
Our next presenter will provide us some perspectives on the state of AI engineering. Please join me in welcoming to the stage Bar Yaron.
All right, hi everyone. Thank you for having me here, and huge thanks to Ben, to SWE, to all the organizers who've put so much time and heart into bringing this community together. Yeah. All right, so we're here because we care about AI engineering and where this field is headed. So to better understand the current landscape, we launched the 2025 State of AI Engineering Survey, and I'm excited to share some early findings with you today. All right, before we dive into the results, the least interesting slide. I don't know everyone in this audience, but I'm Bar. I'm an investment partner at Amplify, where I'm lucky to invest in technical founders, including companies built by and for AI engineers. And with that, let's get into what you actually care about, which is enough bar and more bar charts. And there are a lot of bar charts coming up. OK, so first, our sample. We had 500 respondents fill out the survey, including many of you here in the audience today and on the live stream. Thank you for doing that. And the largest group called themselves engineers, whether software engineers or AI engineers. While this is the AI engineering conference, it's clear from the speakers, from the hallway chats, there's a wide mix of titles and roles. You even let a VC sneak in. So let's test this with a quick show of hands. Raise your hand if your title is actually AI engineer at the AI engineering conference. OK, that is extremely sparse. Put your hands down. Raise your hand if your title is something else entirely. So that should be almost everyone. Keep it up if you think you're doing the exact same work as many of the AI engineers. All right, so this sort of tracks. Titles are weird right now, but the community is broad, it's technical, it's growing. We expect that AI engineer label to gain even more ground. Couldn't help myself, quick Google trend search, term AI engineering barely registered before late 2022. We know what happened, ChatGPT launched, and the moment for AI engineering interest has not slowed since. OK, so people had a wide variety of titles, but also a wide variety of experience. The interesting part here is that many of our most seasoned developers are AI newcomers. So among software engineers with 10+ years of software experience, nearly half have been working with AI for 3 years or less, and 1 in 10 started just this past year. So change right now is the only constant, even for the veterans. All right, so what are folks actually building? Let's get into the juice. So more than half of the respondents are using LLMs for both internal and external use cases. What was striking to me was that 3 out of the top 5 models and half of the top 10 models that respondents are using for those external cases, for the customer-facing products, are from OpenAI. The top use cases that we saw are code generation and code intelligence and writing assistant content generation. Maybe that's not particularly surprising. But the real story here is heterogeneity. So 94% of people who use LLMs are using it for at least 2 use cases, 82% using it for at least 3. Basically, folks who are using LLMs are using it internally, externally, and across multiple use cases. All right. So you may ask, how are folks actually interfacing with the models, and how are they customizing their systems for these use cases? Besides few-shot learning, RAG is the most popular way folks are customizing their systems. So 70% of respondents said they're using it. The real surprise for me here, I'm looking to gauge surprise in the audience, was how much fine-tuning is happening across the board. It was much more than I had expected overall. In the sample, we have researchers and we have research engineers who are the ones doing fine-tuning by far the most. We also asked an open-ended question for those who were fine-tuning, what specific techniques are you using? So here's what the fine-tuners had to say. 40% mentioned LoRa or QLoRa, reflecting a strong preference for parameter-efficient methods. And we also saw a bunch of different fine-tuning methods, including DPO, reinforcement fine-tuning, and the most popular core training approach was good old supervised fine-tuning. Many hybrid approaches were listed as well. Moving on top of updating systems, sometimes it can feel like new models come out every single week. Just as you finished integrating one, another one drops with better benchmarks and a breaking change. So it turns out more than 50% are updating their models at least monthly, 17% weekly. And folks are updating their prompts much more frequently. So 70% of respondents are updating prompts at least monthly, and 1 in 10 are doing it daily. So it sounds like some of you have not stopped typing since GPT-4 dropped. But I also understand, I have empathy, seeing one blog post from Simon Willison, and suddenly your trusty prompt just isn't good enough anymore. Despite all of these prompt changes, a full 31% of respondents don't have any way of managing their prompts. What I did not ask is how AI engineers feel about not doing anything to manage their prompts. So we have the 2026 survey for that. We also asked folks across the different modalities who is actually using these models at work, and is it actually going well? And we see that image, video, and audio usage all lag text usage by significant margins. I like to call this the multimodal production gap, because I wanted an animation. And this gap still persists when we add in folks who have these models in production, but have not garnered as much traction. OK, what's interesting here is when we add the folks who are not using models at all in this chart, too. So here we can see folks who are not using text, not using image, not using audio, or not using video. And we have 2 categories. It's broken down by folks who plan to eventually use these modalities and folks who do not currently plan to. You can roughly see this ratio of no plan to adopt versus plan to adopt. Audio has the highest intent to adopt. So 37% of the folks not using audio today have a plan to eventually adopt audio. So get ready to see an audio wave. Of course, as models get better and more accessible, I imagine some of these adoption numbers will go up even further. All right, so we have to talk about agents. One question I almost put in the survey was, how do you define an AI agent? But I thought I would still be reading through different responses. So for the sake of clarity, we defined an AI agent as a system where an LLM controls the core decision-making or workflow. 80% of respondents say LLMs are working well at work, but less than 20% say the same about agents. Agents aren't everywhere yet, but they're coming. The majority of folks may not be using agents, but most at least plan to. So fewer than 1 in 10 say that they will never use agents. All to say that people want their agents, and I'm probably preaching to the choir. The majority of agents already in production do have write access, typically with a human in the loop, and some can even take actions independently. So excited as more agents are adopted to learn more about the tool permissioning that folks have access to. If we want AI in production, of course, we need strong monitoring and observability. So we asked, do you manage and monitor your AI systems? This was a multi-select question. So most folks are using multiple methods to monitor their systems. 60% are using standard observability. Over 50% rely on offline eval. And we asked the same thing for how you evaluate your model and system accuracy and quality. So folks are using a combination of methods, including data collection from users, benchmarks, et cetera. But the most popular at the end of the day is still human review. And for monitoring their own model usage, most respondents rely on internal metrics. So storage is important, too. Where does the context live? How do we get it when we need it? 65% of respondents are using a dedicated vector database. And this suggests that for many use cases, specialized vector databases are providing enough value over general purpose databases with vector extensions. Among that group, 35% said that they primarily self-host, 30% primarily use a third-party provider. All right. I think we've been having fun this whole time, but we're entering a section I like to formally call Other Fun Stuff. I spent hours workshopping the name. So we asked AI engineers, should agents be required to disclose when they're AI and not human? Most folks think yes, agents should disclose that they're AI. We asked folks if they'd pay more for inference time compute, and the answer was yes, but not by a wide margin. And we asked folks if transformer-based models will be dominant in 2030. And it seems like people do believe that attention is all we'll need in 2030. The majority of respondents also think open source and closed source models are going to converge, so I will let you debate that after. No commentary needed here. So the average or the mean guess for the percentage of US Gen Z population that will have AI girlfriends, boyfriends is 26%. I don't really know what to say or expect here, but we'll see. We'll see what happens in a world where folks don't know if they're being left on red or just facing latency issues. Or, of course, the dreaded, it's not you, it's my algorithm. And finally, we asked folks, what is the #1 most painful thing about AI engineering today? And evaluation topped that list. So it's a good thing this conference and the talk before me has been so focused on evals, because clearly they're causing some serious pain. OK, and now to bring us home, I'm going to show you what's popular. So we asked folks to pick all the podcasts and newsletters that they actively learn something from at least once a month. And these were the top 10 of each. So if you're looking for new content to follow and to learn from, this is your guide. Many of the creators are in this room, so keep up the great work. And I'll just shout out that SWE is listed both on popular newsletter and popular podcast for latent space. So I will just leave this here. I think that's enough bar charts and bar time. But if you want to geek out about AI trends, you can come find me online in the hallways. We're going to be publishing a full report next week. I'll let Elon and Musk have Twitter today. But it's going to include more juicy details, including everyone's favorite models and tools across the stack. Thank you for the time. Enjoy the afternoon.
Our next presenter co-founded OpenSea, the first NFT marketplace, and grew it to over $4 billion in monthly volume from 2017 to 2022. He then founded OpenRouter in 2023, the first LLM aggregator and distributor, processing over 2 trillion tokens weekly across over 400 unique language models. He's here to tell us fun stories from building OpenRouter and provide some predictions on where all this is going. Please join me in welcoming to the stage Alex Atala.
All right. I can't go back. Well, when I started OpenRouter at the beginning of 2023, I had one major question in mind. I was looking at this new market that was coming online, and it was incredible. At the very end of 2022, we all saw ChatGPT, and I got bitten by the AI bug. And I decided to look into answering this question, will this market be winner take all? Inference might be the largest market ever in software. And this seemed like a critical thing that everybody was assuming the answer to it would be yes. OpenAI was just far and away the leading model. There were a few others that were coming up on its tail. And I built a couple prototypes to look into what they could be used for, and also wanted to investigate open source. So in this talk, which SWE named, I'm going to talk about the founding story of OpenRouter and go through a little bit of the hoops that we jumped through and sort of the investigation that we did as we put together this product that started as an experiment and kind of evolved into a marketplace over time. In January, we saw the first signs of people wanting other types of models. And the first evidence was moderation. This was like a very clear interest from users in looking for models where they could understand whether they'd be deplatformed or what the moderation policy of the company was. And we saw some people like generating novels where like it would be a detective story, and in chapter 4, the detective would find someone who like commits a murder and shoots the victim. And OpenAI at the time sometimes refused to generate that output, or it was like questionably against the terms of service. And of course, we saw role play and basically a big gray area emerge around what models were willing to generate. So in the next month, we saw the open source race begin. And that, I'm going to do a little bit of an OG test here. Raise your hand if you ever used Bloom 176B. There's like 10 hands raised, or OPT by Facebook. This was like one of the earliest open source language models, about 5 hands raised. There were a couple of these emerging, and there were some very interesting projects to help people access them. And early days, they weren't really useful for very much. So we kept digging, and eventually, like, the open source community ran into Meta's first launch, which was Llama 1 in February. And Llama 1, in their abstract, advertised that it outperformed GPT-3 on most benchmarks. You can see the highlighted part here, which blew everyone away. This was huge, an open weights model better than GPT-3. And especially a smaller model. This was the 13 billion parameter version, one that you could run on your laptop, outperforming a large server-only, only like, tons of money required to run inference companies model. And it was beating it on some benchmarks. Everyone lost their minds. And Llama kicked off a huge storm. It still was not very useful, I have to say. It was like a text completion model for the most part. And it was very difficult to run locally. The infrastructure just wasn't there. And people were struggling to figure out what to do with it, which is when we had the greatest moment of all, I think, for the birth of the long tail of language models, which was the first successful distillation in March of 2023, Alpaca. A group at Stanford took Llama 1, generated a bunch of outputs on GPT-3, and fine-tuned Llama 1 on those outputs, and created Alpaca for less than $600 in total. And this was an incredible moment. It was the first time I saw the transference of both style and knowledge from a large model onto a small one. And this was a huge unlock, because it meant that not only did you not need a $10 million training budget to create your own models, but you could also, for the first time, make unique data available as a service in the form of a language model. And I immediately began to wonder, like, well, there's going to be tens of thousands of these, maybe hundreds of thousands. And they seem incredibly important. This is knowledge finally being distilled into software. There needs to be a place on the internet to discover these and understand what they do. Because even this open weights model was still closed in a way. It's a black box. You get 7 billion floating point numbers. You don't know what it's good at or what to do with it. Very few people used Alpaca. Raise your hands if you used Alpaca. I see about 50, maybe 12. So it's like only double the number of people who used the almost unusable open source models on the previous slide. So Open Router initially started as a place to collect all these things. But before we got there, I wanted to check out people's willingness to bring their own model to generic websites. Like, what if the developer didn't even know which model a user wanted to use? How would a user bring their choice of model to the software that they want? And in April, I launched Window AI, which was an open source Chrome extension that let a user choose their model and let a web app just kind of suck it in. And so you can see from the Chrome extension here, if you look really closely, this user is using Together's open source deployment of GPT Next. I can't read it from here, but like an open source model that swaps out OpenAI directly inside the web page. So the next month, Open Router launched, and I co-founded it with the founder of the framework that that Window AI was built on, Plasmo, Lewis. And we started Open Routers, first a place to collect all the models in one spot and help people figure out what to do with them. And it eventually grew into a place that gives you better prices, better uptime, no subscription, and the most choice for figuring out which intelligence your software should run. So let's talk a little bit about what it is, because not everyone here might be familiar with it. We have been growing 10 to 100% month over month for the last 2 years. It is an API that lets you access all language models, and it's also become kind of the go-to place for data about who's using which model and how that is changing over time, which you can see on our public rankings page here. It's a single API that you pay for once. You get near zero switching costs to go from model to model. And we have about over 400 models, over 60 active providers. And you can buy with lots of different payment methods, including crypto. And we basically do all the tricky work of normalizing tool calls and caching for you so that you get the best prices and the most features, and you don't have to worry about what the provider supports. Another story. Initially, Open Router was not a marketplace, really. It was just kind of a collection of all the models and a way to explore data about who was using each one. So how did we get here? Initially, when the first open source models emerged, we only had like 1 or 2 providers for each one, and so we had like a primary provider and a fallback provider. And initially, that was it, and we didn't even name the providers. But it became clear that there were going to be a bunch of companies that wanted to host these models, and at very different prices and performances. The number of features ballooned. There were companies that supported the min-p sampler, and most didn't. There were some that supported caching, some that supported tool calling and structured outputs, and others that didn't. And suddenly the ecosystem was just ballooning into this kind of out-of-control, heterogeneous monster. And we wanted to tame the monster. So we aggregated all providers in one spot, and at different price points, it became a marketplace. And you can see, like this model, Llama 3.3 70B Instruct, has one of the models with the most providers on the platform, and it has like 23. Closed source models also had something interesting happen to them, which is that they couldn't keep up with the demand. And so we help developers basically get uptime boosting, and you can see like the delta and how much we can boost uptime just by aggregating lots of different providers for a model. And this became really helpful for people using open source or closed source. And we became a marketplace for both, showing graphs about latency and throughput and helping people figure out using real-world data what the latency and throughput is on each model. And that's how Open Router became a marketplace and one optimized for language models, which I thought would be proper for inference, but potentially the biggest market in software. You can, obviously, a couple other things that we support, comparing models using your own prompts with the ease of just texting an iMessage, fine-grained privacy controls with API-level overrides, the ability to see like your usage of all models in one place and have great observability. And back to the original question here of whether will intelligence be winner take all, we've come to the most likely bet that that is not the case. Here's our data broken down by model author, how many tokens have been processed by each one. And you can see Google Gemini started pretty low, like roughly 2-3% in June of last year, and just has grown to 34-35% pretty steadily over the last 12 months. Anthropic is like one of the most popular models on our platform. OpenAI is a little bit underrepresented in this data because a lot of developers use us to get OpenAI-like behavior for all other models. But OpenAI has grown a lot here as well. So here's what we believe about the market after all of the backstory that I just gave you. The future is going to be multi-model. All of our customers, tons of customers use different models for different purposes and realize they can unlock huge gains by doing so. Inference is also a commodity. Claude from Bedrock, we want to make look exactly the same as Claude from Vertex. And we do that because the two hyperscalers have fundamentally the same commodity being delivered at different rates, different performances. And for a developer, you just want to be able to select that without worrying about who's serving it. We think inference will be like a dominant operating expense, and selecting and routing will be crucial. You can see the number of active models on OpenRouter has just steadily grown. It's not the case that people just hop from model to model. It tends to be sticky. And we're trying to just make this wild ecosystem a lot more homogeneous and easier to work with as a developer. To honor Swix's title for this presentation, let's give a technical story, something that we've worked on in the process of building the company. And that was our own idea for how to do an MCP within OpenRouter. So we don't have MCPs, we don't have an MCP marketplace, but we did run into the need to expand inference with new features and new abilities. For example, searching the web for all models, PDF parsing for all models, other interesting things coming soon. And what we really wanted to do was give these abilities to all models. But that involves not just the pre-flight work that MCPs do today, where you can kind of get in, call another API, get a bunch of behaviors, and then have the inference process access those behaviors as it goes. We also need the ability to transform the outputs on the way to the user. And so what we really, really needed was something more like middleware. Middleware is kind of a common concept in web development. You set up middleware when you're setting up authentication, for example, or caching for a web app. And so we came up with a type of middleware that's AI native and optimized for inference, and that looks not totally dissimilar from the way middleware it looks in Next.js or web development. So pardon the code on the screen, but this is a little bit about how our plugin system looks, and it can call MCPs from inside a plugin. But importantly, it can also augment the results on the way back to the user. So here's an example of our web search plugin, which augments every language model with the ability to search the web. Every language model can just kind of tap in to this plugin and get web annotations as results are being fed back to users in real time. And this all happens in a stream. So there's no kind of requirement that you get all of the tokens at once. It can just happen live in the stream. We solved a bunch of other tricky problems while building OpenRouter. We really wanted to get extremely low latency. And we got it down to about 30 milliseconds, the best in the industry, I believe, using a lot of custom cache work. And we also need to make streams cancelable. All these different providers have completely different stream cancellation policies. Sometimes if you just drop a stream, the inference provider will bill you for the entire thing. Sometimes it won't. Sometimes it'll bill you for the next 20 tokens that you never got. And we work a lot to try to figure out these edge cases and understand when developers are going to care about them too. And standardizing all these providers and models became a big, tricky architecture problem that we spent a while working on. So here's where all this is going. We're going to add more modalities to OpenRouter, and I think this is a big change in the industry as well. We're going to start seeing LLMs generate images. We already have a few examples on the market, but some people call it transfusion models, a transformer mixed with stable diffusion. These are going to give images way more world knowledge and the ability to have a conversation with the image. which we think is just critical for growing that industry, making it really work. Imagine, I just ran into somebody today who is using a transfusion model, or who told me about their customer using a transfusion model to generate menus. Imagine doing that, like a whole menu like in a delivery app generated by a transfusion model. It's going to be really exciting and a big deal in the coming year. We're also going to work on much more powerful routing. Like routing is our bread and butter. And so doing geographical routing, right now it's pretty minimal, but routing people to the right GPU in the right place and doing enterprise level optimization is coming. Better prompt observability, better discovery of models, like really fine-grained categorization. You know, imagine being able to see like the best models that take Japanese and create Python code. And of course, even better prices coming soon. So, you know, we believe in collaboration and building an ecosystem that's durable and with low vendor lock-in. So, you know, collaborate with us. Here's our email, and if you're interested, join us too. Thank you.
Our next speaker works on alignment reasoning at OpenAI, helping translate high-level intent into enforceable specs and evaluations. Please join me in welcoming to the stage Sean Grove.
Hello, everyone. Thank you very much for having me. It's a very exciting place to be, very exciting time to be. Give me a second. I mean, this has been like a pretty intense couple of days. I don't know if you feel the same way, but also very energizing. So I want to take a little bit of your time today to talk about what I see as the coming of the new code, in particular specifications, which sort of hold this promise that it has been the dream of the industry where you can write your code, your intentions once, and run them everywhere. Quick intro, my name is Sean. I work at OpenAI, specifically in alignment research. And today, I want to talk about sort of the value of code versus communication, and why specifications might be a little bit of a better approach in general. I'm going to go over the anatomy of a specification, and we'll use the model spec as the example. And we'll talk about communicating intent to other humans. And we'll go over the 4.0 sycophancy issue as a case study. We'll talk about how to make this specification executable, how to communicate intent to the models, and how to think about specifications as code, even if they're a little bit different. And we'll end on a couple of open questions. So let's talk about code versus communication. Real quick, raise your hand if you write code, and vibe code counts. Cool. Keep them up if your job is to write code. Okay? Now, for those people, keep your hand up if you feel that the most valuable professional artifact that you produce is code. Okay? There's quite a few people, and I think this is quite natural. We all work very, very hard to solve problems. We talk with people, we gather requirements, we think through implementation details, we integrate with lots of different sources, and the ultimate thing that we produce is code. Code is the artifact that we can point to, we can measure, we can debate, and we can discuss. It feels tangible and real. But it's sort of underselling the job that each of you does. Code is sort of 10 to 20% of the value that you bring. The other 80 to 90% is in structured communication. And this is going to be different for everyone, but a process typically looks something like you talk to users in order to understand their challenges. You distill these stories down and then ideate about how to solve these problems. What is the goal that you want to achieve? You plan ways to achieve those goals. You share those plans with your colleagues. You translate those plans into code. So this is a very important step, obviously. And then you test and verify, not the code itself, right? No one cares actually about the code itself. What you care is, when the code ran, did it achieve the goals? Did it alleviate the challenges of your user? You look at the the effects that your code had on the world. So talking, understanding, distilling, ideating, planning, sharing, translating, testing, verifying. These all sound like structured communication to me. And structured communication is the bottleneck. Knowing what to build, talking to people and gathering requirements, knowing how to build it, knowing why to build it, and at the end of the day, knowing if it has been built correctly and has actually achieved the intentions that you set out with. And the more advanced AI models get, the more we are all going to starkly feel this bottleneck. Because in the near future, the person who communicates most effectively is the most valuable programmer. And literally, if you can communicate effectively, you can program. So let's take vibe coding as an illustrative example. Vibe coding tends to feel quite good. And it's worth asking, why is that? Well, vibe coding is fundamentally about communication first, and the code is actually a secondary downstream artifact of that communication. We get to describe our intentions and the outcomes that we want to see, and we let the model actually handle the grunt work for us. And even so, there is something strange about the way that we do vibe coding. We communicate via prompts to the model, and we tell them our intentions and our values, and we get a code artifact out at the end. And then we sort of throw our prompts away. They're ephemeral. And if you've written TypeScript or Rust, once you put your code through a compiler or it gets down into a binary, no one is happy with that binary. That wasn't the purpose. It's useful. In fact, we always regenerate the binaries from scratch every time we compile or we run our code through V8 or whatever it might be from the source spec. It's the source specification that's the valuable artifact. And yet when we prompt LLMs, we sort of do the opposite. We keep the generated code and we delete the prompt. And this feels like a little bit like you shred the source and then you very carefully version control the binary. And that's why it's so important to actually capture the intent and the values in a specification. A written specification is what enables you to align humans on the shared set of goals and to know if you are aligned, if you're actually synchronized on what needs to be done. This is the artifact that you discuss, that you debate, that you refer to, and that you synchronize on. And this is really important, so I want to nail this home, that a written specification effectively aligns humans. And it is the artifact that you use to communicate and to discuss and debate and refer to and synchronize on. If you don't have a specification, you just have a vague idea. Now let's talk about why specifications are more powerful in general than code. Because code itself is actually a lossy projection from the specification. In the same way that if you were to take a compiled C binary and decompile it, you wouldn't get nice comments and well-named variables. You would have to work backwards. You'd have to infer, what was this person trying to do? Why is this code written this way? It isn't actually contained in there. It was a lossy translation. And in the same way, code itself, even nice code, typically doesn't embody all of the intentions and the values in itself. You have to infer what is the ultimate goal that this team is trying to achieve when you read through code. So communication, the work that we establish, we already do, when embodied inside of a written specification, is better than code. It actually encodes all of the necessary requirements in order to generate the code. And in the same way that having a source code that you pass to a compiler allows you to target multiple different architectures. You can compile for ARM64, or x86, or WebAssembly. The source document actually contains enough information to describe how to translate it to your target architecture. In the same way, a sufficiently robust specification given to models will produce good TypeScript, good Rust, servers, clients, documentation, tutorials, blog posts, and even podcasts. Show of hands, who works at a company that has developers as customers? OK, so a quick thought exercise is, if you were to take your entire code base, all of the documentation, or so all of the code that runs your business, and you were to put that into a podcast generator, could you generate something that would be sufficiently interesting and compelling, that would tell the users how to succeed, how to achieve their goals? Or is all of that information somewhere else? It's not actually in your code. And so moving forward, the new scarce skill is writing specifications that fully capture the intent and values. And whoever masters that, again, becomes the most valuable programmer. And there's a reasonable chance that this is going to be the coders of today. This is already very similar to what we do. However, product managers also write specifications. Lawmakers write legal specifications. This is actually a universal principle. So with that in mind, let's look at what a specification actually looks like. And I'm going to use the OpenAI model spec as an example here. So last year, OpenAI released the model spec. And this is a living document that tries to clearly and unambiguously express the intentions and values that OpenAI hopes to imbue its models with that it ships to the world. And it was updated in February and open sourced. So you can actually go to GitHub and you can see the implementation of the model spec. And surprise, surprise, it's actually just a collection of Markdown files. Just looks like this. Now, Markdown is remarkable. It is human readable, it's versioned, it's change-logged, and because it is natural language, everyone, not just technical people, can contribute, including product, legal, safety, research, policy. They can all read, discuss, debate, and contribute to the same source code. This is the universal artifact that aligns all of the humans as to our intentions and values inside of the company. Now, as much as we might try to use unambiguous language, there are times where it's very difficult to express the nuance. So every clause in the model spec has an ID here. So you can see SY73 here. And using that ID, you can find another file in the repository, sy73.markdown, or MD, that contains one or more challenging prompts for this exact clause. So the document itself actually encodes success criteria that the model under test has to be able to answer this in a way that actually adheres to that clause. So let's talk about sycophancy. Recently, there was an update to 4.0. I don't know if you've heard of this. Caused extreme sycophancy. And we can ask, what value is the model spec in this scenario? And the model spec serves to align humans around a set of values and intentions. Here's an example of sycophancy where the user calls out the behavior of being sycophant or sycophantic at the expense of impartial truth, and the model very kindly praises the user for their insight. There have been other esteemed researchers who have found similarly concerning examples. And this hurts. Shipping sycophancy in this manner erodes trust. It hurts. So, and it also raises a lot of questions. Was this intentional? You could see some way where you might interpret it that way. Was it accidental, and why wasn't it caught? Luckily, the model spec actually includes a section dedicated to this since its release that says, don't be sycophantic. And it explains that while sycophancy might feel good in the short term, it's bad for everyone in the long term. So we actually expressed our intentions and our values, and we're able to communicate it to others through this. So people could reference it. And if we have it in the model specification, if the model specification is our agreed upon set of intentions and values, and the behavior doesn't align with that, then this must be a bug. So we rolled back, we published some studies and some blog posts, and we fixed it. But in the interim, the spec served as a trust anchor, a way to communicate to people what is expected and what is not expected. So if the only thing the model specification did was to align humans along those shared sets of intentions and values, it would already be incredibly useful. But ideally, we can also align our models and the artifacts that our models produce against that same specification. So there's a technique, a paper that we released called deliberative alignment that sort of talks about this, how to automatically align a model. And the technique is such where you take your specification and a set of very challenging input prompts, and you sample from the model under test or training. You then take its response, the original prompt and the policy, and you give that to a grader model. And you ask it to score the response according to the specification. How aligned is it? So the document actually becomes both training material and eval material. And based off of this score, we reinforce those weights. And it goes from, you could include your specification in the context, and then maybe a system message or developer message, in every single time you sample. And that is actually quite useful. A prompted model is going to be somewhat aligned. But it does detract from the compute available to solve the problem that you're trying to solve with the model. And keep in mind, these specifications can be anything. They could be code style, or testing requirements, or safety requirements. All of that can be embedded into the model. So through this technique, you're actually moving it from a inference time compute, and actually you're pushing down into the weights of the model, so that the model actually feels your policy and is able to sort of muscle memory style apply it to the problem at hand. And even though we saw that the model spec is just Markdown, it's quite useful to think of it as code. It's quite analogous. These specifications, they compose, they're executable, as we've seen. They are testable. They have interfaces where they touch the real world. They can be shipped as modules. And whenever you're working on a model spec, there are a lot of similar sort of problem domains. So just like in programming, where you have a type checker, the type checker is meant to ensure consistency, where if interface A has a dependent module B, they have to be consistent in their understanding of one another. So if Department A writes a spec and Department B writes a spec, and there is a conflict in there, you want to be able to pull that forward and maybe block the publication of the specification. As we saw, the policy can actually embody its own unit tests. And you can imagine sort of various linters, where if you're using overly ambiguous language, you're going to confuse humans, and you're going to confuse the model, and the artifacts that you get from that are going to be less satisfactory. So specs actually give us a very similar tool chain, but it's targeted at intentions rather than syntax. So let's talk about lawmakers as programmers. The US Constitution is literally a national model specification. It has written text, which is aspirationally at least clear and unambiguous policy that we can all refer to. And it doesn't mean that we agree with it, but we can refer to it as the current status quo, as the reality. There is a versioned way to make amendments, to bump, and to publish updates to it. There is judicial review, where a grader is effectively grading a situation and seeing how well it aligns with the policy. And even though even though the source policy is meant to be unambiguous, sometimes you don't, the world is messy. And maybe you miss part of the distribution, and a case falls through. And in that case, there is a lot of compute spent in judicial review, where you're trying to understand how the law actually applies here. And once that's decided, it sets a precedent. And that precedent is effectively an input-output pair that serves as a unit test that disambiguates and reinforces the original policy spec. It has things like chain of command embedded in it. And the enforcement of this, over time, is a training loop that helps align all of us towards a shared set of intentions and values. So this is one artifact that communicates intent. It adjudicates compliance, and it has a way of evolving safely. So it's quite possible that lawmakers will be programmers, or inversely, that programmers will be lawmakers in the future. And actually, this is a very universal concept. Programmers are in the business of aligning silicon via code specifications. Product managers align teams via product specifications. Lawmakers literally align humans via legal specifications. And everyone in this room, whenever you are doing a prompt, it's a sort of proto-specification. You are in the business of aligning AI models towards a common set of intentions and values. And whether you realize it or not, you are spec authors in this world. And specs let you ship faster and safer. Everyone can contribute, and whoever writes the spec, be it a PM, a lawmaker, an engineer, a marketer, is now the programmer. And software engineering has never been about code. Going back to our original question, a lot of you put your hands down when you thought, well, actually, the thing I produce is not code. Engineering has never been about this. Coding is an incredible skill and a wonderful asset, but it is not the end goal. Engineering is the precise exploration by humans of software solutions to human problems. It's always been this way. We're just moving away from sort of the disparate machine encodings to a unified human encoding of how we actually solve these problems. I want to thank Josh for this credit. So I want to ask you, put this in action. Whenever you're working on your next AI feature, start with the specification. What do you actually expect to happen? What success criteria look like? Debate whether or not it's actually clearly written down and communicated. Make the spec executable. Feed the spec to the model, and test against the model, or test it against the spec. And there's an interesting question sort of in this world, given that there's so many parallels between programming and spec authorship. I wonder what does the IDE look like in the future? You know, an integrated development environment. And I'd like to think it's something like an integrated thought clarifier, where whenever you're writing your specification, it sort of pulls out the ambiguity and asks you to clarify it. And it really clarifies your thoughts so that you and all human beings can communicate your intent to each other much more effectively and to the models. And I have a closing request for help, which is what is both amenable and in desperate need of specification. This is aligning agents at scale. I love this line of like, then you realize that you never told it what you wanted, and maybe you never fully understood it anyway. This is a cry for specification. We have a new agent robustness team that we've started up, so please join us and help us deliver safe AGI for the benefit of all humanity. And thank you. I'm happy to chat.
Ladies and gentlemen, please welcome to the stage the founders of the AI Engineer World's Fair, Benjamin, Dunphy, and Swix.
All right. Choose to mirror or extend display. I'd love to have my notes from the house slides, please. Thank you. All right. How are we feeling? I hope you're not as exhausted as me, but sufficiently exhausted. I hope we all had a wonderful conference. But we have one more special treat for you. We're excited to present the finalists for the very first official AI Engineer Hackathon. We partnered with Cerebral Valley, the largest AI community in the world, and Legends, right here in the Bay Area, for running hackathons for the very first official AI Engineer Hackathon. From 500 applicants, 160 engineers came together to learn, connect, and build together. 46 projects presented on site, and 3 were selected as finalists. And today, we have those 3 finalists with us, and they will each present their 48-hour builds for us in under 5 minutes. And all of you in the audience are going to be the judge. But thanks to being smitten by the Wi-Fi gods, we have decided to go old Athenian style. By the roar of the crowd, are you not entertained? The 3 teams listed here in the order that they will present. Have we confirmed that, Rove? Is this the actual order they're coming on? I certainly hope so. Team 1, survival of the feature. Team 2, tab RL. Team 3, featherless action R1. Do what you have to do to remember the order. Take some notes on what you like best, because we're going to come back and roar as soon as they're done after these 15 minutes. So I'll let Swix proceed with the intro.
Yeah, these are all very competitive teams. I think they're coming up now. They are, what can I say? I was actually, I think, in the room when these guys were presenting for the final round. And like everyone was very, very impressed. Like they were like, how does this not exist already? So I think I should just kind of let them take it away because I don't want to steal their thunder. But I did insist on printing these trophies, so we're going to hand them out. It's mostly just appreciation, but I think we also want to try to make AI Engineer a place where people can get recognition for their work by speaking, by posting. Thank you. We worked really hard on these. They got here 2 hours ago. Overnight delivery started on Monday and then went to Tuesday. And anyway, so I think these are ready, so I don't want to take away their time. Survival of the feature, folks.
So we're here at the World's Fair, and we're all builders. So we want to ship as fast as possible so we can get feedback from users as fast as possible, shorten the feedback loop to know whether we're moving in the right direction. But a lot of the time, making progress toward optimizing UX can totally feel like shooting in the dark. Why is it so hard to optimize UX? Well, in order to find the right message for users, you have to subject yourself to the painstakingly iterative trial and error process of creating and testing variations. A lot of the times, these changes can look like really small tweaks to copy, one-line code changes. The variations are endless. In addition, A/B testing pipelines can be super clunky. So you can wait to gather the data, and then once you get the data, the signal is still not clear, and you're not sure how to proceed. All the while, sometimes the product is changing, or sometimes we need the feedback from the users in the first place to figure out what the product is. How do we use AI agents to improve this process? Our product uses agents to automate those small refinements, the one-line code changes, and push those to production and review the data in real time. This frees up resources for teams to focus on the big picture problems and improvements. Meanwhile, our agents are reviewing the data and refining the A/B testing to maximize the value of information that can be gained from user behavior from these changes.
It's not this one. So for our current workflow, we have a pretty easy integration with your GitHub that you can just increment it to your GitHub, choose whatever repo that you want that has some sort of front end. We have one agent that's going to look for either your landing page or the dashboard that the users have the most integration with. And then another agent is going to try to analyze it and try to make like very small integrations to those pages. Or if you're already in the data pipeline, we can also use previous feedbacks from the user interactions to give that agent to make like better integrations depending on how previous interactions worked. And then after that agent is done, it's going to make a branch into just to your repo. And another agent can traffic user data, again, based on previous recordings of how the users were interacting with those components. It's going to traffic like a very small percentage of the user there to that new variant that we made. And it's going to keep doing that until you make better and better variants for your product.
So we're currently building out capabilities to solve for the metrics that matter the most. So our customers can customize what they want to solve for to maximize the value of real-time user feedback. LLMs and user feedback are a match made in heaven. This also means that UX engineers don't have to babysit their features because this process is run by agents. So again, teams can focus on the metrics that matter the most while working on the big picture improvements and decisions. All the while, our agents are analyzing the user data, providing a refined approach to A/B testing, and introducing a soft launch of updates and changes, so that as more and more users respond positively to these changes, they're shown to more and more users, and you can push changes to production safely and with confidence. This is a massive improvement over the current process, because who hasn't had the experience of pushing to production and it doesn't turn out how you were hoping it would? So our agent does 3 things. It takes care of the busy work and those incremental changes. It frees up resources for teams to focus on the big picture. And it improves on the current A/B process by incrementalizing it and refining it. So you can push code to production more confidently, more safely, and reduce that risk. Thank you. And if you scan this QR code, it'll take you to our website, so you can check it out.
Awesome. Thanks to Laurie, Salim, and what was the last one? Armin. Thanks so much, guys. Fun fact, they just met 10 days ago. And they've been just spamming the hackathons and been winning quite a lot of them. So very, very strong team. The next team is TabRL. I think Aditya I've met quite a few times at a number of AIUs, right? This is not your first one. Yeah. I think the other interesting thing about this is just the sandboxing that you guys do. It's like really stands out. Like that's what every single judge that I talked to also was commenting on. So take it away. Cool.
Hi, guys. So I'm Richa. I'm a physicist, and this is my friend Aditya, and he's an AI engineer. So we met at the hackathon this Saturday, and I was very frustrated about certain things. And I pitched something to him, and I was like, we are having this entire automation of full-stack SWE platforms where we have bold, lovable, completely doing really complex back-end and front-end in the browser. But we have nothing like that for robotics. We have nothing like that to simulate the reality. And so the idea was born. Your browser is all you need, TabRL. So we are here to present to you what we did on the hackathon. Next slide, please. All right, so we're using Mujika. We're using Mujika, which is a genius platform built by and acquired by Google DeepMind. What it does, it helps you to embed all the physical attributes in the robots. And so you can see this really nifty, really cute robots falling under the gravity. It's basically, it just shows you how these attributes that are only present in the physical world are all embedded in these frames. But the problem is it's all siloed in Python. It's extremely fragmented, the way this framework works. And it's kind of it's only left up to robotists to figure out how to generate thousands and thousands of data points and simulations to invent the future. But we are changing that. What we're building is we're building a simulator that allows you to take a prompt, generates different policies of RL, and basically gives this really, really controlled parametrically and sophisticated simulations. So in a second, we'll switch to. All right, so here we are. We good?
Yeah, sorry about that.
All right.
So this is what we built, actually. We built an entire RL environment that runs in your browser. In the beginning, we actually built it in the browser, but then in order to make it work, the whole idea is beginners like us can just pick a model in a 3D environment like Richard just showed you. You can, we picked a robot dog, and we told the dog, hey, you're a great dog. Show me how well you can, stick out your paw. I love you. Do you want a treat, right? And the way RL works is the robot throws off observations, and you need to take those observations, and you need to craft a custom reward function. And usually these reward functions are only written by specialists. But what we've done here is we've used the latest foundation models to democratize that. So you just put in your prompt, and O3, Opus, and Gemini all create 3 different reward functions each. And as you can see, these are pretty complicated bits of code. They have all these quaternions, different rewards for height. What we asked the robot to do is to sit and stick its paw out. Like, that's a pretty complex set of rewards. Like, I wouldn't even know where to get started with the math, right? But foundation models, they just spit that stuff out. And then once we actually go through and generate that, we actually have these sandboxes, which are kindly hosted by Modal, where we actually go ahead and start training all these, fine-tuning. And what we end up with is we actually end up with reinforcement learning, and it's just like magic. So normally you have to be like a researcher, you have to know all this stuff, but I just typed in a prompt, my model started training, I had 9 different ones, I'm showing you one from each provider. I think this is the one from Claude. As you can see, I didn't give it enough steps, reinforcement learning takes time, so it didn't like get the, start to converge or whatever, but some of the others ones from Google and OpenAI did. And yeah, long story short, that's our project. And now you can do it in your browser. I'm really excited to bring this to the whole world, get everybody start training the robots on their own machines. Thanks.
Awesome.
Yep.
So overall, so closing in, the future is incredibly bright. And if you want to reach the generalized intelligence in these machines, we have to optimize for everything. Thank you, guys.
That's I think the next speaker and I think the last finalist that we have. I have a personal relationship with because he was our first international guest on Latent Space. We did it in Singapore, I think. And he's been training non-subquadratic, non-attention models for a while. Are you plugged in?
I am.
Okay. And he was like, he was like in the middle of like some very important meetings, but he said, I'm just going to hack in this hackathon and show you what I can do with my model. So I thought it was like pretty impressive and wanted to at least, it was exciting to at least see him like emerge with something that you can use today. Hopefully this works because he wants to demo instead of slides. Okay. Awesome. Take it away. We can't hear you. Hang on. Your mic is not on.
Test. All right. How are you measuring reliability? Are your agents following your specification? That's the question I'm asking. A bit of background, like Sean gave, is I'm Eugene. And firstly, I'm going to say I'm sorry, because my team is working to obsolete all the AI models you see today. That's just what we are working on. Like, you may have seen some of my latest work, such as the Quirky 72B, where we built the world's largest model without transformer attention. So this is a 72 billion parameter model that's 1,000x cheaper in inference cost and performs the same based on the RWKV architecture. We also apply this technology to accelerate transformer models. But that's my background, not what I did in the hackathon, to be clear. So that's not really that important for this case. Back to the topic, the boring topic, which is reliability. And this may sound weird, because my hot take is scaling is dead, and we're not going to solve reliability with scaling. Because to me, right, this is a billion-dollar money pit that we are throwing to scale. And despite that, some of the richest companies on Earth is saying, for example, the DeepMind founder CEO is saying that it may take up to 10 years to solve the compound AI agent error problem. Yan LeCun say we need a new AI architecture to solve the paradigm in robotics and AI. If you think that they are GPU poor, maybe don't take them seriously. But furthermore, this is also further reinforced by what we see in production, where 90% of all AI projects fail to reach the bar required for enterprises. So why does this happen? Really, the problem, if you think about it, is reliability. Because if you think about it, right, these AI models are already capable of orbital physics math. How many of us can do orbital physics math from Earth to Mars? You have a 1 in 30 chance of you answering correct. But would you use a delivery app that says it will arrive 45% of the time? Like, think about it. Like, you can do your order, and then maybe it orders 10 pizza instead of 1, or the pizza never arrived, and then you're spending your time calling customer support, cleaning up the mess. That is what the best AI agents right now are doing, or even the best AI model. And that's the struggle that we are having with. And here's what nobody is talking enough about, in my opinion. Most companies don't need an AI that can do PhD math. What they really want is an AI that can do the boring things in life, like booking a flight, sending an email, or processing an invoice without failure every single time. Scaling is not going to fix this, and in our opinion, a new architecture is needed, and that's something that I can spend an hour talking, but I'll put it aside. Because what we did instead is just to show it. Most recently, our latest action hour model hit 65% on real eval. This model will not solve a PhD math equation, but it will do real-world web tasks such as shopping on Amazon.com, DoorDash, and etc. And that jump is more than half compared to Claude or Gemini, which is at 45 percentile. So for those who are asking how it looks like, of course we made an MCP demo for it. So if you look at this, I'm just going to run the MCP and pray to the Wi-Fi gods. So for those who are not familiar with Client is awesome because it can run everything in your agent, in your IDE, and I'm just going to tell it to connect to my local MCP server, which I have already set it up. Let me double check. OK, it's there. OK. And then this will then do the task of searching up for a book for AI engineering on Amazon.com if my Wi-Fi is working as planned. OK, so you see it goes there, and it starts to run it. I'm going to say up front, this is not a fast model. It's going to take 5 minutes to run. So I'm going to, but you can see like slowly filling up behind the scenes. So to speed it up, I have prepared a recording in advance to just show it in simultaneous. Okay, so this is the same thing. You can see it. Going to fast forward a bit. Yeah. So this is boring, but the point here is actually about reliability. And so how do we measure reliability? It's about running it as many times as you can. So what I'm going to do simultaneously is I'm going to run this on model. So part of the real eval, and shout out to Div and AGI Inc. who did all of this, is that they provide an endpoint for us to be able to run it and against a leaderboard. So I'm just going to run it, and then I'm just launching everything live, and it's going to start filling up the scoreboard here. Once again, don't have time to run the whole thing, so I'm just going to go to the final result, 65%. And to me, this is not enough. We need to get 99, and that's what I'm building towards. And to me, I find it more frustrating that if anything, our existing best model can't even do better than a coin flip. And that reliability is important because it's what's going to unlock all of your value for all you AI engineers. This is a billion-dollar market. You want to make an AI agent that's reliable in law, accounting, ordering books. That's what is going to make you money. And that's what we need, not a PhD lawyer. Yeah. OK, that's about it. I think I'm out of time, so I'm just going to jump straight into, yeah, we have a wait list. Thank you.
All right. How about we hear it for all of our hackathon finalists? Very exciting. So as mentioned, now all of you are going to be the judges. So can I get next slide, actually? So you're going to be the judges. So typically this is done by applause, but that is so pre-GPT. So let's go by woos. So we're going to do a practice round with all of you in the audience. I want you to go, woo! Woo! 1, 2, 3.
Nice.
We only have to do one practice round. Great work, great work. OK, so you ready? I want you to write down who your top team is. I only want you to woo for that team. I'm going to get ChatGPT Advanced Voice Mode ready to analyze the results. Hey, ChatGPT, I'm at the AI Engineer World's Fair, and we are doing the judging of the top 3 hackathon finalists. And now, we need your help. We don't have Wi-Fi, so what we're going to do is we're going to, I don't know why I'm talking to it like a kid. We're going to actually do it by applause. So we have 3 teams. I'm going to say Team 1, Team 2, Team 3. And each of them are going to get applause from the audience. I want you to analyze this, whether actual data measurements that you have or just perceived, and tell us who the winner is, who number 1 is, who number 2 is, and who number 3 is. Are you ready?
Absolutely, I'm ready. Let's do it. Go ahead and announce each team, and I'll listen carefully to the applause.
Fuck yeah. All right. Are we ready? Team.
Announce the first team.
Team 1, survival of the feature.
Got it. Listening to the applause applause for Team 1.
We just did it.
All right, I've got a feel for the crowd's reaction for Team 1. Let's move on to Team 2 when you're ready.
Awesome, we're ready, we're going. Team 2, Tab RL.
Closely to Team 2's applause.
It's actually woos, but sure.
I'll listen out for those woos too. Whenever you're ready for Team 2.
Team 3, Featherless Action R1.
Wow.
Applause for Team 3.
You failed, I'm sorry. I'm calling Claude.
No, we have human evaluators in the back who will help
we knew
us.
this was a gimmick.
Yeah.
It was a fun gimmick.
But no, thank you for
you.
helping us at least give some sense of sort of audience participation and favorite. Like it's meant to be a bit of a people's choice type of thing. So yeah. Nice work. Cool.
Okay.
Okay, so we're going to get the results later. I think, Ben, you can talk to them if you need. But we're going to give out some prizes. I don't know if the Trace Loop team is still around. I think I saw some of them going out there. But basically, we want to just recognize people who've been like really pulling out their stops for the event. We got Best Swag, which is won by Trace Loop for their keyboard. We got Best Dressed, won by Madison from Base 10. I don't know if any of the Base 10 folks here, but anyone got the artificially intelligent shirt? Yeah, that really fun swag. And best tweet from Dylan Patel, basically talking about a relationship that was actually started here like 1 year ago, which is pretty sweet. Like that is actually heartwarming. We try to get people hired, but we never promise any partners.
AI Engineer World's Fair, where love happens.
Yeah, I think that is AI Engineer Love Fair, which is a very high bar. Okay, so then the big categories that we really wanted to hand out. Obviously, unfortunately, like a lot of people like leave after your talk, so we can't really hand it out. But obviously, come and claim it afterwards if you want. Every track has best speakers. So you all voted. We actually, like really care about giving recognition to the speakers who work so hard in their talks and sharing their experience. Thank you to all these tracks. Can I get a round of applause for MCP, David Kramer, Alex Duffy, Devansh Tandon, Daniel Shalev, Harrison Chase, Dylan Patel, Brooke Hopkins, Brian Belfer, Itamar Friedman, Dennis Ninkov, Boris Cherny, Nathan Lambert, Rafal, Vitor, Daniel, Rita, Renee, John, Sharif, Nikhil, and Paul. I think the retrieval one is wrong. Retrieval one is actually Will Brick, who actually got his prize earlier as well. So those are the individual track speakers. Actually, can I get those picture frames on there? We actually spent some time putting together the sort of track speaker prize. Just one. Thank you. And it's like really nice and printed, and we Gibified everything, so it's kind of cool to see. So yeah, come and get your track speaker award if you are still around, and obviously we can send it to you if you're not. Okay, overall best speaker, we have a runner-up and also an overall winner. I think it's like relatively obvious, and I think like something that we wanted to recognize as well for our keynoters. Where is the? Oh, okay. This is not refreshed. If someone can go back.
Can we go back 2 slides?
Yeah, runner up. George, are you here from artificial analysis?
Let's hear it for the runner-up. George,
okay.
Artificial analysis.
Probably they're all in the hallway track. So artificial analysis worked really, really hard in their talk. They actually did this whole 50-page report. I was like, George, you have 20 minutes. You can't really do this. But they worked super hard on that, and I think it's something that we want to recognize as well. The winner, though, it was by far the consensus on the people that I talked to and the committee and all that. The winner is our third-time keynote speaker. He went line dancing, so he's not here today. He's not here to receive the award. But I'm actually going to get Laurie. Laurie, you're actually going to receive the award on behalf of him. It's Simon Willison, everyone. So, no, Laurie Voss. Laurie Voss.
We have 2 Lauries.
Sorry, Laurie. So. She's also called Laurie. Laurie, you're waiting for the next one. So I don't know. You can present the best speaker.
Yeah,
Simon nominated Laurie because they worked together on Django. When did you work together?
We worked together at Yahoo in 2005.
Yahoo. Yeah. So
The Few, the Proud.
The Few, the Proud. Yahoo Pipes is still a pipe dream for a lot of people. But thank you for accepting the award on Simon's behalf. Thank you.
Thank you, Laurie.
Okay. Hackathon.
Hackathon.
You have the second best and the runner-up and the best?
I was relying on ChatGPT. I don't know.
Yeah.
Kind of failed me.
Yeah, okay.
So do we want to go by perception?
Yeah.
Should we do woos again?
No.
The audience is thinning.
Yes.
They're running impatient. I think it's probably team 3, right?
Okay. Well, so we have the runner-up.
Okay.
Of the hackathon. I actually don't know where the sort of prize. Yeah, there we go.
Okay.
So hackathon runner-up. I think it's like fairly pretty evident in my mind. It would be the feature team. So this other Laurie, you can come up with your team and Amir.
Come on up. What's the team's
come on
name?
up. Yes. So
you can come for real this time.
Yes, you can come.
Yes.
Okay. I'm sorry.
Sorry about that.
There you go. Congrats.
Thank you.
Congrats.
Could I?
Thank you. Oh yeah, you should all definitely.
Thank you, guys.
Congrats, everyone.
Pose for a photo.
Yeah.
Look at me right over here. Thank you.
Thanks.
Thank you.
And our website is survivalofthefeature.com.
Survivalofthefeature.
Survivalofthefeature.com.
Please try it.
Yeah.
Very good.
And I think the winner, just decided by votes and applause earlier, is Eugene from Featherless R1.
It's here for Eugene.
Where's Eugene?
Here he comes.
Eugene gets one of the big ones. Oh my God, Eugene, you're so excited. Featherless has been grinding away for a long time, and I can't believe you did this in a hackathon.
Dude, I also like to add that I wasn't alone. Rochelle, who couldn't be here, took part in the hackathon as well.
Yeah.
And worked on it with me.
Okay. Well, this is yours. Thank you for taking part.
Yeah.
Yeah. Why don't you stand in the middle?
Okay.
Awesome. Congrats. That's it.
All right, we got to go to thanks. All right, now I got to do one more thing. It's just a quick thanks to everyone who has been part of this. Obviously, to everyone in the audience here. Microsoft, our presenting sponsor. AWS, our Diamond Innovation Partner. Neo4j Braintrust, who curated our evals and Graphite tracks. All of our platinum sponsors and all of our sponsors in the expo and beyond. And of course, Swix, the executive producer and program curator of this event. It takes a hell of a lot of work to do that. Leah McBride, our senior producer, she's been with us since our very first event in October of 2023, and she really helps to make this run. And also our new team members, Melissa Bealey and Scott DeLapp. So many others, including, I wanted to give a special shout out to Vincent Wendy, who is just all of these incredible graphics. Everything you see, that was him. Okay, he didn't do the animation. I'll get to them in a minute, but he did all that. So incredible working with him. VCI events. This is VCI, and they've been running everything on this floor in Golden Gate Ballroom level. Freeman, all the graphics you see were them. Art and display. That beautiful expo in there. That's like a little Santa's village. I mean, you feel like you're in a little mini city there. Incredible. That was them. Encore helped to run AV up in second floor. Local 16 helps to operate everything. So really big thanks to them. They've all been so incredible. Motion Agency actually did all of the motion graphics you see here. They're based in Asia, but they worked some of the hours in Pacific for some last minute stuff. Suno, I love working with Suno. It doesn't miss every time. They produce music just from text. The Marriott Marquis, thank you so much. Max Video Productions for B-roll, Randall for photography, Brad Westfall and Swix, our web developer. Come on, how is he actually doing? And Haley Holmes, our incredible show caller. Thank you so much. And all the speakers, of course, they've been so incredible. Anyone in the yellow shirt you saw is a volunteer. They come here just to help out and be part of the event and the excitement, so we thank all of them. We can't run it without you all, so thank you so much. And then lastly, I'd like to welcome on stage the absolutely hilarious, absolutely wonderful Laurie Voss, our MC. Thank you so much. Can we give him a big round of applause, everyone? I keep telling him this, but I keep telling everyone this, but I keep telling you this, but your intro was, like, his jokes, did his jokes land or what? Like, they were actually really good. They weren't just dad jokes. So I really appreciate that, and thank you so much. So with that, that should do it for the show. Thank you all for staying, the last few of you who stayed for this. Really appreciate it. Thank you so much for coming out.